How about you can focus on that? I can handle the if you want. Frederick, okay. Frederick?
It's gonna be fun.
Good morning, everyone. Thank you for showing up so early. You want it higher? Is that what you're saying? Higher, okay. All right. So welcome back. Today we have a group of sessions. Before that, we have a few announcements. The first announcement is that the PC elections nominations will close today at 3:30 p.m. So please remember to send it in. And also the second announcement is that the deadline to register to attend and vote in the NCC general meeting is Wednesday at 2 p.m. Okay? And with that, we will start with our first session. I'd like to welcome Thomas Vible, or Vible, sorry, Vible from Flex Topic. Please go ahead.
Perfect. Thank you very much, Osama. Great. Yeah, good morning, everyone. I'm your yoga instructor for this morning session. So we do some morning yoga to wake up. No, actually, I'm not the yoga instructor. I'm pretty sure every one of you already made that experience. You meet someone, you have a great conversation about a certain topic, and then later on, you think, hey, this is something I want to know more about. And then you dig into that topic and you figure out, hey, that's not so trivial, not so easy, but I really want to know the innards and why is this so critical, important, whatever. Actually, this happened to me last year at the RIPE meeting in Lisbon. I had a great conversation with Blake Willis. Blake is sitting here, he's waving. It was really a gorgeous conversation in the evening at the social. And the topic we were talking about was about coherent transceivers, coherent detection, colorless, all those buzzwords. And I thought, hey, that's something I need to know more about. And I took it back to the company. I'm the CTO and co-founder of Flex Optics and discussed this with our engineering. And we came up with this topic today about, we call it channel mania, because we thought, hey, this coherent detection is something which is also helpful for you guys when you plan and design your network, especially in the area of DWDM beyond 400 gig and above. And yeah, for the next 25 minutes, I will show you a little bit what we discussed there and what we figured out, and we did some research on it. And it turned out at the beginning it was a real brain fuck, but then later on it turned to something else. Okay, first of all, a transceiver in general, I'm pretty sure you're familiar with those components so far in the last years since you know me. The inside is straightforward. We have a transmitter and a receiver, those nice golden boxes. And there is a digital signal processor, which basically does a couple of functions, modulation, forward error correction, etc. So there is a little bit of electronic involved. But now let's focus on those two golden boxes where all the magic is going to happen. And we start first with the transmitter. In general, when we look a little bit back in history, a transmitter, we all rely today on lasers. But the lasers have been around for a couple of decades, so around. In the 60s, the first lasers were evolving. But those were big boxes, needed a lot of power and especially a lot of cooling to keep the frequency stable. And the interesting ones, which are important for us in telecommunication, have been developed in the 70s because these lasers were capable to operate at room temperature. I assume you don't want to cool your router with liquid nitrogen or something, so you want to use fans or in the upcoming years maybe some water. So the goal was to make them small, to make them efficient, and operate them at a proper temperature. And for sure to make them reliable and last for a long time. And keep the wavelength very stable, because that's one main characteristic of a laser. So when we look now at different type of lasers, we have seen in the last 15, 20 years coming up for transceivers, for transmitting. On the top one, the purple one, is a typical spectrum of an LED. It's roughly 100 nanometer wide, this spectrum, and it's a very broad curve. Now with 10 gig, the Fabry-Pero laser, the very characteristics are those two peaks next to the center peak. And there the line width got down to 10 nanometers already. And with the distributed feedback laser, the green one on the lower one, we got down to 1 nanometer, really important for 100 gig and so on. But when we go beyond 100 gig, let's say 400 or 800 gig, and especially when we want to do some coherent transmission, the external cavity laser is really important. And we don't talk in nanometers any longer, because the line width is so narrow. We are talking now in frequency. So it's only a frequency of 1 megahertz, which is very, very sharp. Compare it now with the 125 gigahertz of the distributed feedback laser. This is like a factor of 1,250. That's very, very narrow. But again, when we also look how you want to achieve more traffic or more bandwidth within your fiber, there are basically two approaches. When we look at the top one, this is the typical way how we encode content or how you do transmission. So you have an optical carrier in the middle, and next to the optical carrier, we have the optical bandwidth where you put all the information content in there. And there are two ways to separate this. On the left side, this is the typical approach we have done so far in DWDM or in CWDM networks. We separated the different colors. We sliced them down, and we used filters to separate all those colors. The drawback on this separation is, and the more you slice down, you will always have a lost spectrum which you can't use, especially when the filters overlap. So there is always lost spectrum or lost information content which you actually could use, but you can't. So the other approach is, well, just increase the overall information content you feed into one optical carrier, just make it broader, use more bandwidth. And that's actually then later on done with coherent transmission. Now, that's so far the easy part. Now let's get a little bit back where we have been last year. I might talk about complex numbers and in general coherent transmission. We have to look again a little bit in the modulation. The traditional approach is on-off keying, quite simple and straightforward. We have light, we turn it on, and in the middle you see a receiver, a diode. When this diode gets hit by light, it's opening up, current is going through, we get a 1. And when there is no light, the diode is closing, and we get a 0. That's basically how on-off keying is working in traditional up to 100 gig, let's say, or 40 gig, how we detect a signal. But when we look inside of our 0 and 1 light level, there is way more information in there. We have phase information, we have frequency information, but for the diode itself, this is transparent. It can't detect this. And that's actually information we want to pull out, which makes coherent to take care of all the light parameters, so efficient actually. So we want to pull that now out. And for that, we have to go back again to the constellation diagram, this lovely 16-dot diagram here. And no worries, I don't dig too much into details, but we have those 16 constellation points, and each point can encode up to 4 bits in general. The great thing about those constellation points is when you look at the diagram, they are located somehow in space. So they also have a direction and a position, or what we call a phase information, because when we remember our high school time, when you have this circle where we have 360 degrees, so we can actually identify every single dot with its phase, with this angle where it's located. And looking now on the right side, when we pick out two dots in particular, there are two approaches to identify the position of such a dot. Either we use the phase information, the angle, and the vector in general. So with the angle and the vector, we can identify the dot. Or, again, this is a little bit geometry. We use the I and Q component, or in other words, the X and Y, to calculate a rectangular triangle. And the Q and I component, that's something we're going to look later on, which is basically the foundation for the DSP to calculate then the position of that dot. Okay, so let's move on. So how does this receiver in general look like? Because I said at the beginning, the coherent receiver, or also balanced receiver, is something which is very specific and very important for the coherent detection. But let's start easy. On the top one, you see a single-ended receiver, and how is the setup done? The central component is in the middle. It's the optical coupler. The optical coupler is quite straightforward. It has two ingress ports and two outgress ports, egress ports, basically. So on the incoming ports, we feed in two signals. The first one is our optical carrier with the information content, which we get from the counterpart transmitter. That's everything encoded in there on our with our optical carrier in combination. And then on the second incoming port of the coupler, we also feed in a second signal, the local oscillator. For the local oscillator, I will mention later on some words. But so we feed in both signals into the coupler, and the coupler has a couple of great characteristics. The first one, and which is quite helpful, when we combine two signals, and especially the optical carrier and the local oscillator, they will eliminate themselves, and just the information content or the optical bandwidth is the outcome. And that's something which we put, so combine the orange and the green arrow, we feed that to our receiver diode and can detect it. And we call this a down-converted signal because we got rid of the carrier on very high frequency. We are talking about terahertz, and we're getting down to gigahertz, and that's something we can detect. So that's a single-ended receiver in general, but as you can see, this coupler has two outgoing ports. And when we look now on the balanced solution, on the lower one, it looks pretty much the same. On the incoming ports, we got both signals, we combine it, and then on the outgoing ports, we have now two receiver diodes. And the coupler has another characteristic, because we have phase information in the light, it does a phase shift of the cross port. So the lower port on the left side from the local oscillator is phase shifted by 90 degrees for the upper right port. And the same happens to the optical carrier on the top left port down to the right lower port. It's also phase shifted by 90 degrees. And when we have 2 times 90 degrees of phase shift, we have 180 degrees in total. And the great thing there is, again, back to physics in high school, when you have two waves which are both at the same peak and they overlap, they're going to accelerate them to a higher level. That's pretty amazing. And that's actually happening to our down-converted signal as well. So we boost it up, so it's basically amplified, just because of the fact that we have a phase shift of the local oscillator and the optical carrier. So, and we get more output and less noise, and that's something very, very helpful when we want to detect signals. Okay, the drawback is you need 2 receivers to do this, but this is not the end. Now, we detected so far the signal in general, but as I said at the beginning, we have more information in there, like phase, polarization, and so on in the light, and we also want to gather out that information. And now we're coming back to the I and Q component, which I showed at the constellation diagram, where we do the position of the dot, where does it belong to. And it's pretty straightforward. So we have now, instead of 1 coupler, we have 2 couplers. And on the incoming side, the signal is split up to the I coupler and the Q coupler, the top and the lower one. And the local oscillator, one leg is fed straight into the coupler on the top one, but the lower one is phase shifted by 90 degrees as well, the local oscillator, not the signal itself. And with that, we couple it we can now distinguish now the I and the Q component, and with that we got the phase information out and can identify the dot within the constellation diagram where it belongs to. Okay, we have now 4 receiver diodes, that's important, but we got the I and Q component and get some matrix for the DSP to calculate. And with that, we call this an optical hybrid, and as we have polarization as well. Polarization in general, when you put on sunglasses, we typically, it filters out one polarization direction to filter, to protect your eyes. The same does the transceiver. We take the signal and now we split it with a polarization beam splitter and rotator and split it into 2 optical hybrids, and each optical hybrid identifies one polarization direction. So that's how we basically do it. So in total, we end up with 8 receiver diodes. And here we go. We got phase information, we got polarization out, and we basically did our constellation diagram properly calculated. So with that, we've then figured out, okay, this brainfuck now mainly turned into somehow rocket science. This is getting a very, very interesting. So let's build a rocket with that, because when we have this information now, we can do really, really interesting things looking in our DWDM network again. First of all, a little bit of recap when we look at the optical bandwidth, what we consume so far and what we need. So on the top left diagram, you see a typical curve for a 400 gigabit signal. It consumes roughly 75 gigahertz of optical bandwidth. And looking in the upcoming standards for 800 gig, it's basically double the amount of optical bandwidth. We need 150 gigahertz when we stick to the modulation of dual polarization 16 QAM. And for 1.6 terabit, well, we need roughly 300 gigahertz of optical bandwidth to encode in there. The great thing is they all feed into a filter scheme, and we figured out together also with Blake that the 400 gigahertz is somehow a proper filter to do so, to get all the 75 with 400 gig, 150 gigahertz or even 300 gigahertz with 1.6 terabit into a single filter. And how would that look like? Well, on the left side, you see the traditional approach when you did slice down with a couple of 50 gigahertz filters in your 10 gigabit network so far. So you ended up roughly with the maximum in the C-band of 96 channels, quite a lot. Now, when we look at 400 gigahertz channels, we only get 12 channels in the C-band, which is not a lot, but the great benefit is, well, the insertion loss of such a filter is very, very low. We are talking about roughly 2 dB or 2 decibel for the insertion loss of such a filter. And when we do the math and we can squeeze in 1.6 terabit in a 400 gigahertz slice, well, you end up with roughly 15 terabit for a single pair of fiber, which you can put on those 2 fibers, which is pretty sufficient in these days, I assume so. Well, yeah, and maybe some words about a COTS. That's commercial off the shelf. That's what we say, well, this is commercially available. For sure, you could also say we do a 350 gigahertz filter, but this is way more expensive to produce. The 400 gigahertz is straightforward to build a filter like that, and that's basically was our approach to say, well, that's way sufficient. Yes, for sure, we lose a little bit spectrum, but you will see later on, we're gonna use that anyway. Okay, now coming back to the down-converted signal, because there's some magic happening in there. And also, it's helpful to understand how this down-converted signal has been achieved, because we want to understand the colorless. First of all, there are a couple of approaches. The first one is called heterodyne. So you have the local oscillator on a frequency. In this example, it's 192.79 terahertz and some terahertz. And the optical carrier is running a little bit with an offset of roughly 600 gigahertz offset, or in nanometers, 1,550 nanometers. And when we combine them together, we get a down converted signal because you basically deduct the local oscillator from the optical carrier, the terahertz from the minus the terahertz. You get an intermediate frequency of 622 gigahertz. This is just an example, but looking at those figures, this is a very high frequency, and especially when you want to detect this on the electronical path with the diode running at 622 gigahertz is not impossible, but in a small form factor on a transceiver, it's very tricky to detect 622 gigahertz, and it's costly or way too big to do so. So the heterodyne approach is not very helpful. There is another drawback. When we combine in the coupler, the local oscillator together with our optical carrier, we also get a mirror frequency and from in the negative path, and we don't want that mirror frequency because the bigger the intermediate frequency is, the more the probability is way higher that the mirror frequency is going to be in the neighboring channel, and there it will interfere with the signal on the neighboring channel. So we don't want to have the mirror frequency, or we want to have it as close as possible to our actual information content. So that's the second approach, looking at the homodyne vein on the lower one. Well, we say, well, we take the local oscillator being exactly on the same frequency like the optical carrier. And when we deduct them, the numbers, then we get an intermediate frequency of 0 gigahertz, which is awesome. Detecting 0 gigahertz for a diode and also the electronic behind that is very simple and easy. Well, getting such a precise local oscillator matching exactly the optical carrier is not impossible, but it's again costly and not feasible to build into a transceiver. You need something like an OPLL, an optical phase loop, and this is not what you want to build into a transceiver. So now you can imagine there is a third way to do so. It's called the intradyne detection. We say, well, the local oscillator, we bring it as close as possible to the optical carrier, and the mirror frequency within our band of our 75 gigahertz bandwidth, so it doesn't disturb the neighboring channel. And then when we do the calculation for our intermediate frequency, like in this example, the 193.4095 terahertz, and we deduct the optical carrier with 4145, then we get an intermediate frequency of roughly 5 gigahertz. And 5 gigahertz is something very easy to detect, small to build and cheap to build. And even further, so now you can tune your receiver on the electronical path. So you can either tune it into 5 gigahertz, or you say, well, we do some offset going to 4.5 gigahertz. And with that, you have the capability, or the receiver have the capability only to see the signal which you actually wants to see. And that's very, very helpful when we talk about colorless. So the receiver can filter out on an electronical way, let's call it this, which signal is intent for me and which is not part, and can discard a signal which is not intended for him. And with that, we have built a rocket, and we can go to the moon. And beyond the moon, there is a little bit more, and I want to show you what's happening in the universe out there. So we call this the DIY superchannels. On the left side, you still have this traditional approach doing slicing down the 50 gigahertz grid for your on-off keying. You can squeeze that into a 400 gigahertz filter. You can cascade this. For sure, you will have add way more insertion loss. But the interesting part is happening now on the 400 gigahertz filter on the right side. Instead of just feeding in one 400 gigabit with 75 gigahertz, you can feed in 4 of those channels without separating with a filter. You basically, you can put them into one filter, you can add 4 signals, because your receiver will grab the signal which is intended for him, because you can tune the receiver to the desired color, in this example, for the blue or for the green. And how do you want to separate? Again, later on a physical layer, well, pretty simple, you use a splitter. Splitter known from the PON environment, it's a very straightforward device. You feed in one signal and it distributes the same signal to all 4 legs in this example. And you see this on the lower path where we have 4 different transceivers or coherent transceivers, and the blue coherent transceiver gets light of all 4 colors, but he only picks the blue light because he's tuned to that color or to that frequency. And the same happens to the green one. The green transceiver or receiver only grabs the green information content, and yellow and red, so on as well. And on the top part, well, this would be the traditional approach where we not use splitters, where we use filters to separate the different frequencies, but the lower one is quite helpful. For sure, there are limitations for that. You should do this only on your own network, on your own fiber, because you distribute the signal to all outgoing ports, and maybe you don't want that your competitor or whatever gets the signal from, so you don't want the green one showing up at the port of the blue one, for example. And it's quite helpful as we're talking now in frequencies, and when you talk to the radio guys, as we have a shared media behind the splitter, it's better to make a frequency plan, because then you know on which leg, which frequency is popping out, where you can tune in your receiver. And there are other ideas where you can even build redundancy, for example. When you think on the left side, you have your core network with one transmitter or one transceiver in general, and behind the splitter, you have 2 edge routers, as an example. So we have the blue edge router and the green one, and the blue one is tuned to the blue frequency, and the green one is more on idle and is not connected on the blue wavelength. But in the case that the blue one is failing or having an issue and it's dropping the link, you can tune in the green receiver into the blue color. That's possible. You can just change the tuning on the command line interface, and then the green receiver gets actually the blue one and can pull out the information from the blue path in this example. And with that, I'm almost through. For me, this research was very, very interesting because it opened up a whole new universe when you design a DWDM network, because so far people were thinking in filters, and now with splitters also in place, this makes it way more flexible, or in other words, you had to build your own flex grid basically with that splitter in a small way, internally, we also call this the ROADM for the poor people. This is a very efficient way to do it. An important finding as well was for ourselves, do not think any longer in channel numbers, especially when it comes to ITU numbering. It's really a mess. It don't fit to the coherent transmission. Think in terahertz and gigahertz. It's way more helpful when you talk to your counterpart in terahertz and gigahertz and not in nanometers any longer, or even the weird channel numbers. And with that, I'm pretty much through. And for the future also, what we see now for the next thing coming up, we see also liquid-cooled transceivers, where the liquid is going not only on the main board of the router or switch, but also the liquid is going through the transceiver itself. They are coming up now with 12.8 terabit and with some interesting fancy connectors for the incoming and outgoing liquid port to actually get the heat out of those transceivers. They are rated up to 40, 50 watts for a transceiver, and the current idea is to call them XPO. And with that, I'm very happy to have been here, and let's see what's happening tonight on the next social. I'm really open for discussion. Thank you very much.
See, we have our first question, name and affiliation. Mike, please.
Very much. This is Blake Willis speaking for myself. This has been really helpful and an excellent discussion. I wanted to ask you if you had any other customers using MUX, fixed MUXes with a channel bandwidth higher than 100 gigahertz, or if I'm the only geek out there doing this.
Thank you very much, Blake, for the question. so far what we see when we talk to customers, when they talk to their traditional WDM provider or transmission systems, they are currently going up to 200 gigahertz. But so far, the 400 gigahertz solution we haven't seen in a broad set. So the state of the art is 200, 250 somehow. Yeah.
That's great. I'm hoping that 300 is the limit and they'll just stop with 1.6T there so that we don't have to keep getting bigger and bigger.
Yeah.
Thanks. This is great.
Thank you very much.
Any more questions? Thank you, Thomas.
Welcome. Thank you, Osama.
Next, we have Salim Batti. Please come up to the stage from University of St. Andrews.
Right. Well, good morning to you all. My name is Salim. I work at the University of St. Andrews. And I'm going to be talking to you today about some work we've been doing to change the way addressing is used to try and reduce some of the exposure of privacy you might get through looking at address values. This work was originally started with my PhD student, Gregor Hayward, and the ongoing work is with Rod Grimes and Alistair Woodman with support from the ICANN grant program. Okay, so what problem am I trying to solve? So a bit of background, which I can imagine lots of people are familiar with. So for a long time now, over 20 years, we've had guidance if we're writing new protocols from the ITF on writing text about security considerations. But really, I think it wasn't until the Snowden leaks in the middle of 2013 that people started getting more serious about privacy. And at that time, it was flagged that perhaps address values that you can't hide as they go across the network can reveal something about users. So there's the potential to know about a user or a node's identity and its topological location from looking at these address values. So there are some potential threats here from address visibility. You can correlate flows, so multiple flows with, for example, the same source address you can assume are coming from the same sender, and that helps you perhaps build up a profile of the kind of things that that user is doing. Also, if there are some bits in the address value that get reused, as say your phone, a mobile node, connect at different points in the network, well, those bits, if they don't change, then you can track a user. So there's this general problem of identifying and at least topological location privacy with respect to what happens with address values. Where are we today? Well, we do have guidance now from the ITF about putting privacy consideration text into RFCs, which is great. Of course, a lot of content is protected, so that is good. The privacy of the content, at least, is protected. And there is some work on trying to protect the address values as well. So RFC 8981 has some specification on how to generate temporary address values that last from between a few hours to a couple of days in use, the default being a day. But nevertheless, if you do follow that default for that day, you still have that same exposure. Okay, you can still have flow correlation for anybody using the same address using that day. You still have the potential to identify people's identity and their topological location. Now, you may say, well, that's okay, I'll just use my VPN provider. They can take care of all that for me. I don't use my real address, if you like. But it's a case of, can you really trust your VPN provider? If you can, great, stop reading now and you're done. But if you think you would like an option that's different, then this is what we're working on with my team at St. Andrews. So we're really looking at how you can change packet addressing to improve privacy, but of course we want to do that without impacting routing and forwarding, without having to re-engineer the applications. And what we're really aiming for is another option, to have a different model, an end-to-end model, so your trust domain just is the sender and receiver. You don't have to rely on, let's say, a VPN provider to try and give you this identity and location privacy. Okay, so how have we gone about this? Well, the work we're doing is part of a bigger project that I've been working on for a while. So I'm not going to go through all of that, but it's called the Identifier Locator Network Protocol, and it's a different approach to networking by changing the way that addressing works. And at the moment, we're building that directly on IPv6. So if you like, you can think of it as a superset of IP version 6. It's IP version 6 with a few bits added on. So how does this work? So this is kind of ILNP in a nutshell, but also specific to what happens with the privacy features we've been working on. So if you look at how addressing is used in the communication stack today, you have an IP address. An IP address is assigned to an interface. It's used at the network layer for routing and forwarding. And of course, it forms part of the end system state for a transport protocol. Okay. So that means you have this entanglement between the layers, and it means, for example, a transport flow is fixed to a particular network, and so you have this binding between the transport flow and the address in a way that exposes this identity and topological location. So it'd be nice to try and break that so that you can still have some end-to-end state for the transport protocol, but you can have the forwarding state related to how the packet gets across the network separate from that, and that's what ILNP does. So ILNP introduces some new data types for addressing. So instead of having an address, it has an identifier locator vector, and it consists of two data types: an identifier, a node identifier at the transport layer, and this is for a node as a whole. It isn't attached to a particular interface. And then it has a locator, and I've labeled this a locator 64, L64. You'll see later that it's a 64-bit value when used with IPv6, so that's why that label is there at the moment. What we're aiming for is for this node identity to be stable for the duration of a single transport layer flow. And that means the end-to-end state stays stable for the duration of the flow, so the transport layer is happy. Okay. And the locator, we're aiming to have semantically aligned whatever the network is expecting to be able to forward the packets properly. Okay. And then we have a dynamic binding between the node identifier and the locator. In fact, it can be done per packet if you want. And we have a dynamic binding between a locator and a particular interface. And of course, that all happens at the end system. You don't see that. The user does not see that at all. Okay, so this is what it looks like in terms of transport state. Here are two nodes, X and Y, and they've got some processes running. And if you're using IP, you have addresses AX and AY. And if you look at the TCP state, it looks like this. At X, you have the local and remote port numbers. And then as part of the state, you have the local and remote addresses. So if you like, the forwarding state, what the network needs in order to forward those TCP segments is part of the end system state. Okay, so you have to keep that stable, but at the same time, you're exposing some identity and location information. So what happens with ILNP is you have identities, node identifiers, and a node can have many of these at any one time, and you have locators. And again, a node can have many of these at any one time, and the locators are learnt dynamically. Okay. The node identifier has to stay stable for a transport flow, as I've said, but the locator, you can change as you like for a flow. In the middle of a flow, you could change it if you wanted for every packet. So the end system state looks like this for ILNP. The transport layer state still has a stable value to which it can bind its state at the endpoints, which is the identifier. And then there's a dynamic binding to the forwarding state, the locator value, which the network needs in order to get packets across the network. Okay, so how do these new data types get across the network? How does this fit into IPv6? Well, as good fortune would have it, you can just use the existing address space within IPv6. And in this diagram in the top, we have the normal layout of a global unicast address for IPv6. And in the bottom of that diagram, we have what an identifier locator vector looks like for ILNP. So this is the combination of a locator and an identifier. The top 64 bits have the exact same syntax and semantics as an address prefix. So routers are happy. That's what they need to get your packets across the network. So they're not worried at all. The lower 64 bits, however, are not assigned to a particular interface. They're used differently at the end system, and that's through modified code in the stack, and that's what we've been working on at the end systems. Okay, so we're really using the IPv6 address field to carry the values for these new data types, and the bindings between them change at the end systems to reduce this exposure of privacy. In terms of what the network sees, if you were to put those addresses into packets, well, on the left is the typical view that an IPv6 router has of a packet, and that hasn't changed. It's just going to use the top 64 bits in the destination address to forward the packet, and that is the same. But when that packet gets to the ILNP system, it treats those address fields differently. Okay, so that's how you have compatibility with what's happening in the network, but you can change what's happening at the end systems to change the way that those address bits are used. A couple of other features are required in the protocol to make it work. So a couple of protocol features, I'm not going to spend too much time on them, but you need to be able to tell the difference between a normal IPv6 packet and an ILNP packet. So there is an extension header in IPv6, a destination option header. It's 8 bytes, and that goes into every ILNP packet, so that a receiver knows this is an ILNP packet, not an IPv6 packet. So it identifies the ILNP packet. It also provides some protection for some off-path attacks. That's a subject for a different talk, but its main purpose is really for us there to say this is an ILNP packet. That 8-bit value in there, the nonce value, is a pseudo-random generated value, which is unique for every flow. And in order that two communicating parties can synchronize on the locators they're using, you need a handshake. So we come to the control plane and we have an ICMPv6 message. Very simple handshake. It's called a locator update. When node A is talking to node B and it has a new set of locator values it wants to use, it just sends those values in a message across to node B and tells it, here are the locators I'm using now. So A and B can synchronize on the locator values they're using, and so B knows which sources to expect the packets to come from when they're coming from node A. Okay. So those are all the bits and pieces that you need, and a little bit of explanation of the plumbing. Let's have a look at it actually working. So this is on a lab test bed is what you're going to see. I've got a couple of videos coming up, but we have tried this from IETF hackathons from different destinations around the world back to St Andrews, which is just about 60 kilometers north from here, and things do seem to work. But for the purposes of this video, I've just used a lab test bed that I have. This is what the test bed looks like. You have two nodes, H1 and H2. They're running the ILNP implementation over IPv6 on FreeBSD 14. And I'm going to show you two experiments. Both experiments use standard IPv6 applications, so they haven't been re-engineered, they're just standard IPv6 binaries. Node 2, H2 doesn't do anything. It just sits there, it's going to act as the receiver, it's on a different IPv6 network to node 1. For the first experiment, we're going to keep the locator value, the address prefix the same, but we're going to use ephemeral node IDs. We're basically going to generate a new, fresh node ID for every single flow that we generate. We're going to generate 8 flows, just a TCP handshake, so you can see that a new address effectively is used for each one. Then just close the connection. So netcat is going to be used to connect to the SSH server, netcat running on host 1, the SSH server running on host 2, and you'll see 8 connections go up. And then I do a TCP dump, I look at the PCAP file, I look at the source addresses, and you'll see there are different addresses. This gives you identity privacy. You can't now do flow correlation as easily because each address is effectively different. Yes, in this case, you can see that they've all come from the same network. So with some other information, you might infer that they are from the same node, but just looking at the addresses, you can't tell that at all. And the node ID being different for each flow also protects the user's identity because you don't have one identity for that user. In the second experiment, I'm going to use iPerf, a tool which I can imagine a lot of you use as well. And in this case, I'm going to keep the lower 64 bits the same. Again, this is for the ease of the demonstration. So the lower 64 bits will retain the value 1, A, B, C, D. And the locator value will change. So basically, a flow will start up. After it's started up, I'll change the locator value. So it will be transmitting over different networks. Now, this is all in a single lab. So I have a /56, which I've then broken down into some subnets. And so you can see that the subnets only differ a little bit by value at that highlighted part of the IPv6 address there. So you'll see 4 networks, 1A, 1B, 1C, 1D. However, in a real scenario, those could be from different providers. So they could be very, very different networks. It doesn't matter. For the purposes of the test bed, these are the values that we have. So this provides location privacy. In fact, the configuration I'm showing you, again, for ease of demonstration, is just one thing you can do, but there's a lot of other things you can do now that the state for forwarding a packet is detached from the identity of the end system state. Okay, so the L64 could change for every packet. You could imagine 2 nodes who out of band have negotiated multiple paths between them, and they have multiple L64s, and they have some sort of sequence of use. Okay, so you might have an equivalent thing that you have with something like frequency hopping spread spectrum, where you go and send packets in a predetermined sequence across different paths. Okay, so that kind of thing now becomes possible. What you'll see is a flow is set up on one interface on a machine that's connected to one network. Then I turn on another one, and it's connected to 2 networks, and the packets go across both of those networks. Then I turn off the first interface, and the packets are only on the second network. Then I turn on a third interface to connect to a third network, and the packets will go across those 2 networks. I turn off the second interface, so the flow is now only on the third network. Then I turn on a fourth interface. It's going across the fourth network, so that the flow has drifted across multiple networks. Okay, and you can do this at whatever granularity of time that you really want to do. Okay, so let's have a look at the first demonstration. So these are just the 2 hosts, host 1 and host 2. And so what I'm going to show you first of all in this video is just the little shell script I use. So this machine has 4 interfaces. In this first experiment, I only use 1. And it's just a simple loop that uses netcat to connect to the SSH server remotely, just waits for 1 second, and then closes down the connection. It only does the TCP handshake. It doesn't do the full SSH handshake. That's enough for it to set up a connection and for us to see the address. On host 2, I'm also going to capture the packets and then look at the PCAP afterwards to show you the addresses. So I start the TCP dump running on host 2. Then I start the script running on host 1. So there are the connections to the SSH server, and that's the script ended. And then I go and I stop the TCP dump, and then I look at the SYN packets, look at the source address, and you can see there are 8 different addresses there, 8 different NID values. Okay, so each of those flows looks like it's come from a different node, even though it's come from the same node. Okay, next experiment is with iPerf. So again, there's a little script, and I'm just going to quickly show you the script in the video. So again, you have 4 interfaces. You only start with 1. So you sleep for 10 seconds after you've started the flow on that one interface. Then you bring up the next interface. You take down the first interface. You wait 10 seconds. You bring up the next interface, and so on. So you get the flow drifting across these different networks. And I'll show you what that looks like in terms of throughput on a graph that's going to come up on the next slide. So again, I want to capture the data at host 2. So I'm going to start a TCP dump just to capture the packets. And there it goes. And then I start the iPerf server on host 2. And then I'll start the iPerf client. Now, if you're used to iPerf, you'll know it reports the data rate. I've deliberately constrained this to 4 megabits per second just to keep the TCP dump capture small. And you'll see there is the column with the data rate and the retransmission column as well right next to it. Now keep an eye on that right at the end of the flow lasts 70 seconds. You'll see there's a burst of retransmissions. So I'll say a little bit about that while this is running. This particular mechanism for drifting the flow across different networks is not specifically for privacy. It's how ILNP does mobility and multi-homing and multipath. Okay, so as I said, ILNP is a bigger project. It's looking at a different architecture for networking. So in a way, you could think of this privacy mechanism as a side effect from being able to do mobility and multipath transmission. But the TCP connection here is just the default TCP in FreeBSD 14, which is cubic, running over ILNP. So it isn't aware that it's going over multiple paths. And that's because, of course, we've disconnected the forwarding state from the end system identity. Okay, so that's the flow finished. So I'll stop the TCP dump, and then I'll look at the addresses that are used. And what you should see are 4 addresses there. The bottom 64 bits are the same, as I said, for ease. It's the same node. We've seen that is being used, and we can see that the top 64 bits have changed as the flow has come across different networks. Okay. How does this look like in terms of data rates on a graph? So here's a very simple graph. At the bottom, you have the aggregate data rate that's measured at the receiver. As I said, I set this at 4 megabits per second using iPerf. And then the 4 graphs above that are the different data rates that are seen by looking at the PCAP and looking at the transmissions on each of those separate networks. And right at the end there, as I said, you've got this little burst of retransmissions, and that's because this is standard TCP. It isn't aware that it's running over multiple paths. There's a little bit of misordering as the network change happens. You move from one network to the other, and that triggers the TCP congestion control. Okay, so that's something else we're looking at with my team, is to look at how we can do congestion control when you have multiple paths for a single flow, and lots of other people in the community, research community, are looking at that problem as well. So that's it for me for now. So what we have here is the use of a different form of addressing using ephemeral node identifiers and dynamic multipath flows. And this gives improved packet level privacy because you don't see a single identity and you have multiple networks. So it makes the attacker's job harder. For example, if they want to monitor a flow and you're sending it across multiple networks, they now need multiple monitoring points and they have to collate the results. This can be used on IPv6 today with IPv6 applications. There are other possibilities. I've shown you the simplest thing for demonstration purposes, but there are some examples of other things that are possible with this locator value. For example, rewriting locators within the network if you want to, and that you'll see some details of that in section 7 of RFC 6748. Lots of technical details in a couple of journal papers. The URLs are there for you. And if you want to know more about this or about ILNP in general, lots on the website, but I'm around all week, so I'd be delighted to talk to you. For now, thank you very much for your attention, and I think I have some time for questions.
Hello, Richard Patterson. Thank you for the
Affiliation, please.
Sorry, for myself.
Well, actually, affiliation is just to give us a background of where you're from, what your organization.
Okay, I'm from Sky UK, yeah, it feels like all of this kind of presumes there are no stateful firewalls in the path.
Okay, so if a firewall decides it doesn't want to let the extension header through, then it's not going to get through. The places we have tried, it mostly gets through. I have a partner in India that's having a problem with a firewall upstream.
Yeah, not because of the extension headers, but because of the state. You're not seeing a SYN come through. The SYN's already gone through, and you're changing the location ID partway through the flow, and
yeah, that could happen. Yes.
Jen Linkova, nobody paying for me being here, so I'm
Doesn't
speaking
matter.
for myself.
Affiliation, please.
No affiliation.
No
I
affiliation?
don't want to reveal. Anyway, I am curious if, first of all, if host has the whole /64, for example, right? Like mobile networks do, and not just mobile. It might make your life even easier, right? You can change your bits for identifier on the fly, right? From that /64, just generating new ID, right?
Right. Okay. Yep.
Okay, and the question, I might just missed it. So you're saying you signal the change via ICMP.
Yes.
What happened if it does not get through? Are you making like make before break or something, or like how do you?
Yeah. So effectively, and you saw this in that little video, you've got a make before break. You've got effectively an IP layer soft handover.
Okay, so if you're not getting confirmation, you are not changing your ID. You need to make sure it was properly signaled and received on the other side.
Yeah, but if you lose the network, you lose the network. There's nothing you can do.
Yeah, but I mean, okay, thank you.
Greg Choules, ISC. The examples you've been showing are using a transport like TCP and assuming long duration connections. But what about something like UDP and very short duration connections like DNS, for example? And also, it may be the case that there are policies, in the DNS server that permit queries from some users and not other users, or want to treat them in a different manner, or whatever they want to do. But it's based on the assumption that the source address for a given user is going to be the same.
Right. So we have not tried this for DNS. We have tried this for UDP flows, but again, longer-lived UDP flows. Let's say you got to a point where people thought, hey, we would like to use this. It would then mean that other things would have to change as well. So if you have a service that expects certain address values and will only serve those, this is going to break those. Okay. But then you also then perhaps don't have privacy.
Chicken and egg. Right. Thank you.
So we have a question over there.
Yeah, it's Lucas Rose from the University in Düsseldorf. And I was wondering, in what situations do you need to exchange these ICMPv6 packets to update the locators? Is it always required, or are there just certain situations?
Yep, anytime the locator values change, you need to have that handshake so that the correspondent knows where it's expecting the packets from.
So in the example we've just seen, there have been like every time you brought an interface up or down, there was an ICMPv6 exchange in the background.
Yep.
And the other question I had was, you probably had the networks you were using for the locators pre-assigned to the interfaces you brought up and down?
No, we waited for a route advertisement to come in.
Okay. So this means via route advertisement, you can also dynamically assign these 64s. Okay. Yeah.
Correct. Yep.
Thank you.
Go ahead.
Eric Ving, affiliation is Cisco, but I don't think it's really matter here. So Salim, could you say in a few words the advantage of your solution as opposed multipath TCP or QUIC?
Right. So for multipath TCP, it only works for TCP. Because this is done at the network layer, it will work for UDP and anything else you want to build at the transport layer. For multipath QUIC, on my to-do list to see how the new multipath QUIC spec compares with doing the multipath for UDP over ILNP. So I have a student project defined for that and waiting for a suitable student victim to come along and try that out.
A suitable student. Okay, first time I see it. Thank you.
Neil O'Reilly, Tolerant Networks. I'm wondering what size of, how big a population or how big a pool do you need to get the privacy advantage that you've been telling us about?
Great question. If you look in that paper, the paper you probably want to look at is the second one. It tells you, but things start getting pretty good at 4 different networks, and they start getting to the point where it's very difficult even for a hidden Markov model approach to analysis for things like interpacket arrival times and packet profiles to work once you get beyond about 5 flows. So it gets to the point where, well, the more paths you have, the better. But there's an analysis of this in that second paper.
When you say 4 networks, you're talking of something the size of a /62. So 4 distinct /64.
Yeah.
Okay. The contrast I'm thinking about is the difference between something on a campus network scale, where that's clearly going to be doable on the one hand, and on the other, the scale of my home,
right,
where there are 4 of us in the house, we're all tied to the same /56. There's not a lot of anonymity going on.
No. If somebody wants to monitor your house, or they know the network that you're using at your house, and they know it's your house, and they know there are only 4 people there, that's some additional information that they can then merge, even with the use of ILNP, to give them some further insight. If you have somebody just monitoring things on the network and picking stuff out without, in the blind, as it were, without that extra secondary information, they can't get much further. So this isn't a total solution, it's making the attacker's job harder.
But what I'm taking away from that is that at the scale of maybe a medium-sized enterprise or a small university, it's already advantageous.
Yes.
Thanks.
Thank you. Thank you, Salim. So as we heard yesterday from Hans-Peter, that the objective of stating your affiliation is for us to know you. It has nothing to do with who you're representing when you're asking. We all assume that you're representing yourself when you're asking a question. So it's just for us to understand you and your background. Thank you. Now, our next speaker was not able to come to physically, but will be joining us remotely. Please welcome Frederick from Meta.
Hello, everyone. Sure, if you can hear me, can I get some kind of idea that everything is working? Oh, there we go. Perfect. I can hear the room. Yes, perfect. I hope you can see my screen as well. So first, I have to send my excuse for not being there in person, and also on behalf of the company. We are still a sponsor, but we have nobody on site, unfortunately. And this has to do with some company policy that we will have layoffs this week. And when there is layoffs, nobody is allowed any business travel at all. So it's a bit weird sponsoring an event where you can't be there in person. Anyway, enough of that. So today I want to speak about edge and backbone evolution and a little bit about peering. My name is Fredrik Korsbeck. I'm calling in from Stockholm, Sweden, and I'm the network strategy manager and tech lead for Europe, or EMEA actually. So to set the stage a little bit, the Meta network consists of 32 origin data center regions, one of them being very close to where you guys are, in Clonee outside of Dublin. We are active in roughly 90 or so edge pop markets. We operate something called network appliances that sits inside ISP network. And today we're serving about 3.56 billion users, or active people rather. There will be 3 themes in this presentation. The first will be backbone. And to set the stage a little bit on what the backbone is, we have to talk about our 2 major backbones. We have something called CBB, or classic backbone, which is the data center to POP, right? So that is where, you uploaded a cat picture 15 years ago, they are stored somewhere in a data center, and when they are served to you, your phone or your users, it will be served from a POP. So this backbone is optimized to serve a global footprint. It has very diverse capacity requirements. It's a traditional IP MPLS type of network, and it's a single plane architecture, and it's built for to fit for scale, which means that a small POP like Brussels maybe would have a pretty small POP, but a very big POP like Ashburn or Dallas would be very big. The other network we have is EBB, or Express Backbone, which is the one that it goes data center to data center. This is the big scale-up backbone, the one you maybe see in the news sometimes. And when we go and build new cables and these things, this is typically for the EBB use case. This backbone is very different because this is a multi-plane architecture. It consists only of meta software components. So we use our own operating systems, we use our own protocols, and this is typically deployed inside the data centers and in some of the midpoints. Midpoints is a bit of a meta word, I guess, but it's backbone-only sites. Good example could be Lyon maybe, or Esbjerg in Denmark, where there is really no edge presence, but we have a big backbone presence. Looking at traffic growth over the years, DC2 POP has been more or less flat, or just a very small percentage of growth. However, the EBB, which is a data center to data center, has been growing exponentially over the last couple of years. Has a little bit to do with the AI world we currently live in, but also other things is kind of pushing the envelope here. And in the next 7 slides, I will talk about how we scale up and the various methods of being able to scale a backbone of this type. So one of the ways you could do it is to build larger chassis. You go from an 8-slot chassis to a 12-slot chassis. You could also increase the interface speed. So Thomas here talked about 400 and 800 gig optics on the presentation before me. And we are very much in this business that if we can change out 400 gig interfaces to 800 gig interfaces, we get essentially 100% increase. There's also this idea of scaling out. When we talk about planes, the easiest way to look at this is just essentially another backbone. It's like when your first backbone is full, you add another identical backbone next to it. And we have done this a couple of times. So we're already today up to 8 planes, and we've been for a couple of years actually. And the reason for this is the boxes cannot get big enough. So instead of just trying to make them bigger, which we're also trying, we can just add more and more on the same side. And if we're applying this to how we think about the network, over the years, we've been seeing this type of growth where certain backbone paths has had to be scaled 192x for the last 7 years, which is pretty crazy to think about. And one of the key methodologies that we used to be able to achieve this was ZR technology, primarily on the 400 gig and 800 gig type of interface types. So before we had ZR technologies, we were using traditional transponders like we have done for the last 30 years, which is typically you have a router and you connect it to a very expensive transponder that converts the Ethernet signal into an OTN signal or something like that. These require a lot of space and require a lot of power, and also require all of the software stacks and kind of all of the stuff that goes around it. But with ZR, which is the main technology we use in our backbone, we put the DWDM optics directly into the routers instead, and we can make the optical network pretty dumb. And to showcase this a bit better, we could take an example. So this is a midpoint or a backbone-only site, quite typical for how we have traditionally built it. So rails, another meta word, but it's a fiber pair basically. So this is a big backbone site, fiber pairs. We do about 20 per fiber pair, and the total system capacity here is roughly 1 petabit. In the good old days, this required roughly 58 racks. So 50 of them being optical and 8 of them being routers or EB racks. When we swapped out to 400 gig ZR, we could trim this down to 13 optical racks and 8 routing racks, so 21 racks. And now that 800 gig ZR is becoming commonplace, we are down to 6 optical racks and we're down to 14. And this, of course, saves us space, power, and money, and basically an ease of operation of building this way instead of the traditional way with traditional optical vendors. And if we look in the metro, so the metro is very interesting. When we define a metro, it is, at least in the data center space, we're talking about maybe hundreds of kilometers or something like that. Because today, especially in this new AI data center world where we're talking about gigawatts and not megawatts or kilowatts anymore, we cannot get all of this data center space adjacent to each other. Like we can't put every data center in Ashburn. That would be a bad idea. So between these data centers, we had to come up with a new thing. Today, that new thing has a name. It's called RBB, so Ring Backbone Network. But at the time these slides were produced, it didn't really have a name. So it was called AI Backbone. So when we go and build fiber for these type of networks, they look like this. You might think that this is a plumbing system for Amsterdam or something, but this is actually fiber trenches that goes between these AI backbone pairs. Because in most cases, we require hundreds of thousands of fiber pairs between these data centers to be able to build what we want to build. So if the connectivity, or in the data centers, if they're within a 10-kilometer envelope, right, then we can use regular gray optics, and we can use fiber instead. Then we can just deploy a single 400 gig or 800 gig link per fiber pair, and we kind of scale with fiber, and it goes into these vaults. Because these data centers, especially the AI ones, they require hundreds of thousands of 400 gig links between each other to kind of fully operate. If the connectivity is larger than that, or sorry, the range is larger than that, then we need to deploy DWDM. And then we're using the same methodology, but we're using still a lot of fiber pairs. If we need ILAs, those ILA sites are becoming pretty huge. There is some interesting things on our public blog on how we design the new ILA sites, but as you can imagine, if you ever built a DWDM network, if you're suddenly lighting up, let's say, 2,000 fiber pairs with DWDM optics, that's going to require a lot of amplifiers, essentially a mini data center just for the amplifiers. So that's what's happening on there. And just to give a perspective here, so one site pair of these AI data centers, they consume about twice as much as all of the other backbone combined. So these AI data centers are consuming a lot of backhaul for sure. It's pretty crazy. Okay, let's switch over and look a bit at the edge. What's happening there? Because this is maybe more closer to all of you. So what does the edge really do? So it's one of the largest internet serving infrastructures on the planet with thousands of peering partners. We are covering, as you can see there on the map, I hope it's visible on the screen, but we are in most places in the world. This is a multi-tier caching architecture, which means that not all of these POPs are created equally. They're also serving each other from each other. And we use pretty advanced both targeting and global load balancing to be able to pin users to the right POPs so that everyone involved is happy. So we are happy, the ISPs are happy, and the users are happy. And we try to optimize for latency. And if we look under the hood of an edge metro, it all kind of starts with the peering layer. So the peering layer is more or less as you would imagine. It's a couple of peering routers, 4, 6, 8, or something like that, in a common facility that we all typically have our routers on. You know, Harbor Exchange in London or Science Park in Amsterdam, etc. And with this, we connect two major compute things. In essentially every POP, there is a caching layer, so a CDN layer. That's where the videos comes from and the images and embarrassing things you uploaded 10 years ago to your Facebook profile. All of this comes from the caching layer, which then, of course, gets it from the origin, one of the data centers. More recently, a lot of these POPs also have an edge cloud or a compute layer that is connected to it. It all kind of started with the gaming experiences and the metaverse things, but now it's really all about the AI in combination with those previous things, of course, where at least the larger sites get one or multiple of these edge clouds connected to it. And All of this sits together from an aggregation layer. So this is basically a leaf spine type of deployment. But what's interesting here is that the last 3 years, most of these things were sitting in one site. Let's take Telehouse in London as an example. Like all of this, we're just in a single cage. But with the recent growth and with the recent kind of capabilities with GPUs and stuff, that most of these layers are actually breaking out into multiple sites because they all need very different things. Like the peering layer obviously needs people to peer with. So putting the peering layer in a data center somewhere out in the woods where maybe the space and power is cheap and we can get the rack scalability we want, but there's no one to peer with, so we can't really do anything. Same thing with the edge cloud. The edge cloud is go through the aggregation layer, but it doesn't really need to be very close to anything else. It needs cheap space and power and high density on racks, right? So what we're seeing in a lot of metros, especially Europe, is that these are breaking out into multiple data centers, and we connect them together with DWDM and fiber. And of course, the backbone need access to wherever the large backbone paths are. So if we're talking about the hierarchy then, so the data center, that's the big thing. In Europe, we have 3. So we have Clonee in Ireland, and we have Odense in Denmark, and Luleå in Sweden, where I am. And this is where we store all the information, save all images, and do all of the data processing. But the RTT to users is, of course, very high. So we really don't want to serve stuff from there if we can avoid it. So that's where the edge metro comes in. The edge metro sits in Europe, it's in 32 metros or something like that. And that can, cache 80, 90% of all content that people use, the popular reels, the popular images, the popular ads, whatever it is. And we have something called an MNA, or before it was called FNA, so Facebook Network Appliance. Now it's a Meta Network Appliance. So these are deployed inside ISPs. They cache the most popular stuff. They do WhatsApp call relays. All the new Taylor Swift videos obviously get published there. So this typically takes out a lot of the load on regular ISP networks and regular peering points because these can do like 80% of the traffic, give or take, depending on the market. So these are highly popular. And these clusters could be anything from 3 times 1 rack units to several racks of servers, depending on the scale you need. So really what's happening here, the evolution part, is first, of course, we have we call them multi-peer MNAs. So this is where we can deploy. It's been very popular in Africa, for example, where we can send an MNA into a country where we are not currently planning on building an edge metro. So we can put these multi-peer MNAs that could peer on IX, it could peer on PNIs. So it's like a micro POP, but that sits in someone else's facility. Lately, though, with AI and everything else happening, there is plenty of new use cases for us. Like obviously, you've probably seen the Ray-Ban glasses. So the glasses that has little cameras, it can do a lot of things for you. There is gaming use cases, there is metaverse use cases, augmented reality use cases, and many, many, many more things coming from a product team that requires us to put compute in the edge metros. And with compute here, that typically means a GPU, or I guess an accelerator is the new fancy word to use for this, where these are moving into the edge metro. And really what I want to say with that is that the edge metros are going to get more important for us going forward, because with these forward deployed MNAs, right, the one that sits inside the ISP networks, probably a lot of people in the room currently has this inside their network. They don't really want to host GPUs, right, because GPUs are extremely power hungry. So a lot of these AI use cases will be in the edge metros. And also the latency required for a lot of these AI use cases is not as high as people think. Looking at it from a European perspective, I would foresee that we can serve 99% of our use cases from 5 to 8 locations in Europe, at least for what we know now. because there isn't any needs really for 10, 15, 20 millisecond, that type of low latency for the AI use cases today, because the compute latency is much higher anyway. So trying to optimize for super low latency for this is, at least today, not very much needed. To finish this off, I promised to talk about peering policy as well. I know not everyone in the room is super into this, but we'll go through it anyway. So the big takeaway from this is that we're moving away from route server peering. And truth to be told, in most of Europe, we are, since a few months, already out of the route servers. But this is not a change in peering policy, though. We are still peering with basically anyone that wants to peer. And we just want to reaffirm that smaller networks matter to us. And we want to explain how to easily peer with us at an IXP or wherever you want to peer with us. And we are committed to our network strategy to support the open internet, despite there is some spin doctors trying to make it look the other way just because we're leaving route servers. So the why. Why do we have an IXP strategy? So we want to enable one-to-one connections with long-tail networks, because that's the primary use case for us with IXPs. And we want to make it secure, scalable, and well-managed. And we want to maximize the value both for us and for everyone to peer with us. So typically, we operate 2 ASNs. So our big ASN is 32934. That's the big meta network. And for these appliances, so the MNAs, they typically peer with 63293. And our target is to have roughly 2 IXPs per metro location. For Europe, we're in about 30 or so, and we're looking ahead to get a few more as the year goes along. And if we have less than 1 IXP in a metro, we are typically looking to explore if there is a growth option, if the market is ready for it, and if people actually request it. If there is more than 2, we are probably looking to consolidate, which has been happening all over the world for the last year or so. I mean, I think at one point we were connected to 9 IXPs or something in Amsterdam, which was quite cumbersome. So what we're looking for in an IXP is good governance and stability attributes. We want them to be relevant for the market and have some kind of growth and interesting networks for us to peer with, of course. We want to participate as a customer as possible. Like, we are members of 150 or so IXs globally. And we're just a handful of people that does all of this. So we really don't have time or bandwidth to be able to participate very actively in the IXP, like boards and these kind of things. We are looking at 100 or 400 gig physical presentation. 10 gig is more or less sunset across the network. A 10 gig port is almost worse than having no ports at all, unfortunately. And we also don't want to have an obligation to establish route server sessions. And for the long tail then, we want to maximize the opportunity to peer with anyone. And we want to empower thousands of smaller networks globally. It doesn't really matter the size, right? Like if you're a mom and pop shop or a WISP that covers a small little street or something in rural England, we're happy to peer with you. And we want to make it cost effective for everyone. And we want to connect one-to-one in many more places for more networks. And bilats enable security, performance, and reliability benefits for the both of us. So how to make it simple then? We have an automated peering portal that does not require a Facebook account or an Instagram account or anything like that. The only thing that it needs is a PeeringDB account. You can go to yourself to meta.com/peering. And the requirements here is that you do have a PeeringDB record. And you can essentially just follow the link, log in with your PeeringDB credentials, and you will let all the automated workflows do the job, right? So it's not really more cumbersome than to have a route server session. Just to showcase how it looks like. This is the peering portal. You have a PeeringDB OAuth button at the very top right. You can click that, and you do your thing on PeeringDB. And you will authorize Facebook or Meta to be able to read your email, for example, and to be able to do the sync on which comments you do have. And you click here, you can request a public peering, you can request a private peering, or you can request to join the M&A program, which is the network application program. And it could look like this. It's like here we are trying to peer with 37599, and it seems we are sharing a couple of joint IXs. So you just select the IXs you want, and then you click Start Public Peering. And in a day or so, all those sessions will come up and we'll be able to exchange traffic. So the takeaways here is that essentially most IX sessions will be approved by automated workflows. There's no humans involved. It will just come up and everyone will be happy. It does rely on peering DB. So if you're not there, you do not exist, right? And this is not Facebook, right? You don't need to have any type of affiliation with any of our services at all to be able to use this. And we covered an update to the IXP policy. We confirmed the importance of the long tail, and we shared how to peer with Meta IXPs. We are around, meet with us or say hello at the social, which I guess technically for this time is not true. But in most cases, you know that we are around, we're happy to talk, and we're happy to drink a beer at any social, of course. And thanks for your time. And oh yeah, just before we finish off, IPv6. IPv6, of course, very important for RIPE, but also very important for us. We're an IPv6 first company, and we will always try to serve over V6 if possible. And since RIPE is in the UK right now, I'm happy to show that these are public stats, by the way, that the UK is on the 11th slot here on like global adoption. Still a bit of way to go up to India, which is absolutely amazing in running V6. And then to the left there, you can see there is some countries that has 100% IPv6 adoption. And for the Antarctic lands, I'm not sure. I think that's more have to do with perhaps low sample quality other than that. But India is at least a real behemoth when it comes to IPv6 deployments. With that, I believe I have time for some questions, and I'll try to stop the screen sharing so I can see all of you. And go back here. Thank you very much.
Please go ahead. Name and affiliation.
Hi, Mick O'Donovan, Asira Technology. You referenced very early in your thank you for the presentation, by the way, it was very good. You referenced in your slides early around the power consumption of optical transponders versus ZR transceivers. Have you kind of done actual measurements on that in terms of the swap out and the power usage? Because obviously the routers that these ZRs are going into are still consuming more power as well. So have you done a direct comparison at any stage?
Yeah, I don't have the data kind of on top of my head right now, but of course, there's been a lot of, because in reality with this, you're cutting away one type of link, right? Otherwise, you need to run gray optics between the router and the transponder, right? So at least that part is going away. And then the transponder chassis consume power in itself. So I can't give you a number on top of my head exactly how much this is, but it's not only about power, right? It's also about space. Like these traditional DWDM kits take up racks and racks and racks, which we don't really have in these backbone sites.
Okay, thank you.
Thank you.
Hi, I'm Will from Holland I was wondering what is your consideration to go and connect to an IXP size-wise, because I'm representing the small IXPs there, like the one that have like probably less than 100 gigs, like, or 500 gigs of traffic. So I'm just wondering if you would consider having devices in those small places in towns where you're not yet.
Yes, so we do have a couple of examples of that already. I mean, mostly these multi-peer M&As, they go into emerging markets like Botswana or Zambia or things like that. In Europe, top of my head, I think we have like 5 or 6 of them where we've been able to find markets where first there is an IXP, there is somewhere where we can put it, so there is some kind of data center space, and there is enough interesting networks that is local to that market that that can do it. I mean, in terms of traffic volume, it's like 100 gigs. Yeah, that's probably fine. I mean, just for reference, the smallest cache we can deploy today is roughly in the 50 gig range. So that's where we go, like cost neutral, more or less. So we always look at basically every ASN on the IX. It's like, who are they? What type of traffic do we have with them? We have excellent data, right? So we can see per an ASN level how much combined traffic would this be, and we're happy to evaluate that all the time. And hopefully you can see my email in the PDF on the website, and you can just give me an email and we can look at it.
Thank you very much.
Thank you.
We have time for one last question.
Blake Willis, Peering Geek, speaking for myself. Thanks very much. Great insight into what goes in the the back end sausage making. Would you say that your route server withdrawal is mostly due to like quality reasons and not very useful prefixes and flapping and so on and so forth?
Do you want the spicy answer or do you want the well-polished answer?
Rock and roll.
Yeah, I imagine. Well, there is a whole bunch of weird things going on with route servers. So the first thing is that nowadays we have route servers of route servers connecting other route servers to other route servers. And some operators are also using these route servers to artificially create something that isn't true. Like, for example, creating a very large AS cone. And so that's one thing, which I really don't want to motivate that type of behavior. The second thing is also security related, right? That there's a lot of spoofing going on these route servers, and there is a lot of weird hobby networks that tries to establish sessions. And even though if we have firewall rules and ACLs, because there is whole IXs that is just filled with virtual networks, that is just people's Kubernetes machines peering with each other over a virtual fabric. And it's just a lot of noise to keep track of all of this. And even if we have pretty good, I would say, traffic targeting, where we're trying to figure out where people actually are, it's like when you're peering with us in Amsterdam, are you a Dutch network, or are you at least close enough that we don't have any other better way to serve you? Then that's great. But today, with these network of route servers, there could be someone in southern Brazil suddenly appearing in an IXP in Bulgaria, right? And that's not really productive. And while we are trying with other methods to try to distinguish that, right, and try to serve them from the right place, because in my mind, if you are a network in southern Brazil and you're only peering in an IXP in Bulgaria, then you should probably be served over transit or your upstream in Brazil, right? And not necessarily from the other side of the world over some wet MPLS tunnel over 7 networks. So that's a rock and roll answer. But I think a lot of people actually already knew this kind of in the back of their head.
Thanks.
Thank you, Frederick.
Thank you very much.
For those that were not around earlier today, we have a couple of announcements. The deadline to register and attend and vote for the RIPE NCC Journal meeting is Wednesday at 2 p.m. Also, the RIPE PC election nominations will close today at 3:30. I'd like to just mention that the program committee, we're always striving to kind of improve. So we really appreciate anyone who comes up to us and tells us how things are going, what they think of the program. So anyone that has this kind of reddish, pinkish color or purple, just please come up to us and tell us how if you have any feedback. And thank you very much. We restart in about 30 minutes. Thank you.
point. I just hired a solicitor. Yep. I'll see you around.
Appropriate citizenship at some point in time. Well, she's from America. She's not British citizenship now, but yeah, but Irish citizenship.
Yeah, yeah.
Hello, hello, hello. Good morning to you all. Still is morning. Welcome to the second plenary session of the day where we have lots of fun talks for you. I'm Brian, and along with Clara, we'll be chairing this session. Quickly, because, you know, you haven't heard it often enough so far this week, the PC elections. The deadline is 3:30 today to nominate yourself. Thanks to those who already have. Yes, if you haven't got a headshot and you want a headshot for your PC nomination, the official photographer, Andrew, is happy to do that for you. So, without further ado, we'll introduce our first speaker, Antonios Chariton, to talk about RPKI garbage collection.
Hello, everyone. Can you hear me? I hope you can hear me. Okay, perfect. We can begin. So I'm going to start with a story on what I found on this wonderful subject of RPKI. So it all starts with a friend that I have, and this friend likes to learn new things, and it's how he progresses in his career and how he moves to spend his free time in a better way, basically. And he has played with network gear of, various vendors. He's played with networks and overlays that are using BGP and some kind of filtering and what's not. And this has been successful so far because he has been able to improve his career, and it's been going so far very well for him. But he wants to keep learning. He wants to learn even more about the internet and try to see what else is out there, like beyond the confinements of a small home network that runs in essentially one location, and everything is VPNs and tunnels. But he's also a budget-conscious friend. Like, not everyone has unlimited money to spend on their learning journey, and this is something that I completely understand. So he wanted to find a solution that would help him learn more, progress with his career, and eventually be at a place where he can find a job in this industry. So we were discussing this, and one day I received a message from him that said, "Can you help me get an AS and some IP addresses like IPv6?" And the reason for that is that you can test in these virtual networks, you can test all of the filters and all of that. But when you join the real internet, that's where you have to do, RPKI, all these database objects, actual large volume of updates, filtering, all of that starts to get more serious, more important. So that's something that you can only experience by doing this in the real world, of course, by taking precautions and not causing too much damage along the way. And my answer was, of course, I'd like to help people when I can and if I have the opportunity. And I thought this would be super simple to do it, just, get an AS. I thought it's, I can go to the LIR portal. It's like 2 minutes to file the application to get an AS, right? So I go there, request the resources, I click the AS button, and I move forward. Like, not 2 minutes to get the AS, of course, by the way. It's 2 minutes to apply. And, well, it turns out that we need a contract. Apparently, it's not that easy. Okay, makes sense. I look at the website. There is a nice template, I think, by the legal team or the community that you just download this docx file, you change some details like the names, addresses, whatever, and that's very useful. But apparently, in the contract, it says that I need to charge this person. Okay, like I say, okay, can I give it for free? Like maybe change the docx file and just say this is provided for free. Turns out no, existing policy requires you to charge people. You cannot offer sponsored resources, unfortunately, for free. So now it's a high budget transaction. Now I need to contact my accountant and see how I can charge VAT and how I can pay VAT and issue invoices. Suddenly it turns out it's too expensive. So unfortunately I have to send this person to the many LIRs that are sponsoring resources. And the good thing is that some of them are doing this, thankfully, for a very low or basically no margin at all. They just charge the price that they have to pay to RIPE NCC. So long story short, after 20 or 25 days, I think, we were able to get an AS. And despite it being almost a month, we are still interested in moving this forward. And we say, finally, we can do the interesting things now. We can configure BGP. We can do all sorts of things to move this forward. And he can finally start learning. So what I'm doing from my side is I go to my AS set for my downstream customers. I add his AS there as a member. Then I have some automation that I'm using on my network. It's inspired by Coloclu's case, and it generates all of the customer YAML file, all of that. So I don't have to go manually into every machine and configure the filters and what's not. And it generates the prefix list. So he doesn't send me whatever he wants, and we're more responsible. And when I look at the diff, when I look at the pull request that's generated, I see IPv4 addresses there. I see 2/22s in this prefix list. And I'm like, okay, this is a budget conscious friend. Like he probably didn't spend 40,000 euros buying IPv4. So what's up with that? This was totally unexpected to see IPv4 when I generated these lists. So I go to BGP tools, like the website, to look up the AS and see what's happening and figure out if there was a mistake or anything like that. And I also discovered that he's connected to DKIX, apparently. And he also has a Juniper router. And remember, this is a budget-conscious friend, so he also got a rack in Madrid and a port in DKIX. And he also bought Juniper routers along the way. So what's going on here? Like he probably is hiding his hobby money from me, and he's just having me work for free. I'm over-dramatizing this, of course. He told me he has no idea what these IPv4 prefixes are. So I troubleshoot it. My automation tool is using BGP Q4. I run it with the AS, and it returns these 2/22s. So these seem to be associated with this AS. And I check, I debug it, and it turns out that one of the databases, one of the IRR databases that are being used by BGP Q4 is a pseudo database, the RPKI pseudo database, which, like, to put it simply, is basically you take all of the ROAs that are published, you create route or route 6 objects, and then you serve them as an IRR database. Like, I'm oversimplifying it here. It's not, but essentially, basically, you get all of the ROAs as route objects. So I look into this further, and I use Monocle to check the ROAs. And indeed, RIPE NCC, the trust anchor of RIPE NCC, has 2 valid ROAs for these 2 prefixes, up to 24, for his AS. And these are current, these are being renewed, everything is fine. So back to BGP tools, I discovered that this AS had previous lives. Indeed, it had 2 companies that had this AS before. One of them is really in Madrid, so probably they were the ones with the routers and the DKIX port. So did we discover a way to get free IPv4? Because right now I have someone, he applied for an AS, he got an AS, and he can do an RPKI valid hijack, and nobody would be able to tell. Like this would propagate everywhere, and there would be no way of knowing for anyone that this is an attack. To be clear, like this is a joke, these addresses are not yours. So if it happens to you, you don't own these addresses, you're actually attacking a real network. And in fact, if one of these is not even advertised, you're also getting 100% of the traffic. So I go to one of the RPKI experts that I really trust, who knows the most, at least as far as I'm concerned, about this topic. And I ask him, hey, like, what if I keep getting ASs? And what will happen then? And he tells me, well, I mean, try go getting 100 ASs from RIPE NCC. They're not going to give you that many. There is rate limiting that's happening. So the registry will stop you. You cannot come up with 99 excuses. And literally, like this happened in the morning, literally that afternoon, I was scrolling through Mastodon, and there is a bot there from BGP Tools. And this bot is posting all of the new AES allocations in our region. And you can see here a bunch of them, I think like 15 or something by Tobias Fiebig. And turns out that you can probably get more than one AS if you justify it well enough. So yeah, maybe it's not, as solid. And we had a laugh and that was it. But then I'm lucky enough to be working at a company where I get to decide how I spend some of my time. So I work at Cisco, in case that wasn't clear. And what I did was I discovered all of that on my personal network. I saw that this was happening, and I solved the problem for this specific use case. But I wondered, is this something that happens to someone else? Does it happen? And how often does it happen to the entire internet? And since I'm at least currently entrusted to some degree with the ability to choose what I spend my time on, I decided to study this, like do this research using company resources, company time, to figure out if there is a problem indeed for the internet as a whole, if this is something that we should be worried about. So here's what I did. First of all, I got a list of all the ASs and the date they were assigned. This is a file that is provided, you download it in 5 seconds, boom, you're done. And the next thing is, you go to 24 or 48 hours before an AS is assigned, and you look if there are any ROAs that are pointing to this AS. They are legitimizing this AS as an origin for their prefixes. And the first part was easy, like getting the ASs. The second part, apparently it was more difficult, because there is this open project RPKI views, who could really use contributions in money and time and resources in general. And they have the archive of all of the certificates that you can go back to and research. If we didn't have an archive, this would not be possible. We could not look back in time. And the question then is, why is this the correct methodology? The idea is the following, like RIPE currently, like the registry, assigns the ASs randomly. So I theorize that if you go a day before an assignment is made, not even the registry staff knows which AS they're going to assign. So probably not even the new assignee is going to know to pre-create these ROAs. So any object, any ROA that you see for an unassigned AS, even if it's 24 or 48 hours before, it should probably be a mistake that's left over from a previous life. And I run the numbers and let's see what it looks like. So for 2026, so far at least, 18% of the ASs that are allocated in this region basically come with pre-existing ROAs. And in 2025, which is a full year, above 1 in 5. So that means that roughly 1 in 5 new ASs that we give out come with free prefixes. Again, a joke. I wanted to look more into that, and I took year 2025 as an example. And here are the assignments that have been made through 2025. The busiest month was July, so summer seems to be peak networking season. And they are roughly constant over here, and you can see we make about 150 to 200 ASs every month. And I looked at how many of these have ROAS, and it turns out that, you know, like as expected, we have some peaks, but it is roughly the same. And then for IPv6, most people get free IPv6 with their AS. Someone else's IPv6, that is, not their own. And a few luckier ones, they also get IPv4 ROAS pointing in their AS. And some of them get both, just to have a complete set of address families, so they can do dual stack and whatever else they want with hijack space. And the problem here is that there is a double-digit % chance of you getting IPv4. Like, of course, IPv6 is also an issue, but you can also, you know, this is potentially, you know, a commercial resource here, like IPv4, that you can hijack and it would not appear as a hijack. So the other thing what I noticed was that this seems to start, at least in 2025, in this arbitrary time frame, it starts at almost 0. So I was wondering what is happening, like why do we have, what was happening before? So I pushed it to the limit of RPKI views. And this is 2021, this is almost the beginning of 2021. I downloaded basically as much data as I could, and here are the assignments in our region, and they have, you know, a slowly increasing trend. And here are the ROAS. At the bottom, it's just a few of them, like pre-existing ROAS. But let me actually normalize this. So now assignments are 100%, and you can see here what's happening, at least with the pre-existing ROAS. So there were some that were happening, like around 2021, we started assigning ASs with pre-existing ROAS. Then it lasted for 2 years. And then we almost stopped. It almost completely stopped happening. And this lasted for 2 more years. And then it started happening again significantly. And we reached even a month that was almost 40%. And it has been around 20-something, 30% recently of assignments with pre-existing ROAS. So I wanted to find a way to interpret that. And I was looking at this chart, and I was thinking, okay, so like there is this 2 years period, and what does 2 years mean for our community? Like, I've heard this number before, this period of 2 years, and I kept thinking about it, like, could this be related to something that happened and lasted 2 years? And as I was thinking, oh, sorry, this is an unrelated slide. I don't know how it made it here. It's the IPv4 waiting list. Basically, we ran out of IPv4 in 2021, and then 2 years later, you can basically close your account. Okay, let's ignore it. Let's move forward. That's a mistake. I should have removed this slide. So what about other RIRs? Well, it turns out that the most difficult thing I had to do was get a simple CSV of AS, assignment date. The thing that you can get in 5 seconds from RIPE NCC. It's very, very difficult to get correctly, at least, from any other RIR. You can get it easily incorrectly. That was super easy to do, but getting the actual correct file, that was not possible. 2 NIRs had it, so that was nice. But yeah, that speaks to the great work our registry and our database team are doing in not only maintaining all of these records, but making access to them easy to conduct research like this. And, you know, going through these ASs manually, this is a problem that has been happening in other RIRs, but I don't know to which degree that is. So what can we do? So is this a problem with RPKI? The first question. Because 1 of every 5 ASs we're handing out comes with pre-existing prefixes, and this allows you to escalate network privileges. But since this is privilege escalation month, at least for Linux these days, maybe we're used to that. In theory, it's not an RPKI problem because it works fine. And this is just it's just misconfigured. It's not something that is in the protocol, and the protocol already works better than IRR because you have to keep resigning these ROAs. You're never going to end up with all the garbage and the multi-decade routes that exist over there. The other thing is the policy that we have. We have a cleanup policy. Basically, if an AS is returned, it's kept for 6 months out of circulation, and then it's added back to the pool and then randomly reassigned. There is a very long and detailed process to make sure that it is cleaned up. And this is not something that includes a lot of items for RPKI. Perhaps this is something that we can expand on. But for the interest of time, let's talk about this. There is a session, 30 minutes, in the address policy working group. This is on Thursday at 2 p.m. in this room. So if you want to see any charts, any data that I can prepare in 2 days to present to you by then, or if you want to discuss it and find a solution to this problem, please come to this session. Other than that, I'm open to questions right now. Thank you.
And apparently you're going to get some questions.
Yeah.
So, yes, please.
Joe Snijders, RPKI Views. First of all, not a question, but a compliment. Fantastic presentation, really informative. Thank you for putting together this analysis.
Thank you.
Can you go back to slide 30, please?
Well, very slowly I can.
Can you remember which one was slide 30?
You're not counting the slides as they progress?
Yeah. Is it this one?
This one, yes, please.
Yes.
So I'm not a mathematician, but that is absolutely not random assignments. And what I think we have on our hands here is a cache invalidation problem rather than a garbage collection problem.
Yeah.
So if the RERs were to do uniform distributed assignment from the IANA received blocks, like
Yes.
RERs received the blocks in chunks of 1,000, and throughout the years they now have amassed a number of buckets. I think this observation of inadvertent privilege escalation would dissipate in large part. Another approach could be like a first in, last out style scheduler. But I think the core of the problem is it's like garbage collection is great. It's good to clean up ROAs that are pointing in the wrong direction.
Yes.
But there are consequences because maybe somebody thought the ASN is unused and they intentionally tried to make a ROA pointing to an unused ASN, and then suddenly the ASN is used and they're like, thanks, Ripe, I was using this configuration for weird purposes. So random ASN assignment, I think, is a good approach here. And this is not random, I think. But I could be mistaken. I mean, the screenshot is small, so.
Yeah. I mean, it doesn't look very random, but the policy officially is that these are random numbers. My thought on the topic is that we cannot garbage collect. Like we cannot.
The dice once.
Yeah. We cannot force remove ASs, I think, because, what about delegated CAs or other TAs and all of that?
Exactly.
But we can, perhaps email them, or in the tool, we can notify about stale records. Like, are you sure you still need this? So we can do things, and that's what I was planning to discuss in 2 days.
And the other one, the cooldown period, as you mentioned, is 6 months.
Maybe 6 months after it's clean, yes.
Yeah, maybe
So
it's too short.
Yeah, we can also increase it. That's also an option. Thanks.
Again, thank you.
Yeah, thank you, experts.
Tom Strix, Cloudflare. I'm going to echo what Job said. Really cool presentation. Thank you very much for doing this. 2 things. One, did you remove any of the assignments that were previously entirely never ever used, or did you never clean those up? Because this might also just be a pure fact of someone fat fingers their AS on their actual prefixes, right? So that's something that I don't think you've differentiated from in your numbers. So that might be helpful, kind of cleaning that out between differentiating between never used ASNs and ASNs that we're recycling. That might be really helpful in kind of understanding these numbers a bit better. And then the second component, I'm not sure there's a lot we can do this because the ROAs in this use case are assigned, were emitted by the resource owner on the prefix side of things, not on the ASN side of things. How do you differentiate between this is stale versus this is misconfiguration versus this is intentionally malicious configuration?
Yeah, so this is my theory that if it's not been circulated for at least 6 months and 2 days before assignment, it still has ROAS, it's probably configuration. Like there is a tiny fraction where it could be some researcher doing something or something on purpose on unassigned ASs, but I would say, you know, like empirically, not scientifically proven, it could be, you know, most of it would be that, like 99 point something%.
Perfect, thank you.
Thanks.
Tim Ruijsels, Rock NCC. Thank you for presenting this. Nice story. So the OpTI dashboard is very much focused around showing people which announcements we believe might be happening for their IP prefixes, and it guides people into creating ROAS for those, and I think people do to a large degree. What it does not do well is show people the ROAS that they have that don't seem to correspond with any announcement. And there's actually a very high number of them. I'm not sure if I dare to say it. Well, I'll say it. It's like 30 to 60% if you do like a world map plot of it, depending on region. I'm not sure if it's significant between regions, but anyway, there's a lot. And I think there's work to do there for us as well, because we do warn people about, you can subscribe to it, but you can get warnings about, you know, do you see an invalid announcement appear or a not found announcement? I think we should probably extend that and warn people about, are these ROAS perhaps still, did you forget to remove them? I think we should do better there.
Please. Tobias Fiebig.
Hi.
Theo Wien. Hello.
Hi.
You could have called. For reference, the assignments you're currently seeing there are temporary assignments for the RotaLab course we did earlier this year, where we let students experience real-world PGP. There's a Web Labs article on that if you're more interested. In fact, we also noticed the issue you noticed there, and we decided to do something about it, which was dropping Marco an email being like, yo, you might have a problem there. We also saw that a lot of these ROAS that pre-existed could actually trace to real announcements, so not misconfigurations. We had those also a year before when we the first time got these random announcements, and I'm now going to say things if they're incorrect. Marco is also on the mic line. Roughly 2 years ago, like at a fall meeting, I think it was Prague, I did have this problem of getting this very special temporary assignment process. And I noted that there might be address in the pool and that the assignment seems to be cyclic. So it's iterating through numbers and based on time. So if you know that there's nice ASNs in the pool, like 3310, you could just, you know, time it. You need a unique prefix. Well, I have a 29. I have enough unique prefixes. I could just get a lot of ASNs and they're built on the 1st of January. So if I return them immediately, it also doesn't hurt me. I think there were some changes to the pool procedure roughly 2 years ago. And also for these temporary assignments, at least, there's no real cooldown period. So some of these ASNs were reassigned briefly after the RotaLab. So it was a 3-week period. And like the one day after, I had a new downstream somewhere in wherever, because it already got reassigned. Difficult. Maybe we should take this also a bit offline.
Yeah, sure. Yeah.
Thank you.
Thanks.
Okay, cool. I was going to say Gert, you're next, but Marco, if you want to.
Sure. Marco Schmidt, right in the registration services. Thank you so much for this very entertaining and attractive presentation. And I agree with you. There's something that can be done better. I think I have already some ideas of answers to some of the mysteries that you discovered. But it's good that we have another session at Address Policy and we go dive deeper into this one. There's a lot to unpack, so we also can, in the meantime, talk offline on that one. But thank you very much for raising that. And I think something can be done between the WIPE and the C with some mandate from the community to do that better.
Yeah, thank you very much.
Cool. Yeah, and we're going to close these mic lines. We do have a couple of questions online, but Gert, please go ahead.
Getting involved in policy. Great presentation. I see a couple of things we can do here, like what Tim suggested, make the portal just point out there's ROAS that seem to be stale. Make the pool that we get from IANA bigger. There's no reason why the NCC couldn't cycle through 10,000 or 100,000 32-bit ASNs, except for, I don't know. The reason why I came here is actually something else. We have the extended stats files from all the registries. There's a certain assumptions that these files are correct. If they aren't, there's a huge problem. And this really should be addressed. And personally, I would just throw the ball at Marco and say, please deal with your colleagues and get this sorted out. But I don't have any data that says, why are these files incorrect? So I think there's serious work to be done, because the registry data needs to be correct for all 5 registries all the time.
Yes, this is a good point. For example, my AS that I'm actually using has 3 registration dates, depending on who you ask. From 1995 to 2020 something. So yeah.
Okay, Clara.
You said online? Maybe you can give.
We have Rudiger.
A comment as a question, and the question is, well, aren't the basic problems that the ROAS are in the responsibility of the address owners, and if the address owner does not care what he allows by the ROAS, well, okay, so he's getting what he wants to get, and well, okay, the community gets a little bit of collateral damage. Kind of the second thing could be that the address owners are missing the monitoring tools that actually tell them then something about what they have put into the ROAS has changed, and kind of, in my opinion, someone who is responsible for a resource and actually cares for it would be actually looking at some monitoring. And unfortunately, we haven't done a good job in providing such a monitoring service. But exactly that is one of the very important missing pieces in the RPKI. Not only for ROAS, but for ROAS in specific. Thank you.
Yes, I agree that it is the address owner's problem, let's say, fault in this case. But as a security engineer, I want to help people not misconfigure things, and I want security by default. So yes, monitoring is, I think, the right choice. I'm aware of, commercial solutions, let's say non-ripe NCC solutions, but yeah, perhaps we can get some of the ripe tools as well. So, thank you.
Okay, thank you very, very much. Lots more discussion this week. So now we have Petros talking about OpenPenny and, goodwill, because there will be a live demo in this presentation. So all the good vibes, please.
Okay, step one. Hi, everyone. My name is Petros Gigis, and I recently finished my PhD. And today I'm going to talk about OpenPenny. And OpenPenny is a new open source tool that helps you identify legitimate non-spoof traffic with high accuracy. And the idea is simple. If we cannot trust the observed traffic and we cannot really know if it comes where it claims to be from, many operational signals may become unreliable. So I will start my presentation with an example. Let us consider that we are in ISP and we have multiple presence points around the world. For example, we have in New York, Rome, and Tokyo. And we have a regional ISP in the UK that operates within the area of the UK, and our ISPA provides global transit. We expect traffic to arrive to the ISPA through POPs that are nearby to the UK, for example, a POP in Italy or a POP in North America. And this depends on the routing. And we have tools. We can use existing telemetry. We can use traffic volumes, packet counters, technologies like NetFlow, SFlow, or even we can rely on routing data like PGP. And at some point, we observe traffic with source IPs of ISPB coming in an egress point that we've never seen in the past. And we now start wondering what's really happening. Did something change on the routing? Or there is an anomaly? Is there a route leak? Is there a policy violation? And normally, based on the fact that we have, it's like, okay, we are seeing this source prefix coming in Europe or North America. Now we see it coming somewhere else. And everything suggests that we have a routing change. And depending on our objectives, we may consider that this shouldn't be happening or it's something that we can accept. But whatever is goes, no issue. The incident may be directly misleading. And this can happen if in the case of the traffic that we observe in our POP in Tokyo, we're receiving traffic from someone else, which is spoofed and uses source IP address space of the ISPB. And in that case, we run into this ambiguity problem. We don't know if there is a valid routing path between the ISPB or someone is just sending spoof traffic. And just looking on packet counters or traffic volumes or routing data alone, it cannot tell us if the traffic comes to our POP through the source that it claims to be from. And yeah, we may wonder, okay, why this matters. So if we get misled and we think that there is a routing issue and we start troubleshooting, we start spending time on a routing issue that never existed. And if we can accurately tell that the traffic comes where it claims to be from, we can confirm easier customer provider policy violations, and we can also detect unexpected route changes based on the data plane. So the problem here is not looking for spoof traffic. We are focusing on finding legitimate traffic very reliably. And next, let's see an example of a stealthy BGP hijack. In this graph, there are 6 ASs. And let's consider that ASB announces /16. And we can see how the path propagates towards ASA. And also ASA, AS3, they implement ROV, while AS2 and AS100, they don't do. At some point in time, a different AS announced a more specific /24, but it's part of this /16. And because the neighbor AS100 does not implement any route ordering validation, the update propagates, and then it's being propagated to the AS2. And as soon as it reaches AS2, and is being sent to ASA and AS3 in this live example, it's going to be filtered because there is no route of entry. And yeah, the destination of the /24 can detect this because the traffic will not reach the destination, so we can see that there is a drop in our traffic. But what if AS101 tries to make it more smart and reroute the traffic back to the original path? In that case, the traffic still reaches the destination, and if we don't have a vantage point within the ASs that installed the /24 route, we cannot see it on the control plane. But what if we could look on our ingress points and we could reliably tell, okay, I'm seeing now traffic from source, from IP space of ASA coming somewhere that I didn't expect. And again, without being able to tell it reliably, we run into this ambiguity problem. And we wonder, okay, is it a real path change or is it just spoof background noise? And unfortunately, from control plane, it's almost impossible to get it reliable. And the existing tools, they're very useful. For example, we have RPKI, which can tell us if the origin is authorized. We have tools that do BGP monitoring, but can tell us if the route changed. We have NetFlow, SFlow technologies that can detect where the traffic is coming to our network. But none of these tools can tell us reliably if the source of the traffic that is coming comes from where it claims to be from, or is just spoofed noise. And with this new open source tool, OpenPenny, we are trying to add this missing data plane signal in observability. Now I will move to the second part of the presentation, where I will give you an intuition of how OpenPenny is built. So OpenPenny has two modes. The first mode is a passive mode, where it doesn't interact with the traffic, it just observes flows. And what it tries to do is it tries to find suspicious aggregates. And the idea there is that if we see something that is shouldn't be ingressing there, maybe we can see the patterns. And if there is something in the patterns, we can move to a more intrusive testing mechanism. So as I said, the passive mode collects TCP flow statistics. It looks for per packet load balancing. It looks for out-of-order packets. And it also looks for flows that they were arbitrarily terminated or they are unstable. And the second mode is the one, it's the most interesting one, where we test traffic behavior. And the idea there is that we are trying to find some legitimate flows, some flows that we can be very high confident that they come from the source that they claim to be from. And in order to do this, we rely on a probabilistic mechanism that they developed as part of my PhD. And the idea is the following. If we have traffic coming somewhere that we didn't expect, it may be already problematic. So what if we tweak a very small amount of the traffic? For example, if we drop a few TCP packets and wait to see if the protocol, as the standard says, is going to retransmit the missing byte, the missing packets. Of course, just dropping 1 or 2 packets, it's not reliable because we have to deal with TCP queries, we have to deal with external losses. We want to minimize user impact. We don't want to drop retransmission packets to cause a TCP to further step back. And we need to be aware of people that they know how our mechanism works, and they will come up with a pattern but try to bypass it and lead us to a false conclusion. And through simulations, we have seen that if we drop 12 packets across thousands of packets, the chances for an attacker to bypass it is 1 in a million. And if you want to read more about the mechanism and all the different implementation concerned, you can refer to our paper in SICOM 24. So let me talk about the tool itself. So currently, the tool is under active development. It's experimental software. It's on the GitHub. And it supports fast packet processing. To do that, we use eBPF, AFXDP, and DBDK as packet processing engines. And instead of we are just bypassing the kernel and we do everything in the user space. It supports flow aggregation, and we can do tests across multiple flows, which further minimize the impact on the traffic. And it supports two interaction modes. One is through a CLI, and the other is through gRPC protobuf. And we have tested this on UCL, on real x86 servers, and we have seen that we can cope with tens of gigabits of traffic. Our deployment model that I have in mind is intentionally simple. So the idea is that we have an x86 box in our network, and whenever something doesn't look right, we just send a small traffic slice of the traffic to the x86 box for a few seconds up to maybe a minute. And then the x86 box openpenny processes the traffic and redirects the traffic back to the network. So it doesn't require any modification in the network itself or changes in the switches or routers. It just requires some of the ACL's rules to do the matching of the traffic and send it to the port that the openpenny is connected. And let me summarize what openpenny can help you achieve. So you can reduce false ingress alerts in your network by verifying that the traffic that is coming where it shouldn't be is legitimate. Because finding legitimate traffic at the ingress point means that there is a valid routing path from your ingress point towards the source. So it can lead to more trustworthy ingress observations. It can give you some additional visibility on stealthy path changes, and maybe can use for evidence for policy violations. The tool is available on GitHub on the following link, and it comes with a BS2 closed license. If you have time to contribute, if you have issues or ideas, please free to interact through the GitHub. I have also published a RIPE Labs article describing the tool and our vision for it. And as a final part of my presentation, I have set up a testbed, which consists of 3 x86 boxes. We are using one switch and links at 100G. And in this demo, what I will do is that I have one x86 box that is used as a source and one x86 box that is used as a destination. And initially, traffic goes directly through the switch, and the return path is again through the switch between the two nodes. And when I'm configuring openpenny to start testing the traffic, there is a command in switch starting routing the traffic to the x86 node, and then the traffic is being redirected back to the destination. Okay, so in the terminal on the right is the box that runs openpenny, and in this setup I'm going to use the daemon, which talks with the gRPC protobuf. We need sudo because we're installing eBPF rules. So the next step is I'm going to send a gRPC message to instruct the daemon to install the rule in the eBPF and forward the traffic to the user space. So the message look like this. So we are specifying what we want to match on. We can do 5-tuple matching. We can do prefix matching based on source, destination, port, protocol. In this case, I'm just doing TCP on destination port 5201. And then there are some internal mechanisms of the tool of how many packets drop, what is going to be the probability, when to stop, how many flows to try, and they're all documented on the GitHub. So in this case, we are dropping 1 out 1,000 data packets. But again, this is across multiple flows, and there is an upper bound on the number of drops set to 12. And now I'm going to, sorry. Yeah, that's a demo effect. This is not normal. This is a new bug that I've never seen. I don't even get what it's doing. Interesting. We have a video. Can we play? If I try to do it 1,000 times, it's not going to end up like this. Is it possible to use the video? Okay, this is the page on GitHub. And this is the architecture. So we have the AFXDP, AF packet if we want to do just mirroring for the passive mode. We have DPDK, and we have 2 pipelines for the hot path. One is for the active mode, the other one is for the passive mode. And this is what I was telling you previously about how you can configure the gRPC. In this video recording, we are using 5% packet drop probability. Again, we are setting a max of 12 packet drops. And yeah, we also instructed stop after finding free, after full testing free flows. And yeah, again, we start the daemon. And here we send the gRPC message. So the rule is installed. So we add in the BPF matching rules. So now everything bypasses the kernel. It comes to the user space where the app is running. And the first part of the demo is we are testing legitimate traffic. So we are, the outcome is going to be that, okay. Maybe. Yep. So it's lightning fast because it's we just look on a small fraction of the traffic, and our test is we drop 12 packets across multiple flows that started with IPF. These are results on I think it's in 2 CPUs, and yeah, we can see the overall packets that were being processed since we reached the outcome and penny returned. The outcome is closed loop, which means that the traffic is legitimate. And in the second example, there is a case of mixed traffic. So we have both spoofed and both legitimate traffic, and we still can detect legitimate traffic there. The concept there is that if we have the aggregates and we reach the outcome that there is no closed loop flows, it's spoofed, then we switch to individual flows and we have a number of flows that we test. In this example, for example, we detected the 2 IPF flows that are legitimate, and then we have detected 19 TCP flows that are spoofed. And the goal is that I'm generating traffic patterns that mimics exactly spoof traffic. So we can see that in the individual flows, we dropped 6 packets, but we didn't see any retransmission. So very quickly, can you switch to my screen? Okay, very briefly, so the idea is that spoof traffic can add noise on monitoring systems, and OpenPenny focuses on finding any small portion of legitimate traffic that is coming with a single response, because this proves that there is a routing path between the source and the destination. The project was funded by RIPE-NC Community Projects Fund, and we are very grateful for this. And if you want to use it, try it, or if you have ideas or any feedback for it, you can come to the mic or find me later during the coffee or lunch. And yeah, thank you.
Okay. We have at least one question.
Jelinkova. Sorry, I probably missed something very simple here. In TCP, if your handshake completed, it gives you a very high confidence that connection is not spoofed. What is the point of trying to verify TCP flows instead of just looking at handshake?
Yeah, that's a very good question. Unfortunately, you can do this, you can get the signal only if you are a company like Cloudflare that does this, or Google or Meta, that you terminate the connection. If you're just an ISP that you see traffic transiting through your network, you cannot know what the underlying traffic does. So the tool is built for networks that are sitting in the middle, and they don't see any state about the connection.
Okay, so you're mostly looking at the asymmetrical traffic flow, but you might not see the response at all, right? Okay, I see. Thank you.
Any other questions? Nothing online, Clara? Okay, thank you very much. Okay, and our third and final presentation in this session, we have Elise and Fred, who will be talking about redefining Netflix's BGP architecture.
Ready? Does it work? Can we hear me? No. I think we can. Hello, everyone. I'm Elise Meneges. I'm a network architect at Netflix, and I'm here with Fred, my co-presenter, principal engineer at Cisco. So before we dive in, a quick show of hands. Who here is still running some form of BGP full mesh? So we still do, okay. So quick few hands raised. So we're gonna discuss here today, we're gonna present you what we've done. It's not the one through BGP design, it's just what we came up with, and that suits our needs for what matters for Netflix. So I'm gonna present you with what BGP architecture means for Netflix and how we operate our network. And Fred will take over with the technical solution that we have designed and we've deployed. And we will carry on with the validation process, what we've tested, how we tested things, and how we make sure basically that everything is working as expected. And I will present you with the migration process and the telemetry that we set in place to make sure that the migration is successful and easily tractable. And we will end up with the lesson learned and the conclusion. So let's. So what is our BGP Netflix architectures? So today we operate Open Connect backbone, which is smaller than Meta, by the way. So those numbers can look high, but they are not so much. So we are in the multi-terabit territory in terms of peak traffic delivery. We rely heavily on caches, so both on our network and inside our ISP partners. So they deliver the traffic and they operate BGP as well, so that we know where to steer the traffic to. And we operate in 175 countries over the world. So it represents 90% of the people almost. And we have like 400 point of presence worldwide. So you can see on the map, all the blue stuff are where we are located. both from an OCA perspective and our footprint in terms of network localization. And from an edge routing perspective, we have 20,000 BGP sessions, and we peer with nearly 3,000 different ISN over the world. So as you can see, we are a heavily peer network, and it matters when it comes to BGP. We have to take it carefully because that's what is basically delivering the traffic under the ground. So I will describe quickly the function and the different network devices that we operate in the backbone. So we have the edge switches, which are basically router, but call that, from the back in the day. So they are basically connecting the OCA, which sits our border, the caches, to our peering partners, and they run iBGP for what the mesh is about, and eBGP with our partners. We also have new kind of devices, so aggregation router, which aggregates the gaming appliances, which are sitting in our data center and not in the ISP partner network at all. So that's different, and they basically connect to the upstream ESCs, and they could be remote in the metro. And those are mostly iBGP, so both V6 and V4. And we have on the right-hand side for you the provider edge, which connects everything internal to Netflix. So offices, but also studio and M&A, and so VPN v4, VPN v6, and basically the entry point for everything internal to our network. So those are the basic, BGP function that you can see in any kind of network. That's how it relates to us. And this is basically the current, not so much current anymore, but that was where we were coming from. Everything was iBGP full mesh between ESCs and PEs. And we do have OCA, which are eBGP, and OCGA, which are the gaming appliances, doing eBGP. Same for the LR, which has basically everything internal. So easy to operate, easy to reason about, but the thing is the scale that we are operating at means that every single device has to manage an 1,000 session, like only for iBGP. So it doesn't scale well, not easy when you want to modify any policies to exchange routes. We don't have to do that so much because we don't carry user traffic over the backbone. We steer the traffic at the nearest point of exit. So, but with gaming, that is a new services that we have to onboard. That change the way we operate, and we may have to carry user gaming traffic over the backbone. And as such, we need to now exchange routes within our backbone. So that's the main, drift from what we were doing like for quite a long time, and that was, okay with the iBGP mesh. So we didn't have any need before to move away from that mesh. So that's the reason why we did that right now and not before. So when it comes to defining the new architecture, I think, getting a clear sense of where we want to go and what we want to achieve is key. And so scalability is definitely something that we have to manage, and that was not something that was easy with the iBGP mesh, sorry. Automation, that's something that we heavily rely on, so no problem at all, even with the mesh, everything was automated. But having like something more centralized and more easy to manage and flexibly adjust is definitely something that we need to develop and carry on with what we are doing now. And the resilience, obviously, that's, we cannot offer to fail. So that's definitely key. And observability, which is what is matter for what, when you operate at that scale. So over to Fred for the technical solution.
Thanks, Elise, for the project introduction and the project goals. I will now walk you through what we have deployed together at Netflix. When trying to move away from iBGP full mesh, there are not hundreds of possible ways to do that, essentially. The first way would be to use BGP confederations, but they tend to be obsolete. They're not very flexible. They are very hard to operate and manage, and they're not really widely deployed anymore. On the other hand, BGP Workflow Vectors are field-proven solution, and they can scale very high. Like we can build a certain level of hierarchies if the scale requires that. And this is the solution we have chosen to deploy at Netflix. And what we have decided to go with are dedicated off-path Workflow Vectors, meaning those Workflow Vectors are only dedicated to handle BGP control plane traffic. They're not taking part of the forwarding plane at all. When deploying BGP Workflow Vectors, there are a couple of architecture questions you need to evaluate. How many of them do you need? Most likely more than 2, but how many more if needed? Where should you deploy those Workflow Vectors? Obviously, it matters. You will see later what we have decided to do. How should you interconnect them in the backbone? At Netflix, for example, we have decided to dual attach each Workflow Vector to 2 individual ES routers to maximize their availability. What we have done as well is we've been using 100 gig interfaces. Those are, to my knowledge, the first 100 gig Workflow Vectors available on the market. Not necessarily we need to process and handle 100 gig of BGP traffic, but we wanted to stick with a standard. And today the standard in the backbone are 100 gig LFO. So just make things easier to deploy. For the rest, the design was very conservative. I would say it has to work. It has to be very stable. Those are very critical pieces of equipment in the network. So we stick with BFD over IGP as the rest of the backbone for fast failure detection to switch over BGP traffic inside or between the different ES. But for the rest, we were very conservative. For example, we are using the default BGP timers. Nothing crazy. One key problem of BGP Workflow Vector is they are introducing suboptimal routing, and we don't want to do that. With full mesh, you have optimal routing. There are 2 ways to mitigate this. The first way is to use BGP optimal route protection, which is doing what it's supposed to do. We didn't go this way for the following reason. The way BGP OR works is essentially you configure a number of routes on the Workflow Vector and you put clients in specific groups. But the more groups you have and the more BGP path you have on your Workflow Vector, the longer it will take to converge. So we didn't want to go this way. And instead, we went with the following design. We are using BGP additional path. And what we are doing is we are doing BGP best path plus backup for internet routes. So the 1 million V4, 250 KV6. And for the rest, for tactical routes, which are flagged with special BGP communities, what we are doing is we are doing BGP additional path all, meaning we are sending everything to the clients and we let the clients work. Now we have a design, we have to pick up a platform, a solution. This line is, this table summarizes available options on the market. It's vendor independent, right? Every vendor on the market today is able to provide those different solutions. There are traditional routers where the main function is to perform, I would say, traffic forwarding. You can decide to go with a VNF. It can be like a virtual machine or a container, for example, that will run over a virtualization layer. And you can go with a fully integrated appliance where essentially the network operating system is running bare metal over a big server. Essentially, what we want for BGP Workflow Vector is scale, performance, and what's better than a big server which has a lot of CPU and a lot of memory. The good thing is there are no bad options. All of those form factors, they can do the job right. But for picking, I would say, the right solution, there are a couple of criteria to evaluate. Some of them are technical. For example, scale, performance, do we support control plane protection, etc. Some of them are not technical, I will say, related to organizations. Like, for example, if you decide to go with VNF, is your operation team capable to deploy, operate, secure, and optimize the underlying virtualization layer? So for Netflix, we decided to go with the appliance way, which was providing the best performance available. RIPE is also a good opportunity to share with the community the best practices. And here again, those are not vendor specific. Those will apply to any solution that you have already today. What I'm summarizing here are different things you should do today. And if you are not doing that today, maybe you should reconsider them. I've grouped them into several families: security, scale, convergence, and resilience. For security, for example, you definitely want to make sure that you are doing control plane policing and you have the right values, right? Not too low to make sure you are converging fast, not too high to make sure you're not causing collateral damages or hitting other bottlenecks on the route effector. For scale, a couple of techniques available as well, especially if you have a high number of clients. You might let the clients to initiate the BGP session. It's specifically useful whenever you are doing software upgrades, for example, the route effector. So instead of the route effector trying to initiate 2,000 BGP session at one shot, you let the clients initiate the BGP and the TCP session. Similarly, when you are using off-path route effectors, you are not in the forwarding plane, so you don't need to install all those routes in RIB and ultimately FIB, so you can skip those using some filters. For convergence, a couple of techniques available. If you are doing VPN v4, VPN v6 address families, consider using route target constraint to do some filtering. You also want to make sure you are packing as many BGP updates as possible inside an IP packet, and you want to leverage the whole MTU of the network. So enable path MTU discovery, if not enabled by default, or fine-tune TCP MSS to make sure you are packing all those BGP updates. Most BGP stack on the market and industry today are using the concept of BGP update groups or peer groups. Not only it helps, I would say, dealing with configuration, but under the hood, it's also doing some optimization. Like, for example, we are building BGP update once, and then we replicate across all the clients, which makes things very, very efficient. Why it's very good to speed up convergence? It also has some constraints, I will say. It's because if you have a single client which is part of this update group, which is a little bit slower, it will slow down the rest of the group and it will impact negatively your convergence time. So you literally want to make sure that you deploy something which is able to detect those slow peers and also mitigate them. And the way we do mitigation is we isolate those clients, those slow clients, in their dedicated update groups. Those are the production environment numbers. As Elise was telling you, we're operating at very high scale here. There are big differences between the different regions. The smallest one is LATAM with over 4 million BGP paths. The biggest one is obviously North America with almost 50 million BGP paths, 50 million BGP paths. There is a pair of effector per geography. Single cluster per geography, and we have a full mesh between the different route reflectors. So again, like very simple design. And as you can see, what we have done is we have placed those route reflectors as close as possible from their clients. So for example, there are regions in the globe where there is no deployment yet. So it was not making sense to deploy those route reflectors here. Obviously, before deploying those things in production, we went through a validation phase. And what we've done together with Netflix is we entered after the vendor validation and proof of concept into what we're calling an early field trial phase. It's a process at Cisco where we co-design, co-build, co-test the products while they are still under development. It's a win-win partnership because it allows customers to speed up their validation cycles, and it also allows vendors to expose and test our solution outside of our of our lab. So the idea is to catch and fix before deployment. I would lie you, telling you we didn't have any issues. Of course, there are things we could not catch in the lab and even in production. Things related, for example, to telemetry at high scale, like you need the production scale to be able to catch those. Other than that, it was very traditional validation. I would say we had a document with a list of tests. We wanted to execute it. We consolidated everything. Here on this screenshot, what you can see is the production convergence time for IPv4, multidimensional, meaning behind the scenes, IPv6, VPN v4 and VPN v6 are also converging. And I believe that was after like a route protector reboot to make sure everything was working fine. So 30 minutes to converge 50 million BGP path, which is pretty fast. Are we now over to Elise?
Thank you, Fred. So the big question is, how do we get there? You know, like from a design and a concept into getting into the real world of our backbone. So we come up with a phase migration so that we can run the two control plane, the mesh and the new era, in parallel, so that we can safely and smoothly migrate from what we are running today to what will be run tomorrow. So in 2025, when we first started getting the device, we started with the on-site installation and turn up. So pretty easy, depending on the country you are sending those boxes to. Then we came up with the staging. So basically the root reflector will pair with the ESCs, be part of the IGP mesh. And then we define some pilot prefixes. So one pilot prefixes per address family with a specific BGP community so that we can track those pilot prefixes. Up front, being able to release all the advertisement from the router so that we can basically mimic and compare and validate that the configuration on the root reflector were acting as expected. So that was a very interesting phase so that we were able to spot if anything was going, you know, weirdly in terms of advertisement of those pilot prefixes. And then we've released the advertisement from all the devices to the root effector. So that's the point where we were basically able to assess the scaling limits of the boxes, but also all our tooling against those root reflectors. So that's when we spotted the GNMI issue that was basically triggering a 99% CPU utilization on the boxes because we were using a young specific model that is not the open config model, that was not optimized on the root reflector. So basically we were passing all the table every minute. So that was too intense for the boxes. So that was a good step to basically assess all everything at scale before we were able to do the next phase, which is a per device migration, meaning that we just set a tag on the per device basis, and it will trigger the deployment automatically to the client. And it's what it does is basically adjusting the root policy in, out on the root effector and on the client. So the way we did it, such that it doesn't impact the traffic, is basically we release the advertisement from the root effector to the client, but we don't pref on the client side when we receive the prefixes, such that we can easily compare what we receive from the mesh, what we receive from the root effector. The root effector is not the preferred path, so we still operate as previously. And then we swap that pref when we are confident that the route that we have on the client is what we are expecting to have. So we swap the preference tag so that basically we just swap the preference on the route policy and we prefer the root effector route over the mesh route. So that has been done on the per device basis over all our devices per batch when we were confident enough that we knew for sure using some scripts to basically do the comparison before after. And we migrated all the devices to this new state, so we still operate both. So in case we are not covered with the root effector, we still have the mesh, and we are now at the stage where we shut down the mesh at the peer group level on the client, and we leverage only the root effector routes. And the final stage will be to remove the IBGP mesh, obviously. We rely heavily on the BGP community to tag routes so that we know what we receive and where those routes need to be reflected. That's how we basically fine-tune and filter what we send back to the clients when we know that that route is needed on that client. So that's something additional I didn't mention before, but that's the way we reduce the number of paths that we reflect back to the client, because we cannot send 50 million paths, obviously. We came up with some telemetry because that's the way we thought was easy to operate and monitor that the migration is going on the right path. So we mostly target open config model so that we know that we can reuse those paths for every devices in our network, depending on independently of the vendor, basically. We monitor the BGP session counts, session established on the route reflector, so that we know if anything goes wrong at any point of time. And we also monitor the number of routes received and pass count per address family and what we reflect back to the client. So it gives us like a very good view during the migration and even after, if anything needs to happen on the route reflector. BGP telemetry. And then I end up to Fred for the lesson learned and conclusion. Thank you, Fred.
Thanks. So there you have it. This is our story together with Alice and Netflix. No AI, good old BGP routing. We are done, finally. It took us more time than initially planned, honestly. It was supposed to be a simple BGP route reflector project. But like networking in general, there are always things going on. But we are not done with migrations now over, so that's good. What's rewarding for us is that we did all those changes and implemented this project without, I believe, breaking anything, and like nobody noticed anything right on the network. And it's also allowing Netflix to deliver new services such live and gaming, which were not possible before. There's still a couple of things we'd like to do, a couple of projects around visibility, especially. We are doing BGP telemetry at high scale, at high frequency, every 30 seconds. But remember, telemetry is all about streaming states or counters. And now we would like to go deeper. And to do that, we have to leverage on BMP, BGP monitoring protocol. And that will be most likely the next project that we work on together. Again, still some architecture discussion to consider. Should we enable BMP on the route reflector and leverage this central point, I would say, of control plane to get full visibility, or should we distribute BMP instead on the border of the network? Yeah. That's it for today. I wish you an excellent rest of the week at RIPE. We are happy to take any questions during the Q&A section, or even afterwards if you want. Thanks, everyone.
Costas Orbadelos, entity Gene. Far from a simple project, really impressive, changing the plane on flight.
Yeah.
So a couple of questions. The first is rather rhetorical. So from what I understood, you went with the Cisco solution for your route reflectors.
Yeah.
I guess it comes from your presentation.
Yeah.
The question was, do you rely just solely on a single vendor for this? Wasn't there a concern there? Do you deploy multiple vendors, or do you plan to do it?
So today we have two sides of the coin when it comes to delivering the traffic at Netflix. So we rely on the route reflector for everything networking related. And when it comes to serving the client, we also have like Bird Stack which basically gather all the routes from the ESCs and at the local, IX sites. So, and that is what is feeding the steering today. So we have two basically control planes. One is for the backbone itself, and one is for the customer delivery traffic.
For the backbone, you just utilize the single vendor
Yeah,
solution?
we run Arista mostly on the client side, and we rely only as of today on the Cisco stack for the root effector.
Thank you.
Yeah.
Tom Strix, Cloudflare. Again, yeah, it's super difficult to change the engines on the plane in flight, so super impressive. One question, as an operator of a pretty large network, we need to do quite a bit of traffic engineering on a day-to-day basis, especially in our edge, to mitigate congestion, things like that. Moving to a route reflector setup has massive impacts on kind of how you do traffic engineering on a day-to-day basis. Was that an impact that you noticed on your operational teams? Is that something that you needed to consider at all? Like, is traffic engineering even a problem for Netflix to begin with, I guess?
So by traffic engineering, you mean traffic engineering when you steer the traffic to the client?
No, when you steer the traffic, I guess, to the eyeball that's requesting the data that you have through your backbone. So you have to change an upref, or you need to change an interface, or you need to reroute through the broken backbone.
So the way we steer the traffic is we own the client and we own the server, right? So we just send a trigger to the client to re-steer. So that's the way we are, operating the steering at Netflix. And it's not based on the root reflector today.
So
It's
you
based,
don't have to do any BGP traffic engineering at all?
we do, but not for customer delivery traffic.
Okay, perfect. Thank you.
You're welcome.
Thank you.
Blake Willis, BGP Geek. Thanks. This is really great return on experience from a large network. I wanted to ask if you were using BGP prefix independent convergence, if you had that enabled. I know it's super useful for L3PN.
Yeah.
If you had it enabled in the rest of the network as well.
Yeah, we do. Everything is enabled so that we do.
I found that enabling BGP PIC just on the normal internet address families kind of mitigated the need for extensive optimal route reflection or add path, because it always installs a second path anyway. And so you have like a protect path that it will use and multipath and stuff.
Yeah, that's a very valid point. The reason why we had to add path is because we want to reflect some route from some metro to some other metro, and because the route effector are very,
centralized.
Yeah, centralized. We need those add paths, and we compile those paths and use the BGP community to match on those community that define the metro, so that we know for sure that we are reflecting the right path. So for us, PIC wasn't enough for the use case that we are trying to solve for.
Thanks.
Yeah, you're welcome.
Paolo Lucente, NTT, and co-chair of Grow Working Group at ITF, where BMP is being standardized. So BGP telemetry is very important. I was curious why you went let's say the open config way.
I can tell you the story. That's
right.
for me.
So I was curious whether it was a limitation in the protocol or in the implementation.
Yeah.
And I have a second thing, which is like there is quite some work being done right now in the working group around the use case of BMP on root reflectors.
Okay.
So I guess your experience with this deployment would be very beneficial. So if you want to at some point take it back.
Yeah, I can take the two questions. For the second one, I think most likely you are in touch with people we work with already. Happy to have Netflix participating in this working group as well. For number one, this is the story. We initially went with the Cisco Yang model because they were richer. The thing is at Netflix scale with 50 million BGP path, and at very high frequency, like every 30 seconds, what we encountered is, I would say, a suboptimal software implementation in iOS XR. And it turns out we had optimization done for the OpenConfig model, but which was not backported to the Cisco Yang model. Ultimately, that was a good thing because, as Elise was saying, we wanted to standardize as much as possible on OpenConfig. So we have one model to rule with the role reflector and also the clients. To add a precision to what Elise said, the whole role reflector was not under 99 CPU utilization, right? iOS XR BGP process is multi-threaded. Amongst all the BGP threads we have on iOS XR, there is one responsible for management stuff, which handles telemetry, show commands, etc. And that was the single BGP thread which was going iCPU. And again, the quick fix was to switch to the OpenConfig model, which was not exhibiting this behavior because we had caching optimization. We were not working the whole 50 million BGP path per individual clients. What we have done since is we have backported the OpenConfig optimization back to the Cisco model. So now you can use whatever you want, it will work. Yeah.
Thank you.
Thank you.
Okay, great. Thank you very much.
Merci.
Okay, so that concludes our session for now this afternoon. Please rate the talks, nominate yourself for the PC, make sure you register for the GM, and enjoy your lunch. Thank you very much. All right. Welcome back to the afternoon session. Please find a seat. Turn off your phones because we are about to start. We have all the speakers here. We found Gerhard. So please find your seat. Okay, do we have something to read? Hang on.
at the end. Okay. All right. Well. Okay. So our first talk for today is Tobias Fiebig with "It's Coming: Time for IPv6 in the DNS."
Am I audible? I'm not working. No, I'm working. Well, not working is also kind of true. I'm kind of an academic. So welcome, everyone. I'm Tobias Fiebig. I am now affiliated with TU Vienna since the 1st of March. So a little bit of color change in the slides. And today I'm going to talk about RFC 3901 BIS, a fresh start and a fresh look at the IRC editor's queue. So what is RFC 3901? It's the DNS IPv6 Transport Operational Guidelines. This has been published in 2004. And the bottom line is that recursive DNS servers should be IPv4 only or dual stack. And also authoritative DNS servers should be, well, actually, this should say authoritative, not recursive. Anyway, they should be v4 or dual stack, and v6 is more like a maybe, kind of may if you want and feel like it. All zones should have at least one IPv4 name server. Again, IPv6 is explicitly optional. And zone validation, if you are delegating a zone and are testing the name servers in that delegation, that should test IPv4 functionality. IPv6, well, maybe, if you feel like it, but not even mentioned. And at IETF 118, I was approached by my co-author, Momoka, who thought, well, it might be a good idea, given that it is kind of 2023 at that point in time, to start doing IPv6 in the DNS. So we gave that a shot. Question is, why wouldn't we want to change RFC? By the way, Jan, could you please set the clock? Cheers. Cheers. Clock, please. Thank you.
They're paying lots.
So why would you not want to change RFC 3901? This has been, at that point in time, a roughly 10-year discussion, as documented by this really nice blog post from 2015. Well, IPv6 does not allow on-path fragmentation, so if the packets get too big, they, well, have to be fragmented at the end sites, and they might not make it if they're fragments. Path-empty discovery is notoriously difficult for IPv6. Well, it's kind of also difficult for IPv4 these days, but it's just difficult. There is this high fragment drop rate, which will maximally inhibit DNS key records, because they tend to be bigger than 1,500 bytes. TCP fallback, even though we were told to run DNS servers that do support TCP ages ago, does not always work. And with DNSSEC on the rise, because we all have deployed DNSSEC, right? I did. Everyone else? Anyone else? No. With DNSSEC, this gets an even more pressing issue. So there's a couple of counter arguments you can make to this, also brought forward in this 10-year-old discussion. At the moment, all TLDs are on dual-stack authoritative name servers. If doing that would be a problem, we would not be able to resolve TLDs, especially not with DNSSEC, but we can. Path-empty discovery is not that bad, and it's also bad for IPv4, so it doesn't matter in which IP address family you fail. Fragment dropping is not that bad, or you might be able to fix it. TCP fallback is in fact often used already. DOE and DOC exist, and DOE and especially DOC, so DNS over HTTP3, they really suffer from broken IPv4 connectivity with CGNs, as was brought forward by some vendors during the discussion of 3901 BIS, because the timeouts on the CGN is too short, and usually these DOE connections are long-lived UDP connections, and well, then they break off because state expired. And then there's also RFC 9715, which is limiting the EDNS 0 size. People are deploying that, it works, and open source developers are actually looking at even lower EDNS 0 values than suggested in this document. In addition to that, we ran some experiments. We tried to resolve the Google Crooks top 10 million using a minimally covering an asset. That's an idea from Peter Bacek. Basically, idea being that you hit each NSSEC at least once. Once for DNSSEC, once for no DNSSEC. So you get a maximally wide perspective on different NSSECs while not causing too much unnecessary traffic. And I mean, I don't have to check the Cloudflare DNS servers roughly, I think, 1 or 2 million times in the Crooks top 10 million. It's kind of pointless. They behave the same. We also implemented different MTU scenarios, so just standard internet MTU, MTU 1500, and we put an MTU of 1280 on link, so on the link of the box, which means that the box is aware of the lowest MTU on path, and did that with working path MTU discovery. We did the same with broken path MTU discovery, so dropping packet to back messages, and then we also did it on an on-path MTU break, so the box was on an MTU 1500 link. Further down the path, there was a break to 1280, and then it onward continued with 1500 out of the AS. And in addition to that, we also tested it once via a mix of tier 1s and once via LGI. So all inbound traffic came via Liberty Global. Why did we do this? Because rumor had it that Liberty Global actually dropped fragments, IPv6 fragments on transit. So what did we see? Overall, resolvability is mostly comparable. Surf fail, interestingly, for no DNSSEC is around 33%, which matches up roughly with the 60-65-ish% IPv6 resolvability we measured across the board in earlier studies. It's lower for zones that actually do DNSSEC. It doesn't mean that DNSSEC makes your zones resolve better over IPv6. It means that people running modern protocols on modern software supporting modern standards like IPv6 also tend to use DNSSEC and the other way around. Some IPv6 packets end up getting packet too big at EDNS 1232, which was also interesting because apparently if you send a packet of size 1280, something on path might decide that it might be fun to add 8 bytes more. Most likely atomic fragment headers of middle boxes. There's a small baseline of broken NS. So name servers that have broken IPv6 setups, but IPv6 addresses are in the DNS. This is something that would be caught by actually testing IPv6 resolution when delegating zones as well. For some weird reason, we saw more fragments for IPv4 at EDNS 1496. And that might be a typo because I wanted to say IPv6 there. And for broken path MTU discovery, IPv4 has more timeouts with DNSSEC at EDNS 0 set to 1232. We also found the kind of expected high fragment drop rates. One tier 1, so LGI, used to drop IPv6 fragments on transit. They put in, after they got note of this, after the IETF meeting in Bangkok, 122 in March last year, a lot of effort to get this fixed in 3 months, which still hugely impresses me because changing security policy on all border routers of a tier 1 within 3 months, including labbing and deploy, is, I think, impressive. And actually, when we had compared the values, like the resolution values for working fragments and not working fragments, so via LGI, not via LGI, it also kind of looked the same. We do this with RFC 9715 compliance, or rather the more strict interpretation of open source developers. There's no notable difference. And with EDNS 0 set to 4096, in the worst case, there's roughly 1% more TCP fallbacks. Again, with DNSSEC, even a bit more. And the difference in timeouts, which we see, is basically non-existent. So with all of that out of the way, we were able to get adoption for the document in the DNSOP working group. It went through working group consensus. It went through IETF last call, and it went through the IASG, and it is now sitting in the RFC editor's queue. So, one note, all of these measurements that you have seen They were done on measurement.network, which is a project which received support from several members of the RIPE community and the RIPE Community Project Fund. So if you ask yourself what the fees sometimes buy, this is one of the things, like the upcoming 1301 bis. So what do we change here? So we expanded it, like this is a verbatim copy from the changelog in 1301 bis. We expanded the terminology section and aligned it with the newest DNS terminology document. We expanded text on how namespace fragmentation can actually happen in practice. We recommend the use of IPv4 and IPv6 for authoritative DNS servers instead of leaving IPv6 purely optional. We added text for recursive and stub resolvers, which somewhat follows the recommendations for authoritatives, also recommending dual stack operation. We now recommend testing IPv4 and IPv6 when delegating zones. And we added some more strict guidance to IP layer fragmentation handling and guidance on how you handle address family issues on recursive and stub resolvers. Which leaves a question for everyone dealing with DNS, which for one reason or another is, I think, everyone in this room, even the people doing BGP. What shall we do now? Now, so if you happen to be IANA, what I would really appreciate is if you could handle the open IANA task, which currently keeps this document in the edit A state, and consider the IANA requirements which we put in, which is basically updating your own requirements for delegating zones to TLDs. And I kind of suspect and hope that this is what IANA is currently busy with, and that's why it takes so long, because such a document needs consensus and yeah. If you're a NIC, you don't really have to do that much, at least not on your authoritative servers. So this is data up until mid-2022 from an earlier publication, and back then you could already see that 100% of TLDs are actually running IPv6 and IPv4 on their authoritatives, and they are actually resolvable via IPv6 only. Doing 9715 and MSF stamping might be cool, but that's basically just, some additional gravy. One thing to note, though, is that some TLDs are doing better than others. .dev has 94, 95% v6 resolvability. .io, 94. .dk, 85. .nl, 84, 85. And, for example, .it, only 20. One thing to note, though, is there's this little v6 incomplete point there. That means that for, in this case, for example, 34.26% of zones in .it, we found some remnants of IPv6 connectivity on the name server sets responsible for those zones. So, for example, if you do have missing IPv6 glue, but put corresponding IPv4 and IPv6 addresses into the zone itself, so into the child, you might end up in that part. We will get to that in a bit. So, if you're a NIC, you could start asking for v6 as well. You can ask SIDN how you do that. Little hint, money. That kind of works. Ideally ask for 2 times IPv4 and 2 times IPv6, and maybe push people to do 9715 as well. And maybe wait some time with hard requiring it. It's like people will appreciate that. Gives them some time to accustom. If you're running zone checkers, check if IPv6 is there and at least soft fail, like notify. If IPv6 is there, make sure that it actually works. Maybe do some additional testing for 9715. That technically needs a large resource record. And DNSSEC, again, for DNSSEC, you can ask SIDN or switch how you can encourage people to do that. And again, the hint is money. And you should also test the resolvability of out-of-zone NS for each protocol. If you happen to be a registrar, you might want to run the tests recommended for NICs to run on their zone files, just on your customer's domain. If you already did and found customers that are not doing this, poke your customers before your NIC starts poking you with a money-driven carrot in front of your face. Think about poking the biggest hosters not supporting IPv6 among the domains you are registering, which might be you. GoDaddy in 2017, I think, changed the total number of IPv6 only resolvable zones by 17% globally because they added IPv6 glue to their name servers. And there's still a couple of those around. So if you look at the top NS sets in non-IPv6 resolvable zones, it's like a lot of domain parking. So in .at, for example, you have 20% of non-IPv6 resolvable zones just sitting on domain parking. There's Wix.com, which also is an IPv4 only endeavor, which for some reason hosts a lot of zones. And there's also sometimes per TLD champions. So for Vulture, for in other.arper, it's Vulture. And I think we talked about this. I think I had the conversation with them about V6 on their reverse DNS and Amazon AWS, but I heard from a relatively reliable source that they are currently working on fixing that. And I already mentioned .it, which is also funny. Only 20-ish% of IPv6 resolution capability and 34.26% incomplete. So you have some IPv6 there, but it does not really work. And 25.32% of all zones are on one hoster. And this one hoster has kind of broken IPv6. So it uses 4 name servers. All of these name servers do have port A records. 3 of them have even IPv6 glue in the parents, so in .com and .net. One of them, the one in .zz, has no IPv6 glue, but still glue, port A record in the zone itself. However, the name servers for those 3 zones are in a different zone. They are in aruba.it, and they don't have IPv6 addresses. So if those servers would get IPv6 addresses and IPv6 glue, then all those 20%, 25% of zones in .it would be IPv6 resolvable in a moment. So if somebody knows somebody at Aruba.it, please poke them. Like if somebody's a customer, please also poke them. Usually it works better when a lot of customers do it at the same time. So if you're a hoster, roll out IPv6 on your authoritatives. If you already did that, fix your glue records. If you already did that, poke your self-hosting customers. And if you already did that, thank you. You're really helping. As an ISP, it gets a bit more difficult because CGN is a lifeline for people that do not have enough IPv4 for all their customers. They need it. And well, state is, I think, one of the biggest pains in networking. But it might be at the time to make a little bit more state space for your translation tables when it comes to DNS over HTTP, which is somewhat problematic because it's not really distinguishable from other quick traffic, which is an overall big problem, which would go away if we would all be using IPv6. So yeah, difficult. Roll out more IPv6. If you are a transit provider, please consider not dropping IPv6 fragments. If you're an end-user ISP, please also consider not dropping IPv6 fragments also on your CPEs. So a lot of CPEs which you can buy actually come with firewall rules per default that are for dropping IPv6 fragments. If you are just worried about DNS, it also helps if those can just cleanly communicate with your recursors, which are not receiving, which are not behind something that drops IPv6 fragments. Note though, dropping IPv6 fragments doesn't hurt as much as previously believed, but in the end, it might be beneficial while we're at it to just clean that up as well. If you run your own resolver, so please also see the next slides, which is this one. Please start implementing 9715. Or ideally follow what most open source implementations are doing, which is EDNS0 at 1232 bytes. If you are using TCP fallbacks, consider clamping. So just setting a lower MSS. It doesn't hurt too much these days. It might get a bit more painful with post-quantum cryptography and much larger keys. But that sadly takes some time still. Do support IPv6 DNS resolution. And again, on the path to your resolver, make sure that v4 and v6 fragments are not dropped. And if you do, it doesn't hurt that much. If you happen to write DNS servers, it would be cool if you do something which Unbound is doing. So Unbound has this really cool NAT64 feature. So all my personal resolvers are running v6 only, and I configured the NAT64 prefix in Unbound. And then without CLAT, they can just go to a PLAT, get their queries translated, and then they can do IPv4 DNS resolution without actually having v4 in the resolvers. It's pretty nice. It also does a really cool EDNS 0.1232 fallback, which means if it can't get anything going, if you configured it to do 4096 or nothing at all, it sends one query with EDNS 0.1232. And maybe do a bit more logic on IP selection to deal with misconfigured delegations, for example, non-GUA addresses. If you do not have that already, I think most of you actually clean that out. If you build CPEs, software is not wine. It does not get better with age. So there is no need to use software which is, at least in most European states, allowed to drink and drive, not at the same time. Nevertheless, people keep doing that. Do not configure caching resolvers forwarders to be IPv4 only, even if IPv6 is available. Ship defaults that signal EDNS 0.1232 during DNS resolution if you have a forwarder on board. Clamp MSS on device-originated DNS over TCP queries. Don't do weird things to customer network traffic, even if you just build CPEs and do not do transit traffic. And personal wish of mine, maybe ensure people always can install their own OS and OSS your firmwares and do not rely on funny blobs. Okay, this is DNS unrelated, but I have a dream. If you write libcs, maybe count higher than 3. This might sound a bit funny, but actually etc resolve conf on most Unix hosts with a libc actually supports only 3 name servers. That's like hard-coded. However, what comes with this is a problem of doing proper resolver selection if you get multiple possible DNS resolvers from multiple different sources in multiple different address families and potentially multiple different resolution capabilities. So what I would recommend is participate in v6 ops about picking resolver address families correctly. Eric Nguyen has at least an idea for a draft there, and will hopefully become a draft somewhere. And then we at least get some guidance on this, hopefully. I also built a little thing, which happens to be like all of the little things I built, really ugly, and the web interface. But it allows you to give it a FQDN and a preferred resource record, which you would like to resolve. And then it does DNS resolution against a bunch of differently configured DNS servers in different network conditions. So with standard MTU, IPv4 only, IPv6 resolution, dual stack resolution, of course, MTU 1280 on path with no frag dropping and working path MTU discovery, with frag dropping and working path MTU discovery, without frag dropping and without path MTU discovery, and there is a no too much there, but basically an exhaustive iteration of all the possible use cases. The UI is kind of difficult, so if anyone here feels like doing some front-end development, please hit me up. I would deeply appreciate that, and everyone using the service as well. I'm also willing to trade zone files for stats. So all the tests from the previous slides run against a set of zones of your choosing and providing. I'm also willing to provide the biggest single entity evaluations. So that data about like who is doing how bad and who are the most responsible hosters in your zone. I have that for all public suffix list zones. Status December 2025. I'm also willing to offer a broken network as a service. I know some people don't need that as an additional service. They get it as a free add-on. But I'm willing to do it intentionally. So I can offer virtual machines in broken network conditions to run resolvers and authoritatives on. So if you happen to be an open source developer of this kind of software and would like to have a VM in these broken network conditions to see how your software is doing, drop me an email. There is a plan to be at IETF 126 in Vienna to provision boxes where they are needed. And with that, one last call. Roll out IPv6, please. It will solve a lot of problems also of the non-technical nature, which we are as a community currently struggling with. So thank you, and please ask any questions you want.
Thank you, Tobias. Jim.
Jim Reid, unaffiliated. Interesting talk, Tobias. I kind of sort of bury my head in the hands a little bit because this just seems to be yet another manifestation of the general problem of IPv6 uptake. We have lots of problems getting people to deploy IPv6, and concerning the issues with DNS uptake for IPv6 doesn't seem all that different from the problems I have of just getting the IPv6 transport done. However, I've got two particular points to make on your presentation. The first one is to do with trying to get more IPv6 into TLD delegations. I think it's going to be problematical for IANA to do anything there directly.
Yeah, 100% of the TLD delegations have IPv6 and IPv4 and are resolvable. We don't need to get more in there. Like, this is basically the only time where you will hear me say we do not need more IPv6 because we're at 100%.
Well, I thought you were asking for getting more V6 information.
Oh, I'm asking for them to update their guidelines because all the CC-TLDs and other TLDs are copy-pasting from their guidelines because it's easier than writing your own document.
Okay, well, the thing about that is for those guidelines is that getting those guidelines changed would be very problematical. You hinted about that when you give your presentation because of the way in which ICANN works. I don't think IANA can act unilaterally here. They would need to get some kind of mandate from the ICANN community, and that could be difficult to achieve just because anything takes a long time to achieve in an ICANN setting. And I think maybe on the other side of that is that in terms of dealing with that is that for CC-TLDs, it may be better to try and get something done through Centre or a CCT-TLD type community rather than trying to go through the ICANN machinery. You might be able to get more success there, particularly if people like SIBN can exert some influence on their sister registries. That may be a better way, a quicker way forward there. The other point I wanted to make was to go back to slide 7, I think it was, when you mentioned that DNS serve fails were more prevalent for whenever DNSSEC wasn't used. So something, I think the failure rate was saying serve fails were around about 33%, and then when DNSSEC was being measured, it was less than 10%.
Yes.
Yeah, that seems to be very strange. Because to my mind, the DNSSEC introduced new ways to create serve fails. You know, if a DNSSEC validation fails because of a keying error and out-of-date signature.
Oh yeah, but this is before you get the records. So this is a zone of which I know that it has DNSSEC, which I try to resolve, but I cannot even contact name servers.
Okay.
So I run into a serve fail before I get to the DNSSEC part.
Okay, that explains it. Okay.
Eric. Hi, Tobias. Thanks for the speech. Just on one detail on the slide after. Yes, this one. I'm puzzled. So there is a tier 1 that applies a security policy on transit packets.
Yes.
And the security policy was to drop fragments?
Yes.
For V6 only, not for IPv4?
Yes.
Okay.
And they changed that very quickly.
Yeah. Okay, just puzzled there. And the other point, your recommendation about the CPE vendors, are you applying these suggestions to their efforts in IPv6 ops working group when they do work on the CPE requirement?
I actually haven't thought about that.
This could be easy, right? So please do.
Thank you.
Hey, so Warren Kamari, Google. So if you do go down the route of trying to convince more CCTLDs and similar to have these types of policies, it would be helpful to explain to them why this is good for them and helpful to them, instead of what the tone often is, which is like, you guys are doing this wrong. Like, I think a reasonable amount of the tone in this was, you people are doing it wrong and should do better. Not, here's why this would be really nice to do. And it's just a tone and wording.
Thank you.
Okay, there are no more questions. Tobias,
Thank
thank
you.
you very much. Where is Gerhard? Come. Gerhard, we talk about, well, as usual, fiber optic stuff, right?
Do.
The stage is yours.
Thank you, Jan. Let's go. Right. It's great to be back. Thank you very much for this opportunity. Great pleasure. As introduced, I'm Gerhard Stein, lead research engineer at Flex Optics. And before I start with this presentation, a question to you. Who has the task to monitor temperatures continuously of transceivers? Please raise your hands. All right, we have a couple. Nice. Okay. Well, then, particular for you, it's interesting. Who of you have accessed the VDM or versatile diagnostic monitoring? All right. Okay. Yeah. I would say it's a bit of a hidden feature. There's an analysis of optics, obviously, but I also snuck in an analysis of network gears, particularly switches. But before I get to this, I want to answer a question. Transceivers, especially so 400G1, coherent, 800G, and so on, are consuming a lot of power. And in this presentation, I'm going to show you where this comes from. We want to have a closer look at this problem because it's easy to assume if you have the opportunity to keep your laser turned off, even though the transceiver is connected, you can put it into the state and you turn it on, all of a sudden it draws more power. So it's easy to think that it's to blame the laser, but let's look deeper into this. So I start with some basics, versatile diagnostic monitoring, then a bit of discussion about the laser, TEC, what the heck is that? Then a bit of power budget and planning, and then an own definition of efficiency. Actually, what I want to discuss in efficiency is how you transport heat, because it is not only power consumption. Power consumption is obviously converted almost 100% into heat, and how can you transport it out of your system efficiently? So let's start with this. These are the devices under tests we came up. So we have 100G, we have a 400G, 800G, and some switches, a newer Cisco one. We got lent by one of our customers and some legacy Cisco and Juniper ones. And before we look deeper into versatile diagnostic monitoring, first I want to explain the difference. So when you read the temperature, it's like the first value, if you look to the bottom, byte 22 and byte 23. You read out this temperature, and what usually the network gear does is takes these 2 bytes and convert them, and then that is what you get when you read out your temperature value. Now, versatile diagnostic monitoring is an extension to that and has one big advantage. And if you look closer, instead of having a byte, you have type ID. Why is that? Because it gives the vendor the opportunity to advertise what it supports, what it reports. While with DDM, you have a table where you read out all the possible values. Some of these values, there's a probability that they are not reported. And maybe you have some strange values and you don't know how to interpret them. And that is quite annoying, especially for developers who have to deal with that. So with versatile diagnostic monitoring, what you do is build your own for loop. You go through page 2021 hexadecimal, check which values exist, look in the table. If it's a theory, you just skip it. If it's a value, you translate it. And with that, you do not only get the value through the calculated samples, you also know what the transceiver advertises. And that is particularly important because for coherent transceivers, for example, you have different values than for gray ones. And all these VDM tables are across different CMIS agreements where you find this. Now we did some tests with different switches. As mentioned, these support only DDM. sometimes you find it in menu, sometimes you have to guess. I mean, if you have module temperature only or voltage, these are the basic values of DDM, it's most likely that it only supports that. Even though it could support more, but it really depends on what pages it is accessing. Same with the Cisco one. Here we have an example of the more modern Cisco one. And here's one value I want to discuss about it, a TC current at laser temperature. And we have an interesting fact. It feels a little bit like it's being hacked around, because usually laser temperature, when you read it from your agreement through VDM, so now we know it supports, but another fact, if you read it directly with your own code, you never get the absolute temperature. You always get a difference. Why a difference? Because you want to have this difference on 0, because the laser temperature is the critical value. Module temperature, I mean, you can be flexible, 30 degrees, 40 degrees, depending on your environment or how proper you're cooling down your racks. But the laser temperature is a point, it's a specification. If you cannot keep up this temperature, it's problematic. And fortunately, the transceiver has a control circuit and some apparatus that really provides you that stable temperature. And 50 degrees is the usual temperature. Here you see the variation of 0.2 centigrades. That's normal, sometimes 50.02. Some lasers operate on 55 degrees or 60, but that are the temperature you usually have. Now, 2 years ago, we talked about coherent transceivers, and these are quite interesting because they get very warm, and most of the power you invest, that is a ZR that consumes 70 watts. Most of it is translated into heat. Some of the photonic energy is translated into the value you really want to have, but we want to look into the 16.99 watts, and where does this power consumption come? Where does it go? Where's the most current consumed through all these chips? And I mean, the formula is basic electrical engineering. You have voltage, you have current, and for the power of the laser, you can, with the help of DDM, read it out. But for the power of the TEC, which is the thermoelectric cooler, I get to this device, the cooling device, you need VDM. So if you have these values, some other values are read from specifications like laser voltage. It's not a report, you have to look into data sheets, but you can assume these values are important because it's a voltage, it has to be. So with that, you can calculate your power consumption of different devices inside your transceiver. Let's talk about the thermoelectric cooler. I find it a fascinating device because it's a Peltier element, and you can see to the top right a typical Peltier element which you might find in chemistry laboratories, but in reality in the transceiver, if you look inside, it's hidden and it's next to the laser. How does it work? Well, actually, you have two ceramic plates. You have a metal bridge inside with some semiconductor blocks, and if you let current flowing through, putting a voltage on the metal bridge, what you're inducing is a heat flow. And if you inverse this polarity, that is the more interesting part, you're also inversing the heat flow. So with that and the control circuit together, you can ensure that your laser at all times will have a stable temperature. Does it warm up? It's too hot. It can cool down with the proper current. You just invert it and you heat it up. And for that, it is quite efficient and fast. On the other side, it is not so efficient because depending on the temperature, which is stable, yes, but Peltier elements have a degree of efficiency of 10%, unfortunately. And that's the reason why that makes sense to have it in a transceiver. An air conditioner is out of question, but on the other side, a Peltier element for your room, for cooling down your room, is also not a good idea. For that, air conditioner is better because 30, 40 degrees is what they can achieve with compression and decompression of the gas you have inside. So yeah, that's the idea. Now, power budget, there have been some agreements. On the left side, you see the ones for 100G transceivers. To the right side, you see the one for some 100, but also 400 and 800 ones, which is the same misagreement, and they have been simplifying the power class. You might have seen it in some manuals or documentation where you use a power class to really see what is the worst case scenario, how much power you're going to consume. That is not as important anymore because it's also a bit difficult with the different variants and tastes of transceivers you can buy nowadays to have power classes where you can trust the value that are given. So power class 1.5, and if you have 8, you have to look at byte 107. So the same misagreement said, screw that. Let's just give a byte with maximum power, and you can still report a power class. It can change, but other than that, it's not as relevant anymore. What you want to know is the worst case scenario, how much at maximum will your transceiver consume. And at Flex Optics, in our shop, we simplified this a bit by just if you're looking for a transceiver, you're planning, I mean, you do it before you buy it, obviously. You just look at power consumption, and that is the value, the maximum value you can expect that will be drawn when you're planning. Usually when they are running like 2, 3, 4% below this value is what you usually can expect. But, you know, worst case scenario for planning, so you have enough power. Now, you have seen the Flexbox, some of you are using it. There exist some research tools I wrote myself with a combination of Python, PyQt. That is for what I understand the most. I'm not sure if you can do this better on Rust, but I like Qt as a framework a lot. And I also dissected the Flexbox 5. It has a battery where you can monitor everything. And as soon as I plug in the transceiver, you can see what's happening inside the transceiver and also the different temperatures which are of interest. Now the laser is still turned off. As I said previously, this was the laser is not yet running, but you can access the transceiver. You can read out the registers. You can measure the temperature already. And as you can see, I just plugged it in. The temperature is going up. Now if I give it power, that is what happens. And it's running in low power mode. You can see it with a green curve to the bottom that between 1.2, 1.8, some transceivers, some Korean consume around 2 watts when they are in this low power mode, but it's really the maximum. So you don't have to worry about heat and dissipation. You can access a transceiver, still operate with some functions on it, but it's not running a link yet. What you can do, for example, is firmware upgrade, but you can also measure other values, what is this currently doing and how accessible it is. So now let's turn on the laser, and as you can see here, now the whole thing is operating. You can see the thermoelectric cooler that is heating up the laser because the temperature that is in this case specified to 55 degrees, it is heating up. So the derivation is very low, as I said before, because lasers have to be at a constant temperature. If the temperature is way too different to what it is specified, it not only becomes less efficient, it might change frequency, it might change wavelength, and that is also bad for other links. So there's a filter, but still, that is something you don't want. So this control circuit is quite strict on it. And now as you can see, connect to the jumper cable, you have some signal to dB. If you check the blue curve, it jumped up from the 90-40 dB where there was nothing of power, and the temperature obviously goes up. And as I promised you before, we are looking into this rise of temperature and why is it happening? Is it really to blame the laser? But before I get to that, I want to also talk about generations of transceivers, because this also exists. We have the 400G FR4, for example, that was released in 2018, and for 2025 there was a revision. It looks the same. You still have the same connector, obviously, connectors, media side and host side, but what is inside changes from time to time, and it really comes down to nanometers. From 12 to 9, it's a good gain. So if you can get later generations of transceivers, that is also worth an investment, because with manufacturing technology and nanometers that are going down, you're also saving energy and power consumption. So that is kind of a solution you can apply already, because you're not only saving power, obviously you don't have to transport as much heat. But yeah, it's something to look for. For example, the 1.6 T, there's a second generation already, forwards less, and it's the same. And sometimes they change components like ASICs through PAM4 DSP and different drivers, or silicon photonics like the 800G. So there's a lot going around with different generations, and yeah. Not a bad idea to look for it. Now talking about efficiency and heat transport, one of my favorite topics. Radiation is something we hopefully don't get to see in data centers, because campfire, that is what you feel when you put your hands close to it. We are talking here about combustion temperature of between 1,000, 2,000 degrees. That is something you don't want to have in your data center, obviously, and most likely will not get. But conduction, convection models we have to look at, mathematical models. Yeah, some equations, and it comes from differential equations. But the thing is, differential equations are uncoupled from geometry. So if you want to apply geometry, like this simple example, I did not put any special heat sinks because it gets more and more complex. There exist entire books talking about it, and a lot of scientists who wrote their papers, Nusselt number, Brandt number. The Reynolds number is the most famous one because it's used a lot in fluid mechanics. And if you combine all these formulas, that is what I did for this particular case. It turns out that if you double the speed of your fans, you're not doubling the watts. Why do I want to show you that? Because in the last years, I have observed that data centers are getting quite loud, quite noisy. And I have the impression that the solution is to just increase the fan speed, put more fans into it, increase the fan speeds, and so on. But I want to warn you about this, because it's not linearly escalating. You really have a problem here. If you double your airflow speed, you're not doubling the watts. You have to quadruple it every time. So doubling the fan speed is not a good idea. But as I mentioned, later generations, or if you have the opportunity, different heat sinks, more area to saturate your heat, could be a solution. But normally, I mean, we want to reduce speed. We want to reduce space. Like Meta already mentioned, they want to reduce the space. Space is here becoming a problem if you want to have better heat dissipation with that. So I think the best solution are later generations. Anyway, now getting the myth down to where does the power draw come from? This is a logarithmic description of this transceiver I was measuring here. It was a coherent ZR one. And as you can see, the TRC power, which is the blue curve, is the whole power. And if you compare to TC in laser power, surprisingly, it doesn't draw that much current. And that's interesting, because a laser at 50 degrees and maybe your ambient of 30 degrees, if you can cool down your device as efficient, you would think because it gets hot, that is where the wattage comes from, but it is not that. So if you subtract thermoelectric coolant laser, what is really there are DSP and MCU combination. And that's the thing, modulation is what takes most of the power. And it's like with the CPU, actually, these transceivers are becoming more like a CPU. The modulation is some sort of calculation, no? That from a coherent transceiver, like we saw in the morning, you have your bit stream and you're translating them. I mean, your QAM diagram is really a mathematical description of your phase shift and polarization, but in the end, all this needs to be calculated and then needs to be recovered on the other side, right? So that's the thing that draws a lot of power, actually, and also is converted to heat. And I was looking for the hotspot because I really thought that TC, because cooling requires energy, and laser, there would be a hotspot where you can find at 50 degrees. So I tried different cases here. You would find like a spot where it goes down, but it's almost constant. So it's really negligible what you have here. You really have to look more into MCUs and more efficient chips that do the kind of modulation we require. Now, some results of switches, because that was more interesting. I think in the software of switches, operating systems, maybe a sonic operating system. I want to look more into this. You can reduce the power, hopefully, because you have a feature, as I explained previously. You can decide to enable your transceiver, but also set it up the way that it does not turn on the laser. If you do a different kind of diagnostic, different kind of tests, you can even tell the transceiver to just do some bit error rate measurement only on the media side, so you can rule out where the problem comes from if you are not happy with your transmission quality for whatever reason, and you want to find out, is it a problem with your network gear or is it a problem with your media, with your optical fiber? So there are a couple of features you can test and also read out what is being advertised. But interestingly, if I subtract the base power consumption of the switch without any transceivers, I just subtracted it like 100 watts, 150 watts, depending on the model, and plug in a transceiver, you have different kind of overheads, especially with the Juniper one, with the jumper cable RX connected. You can see it goes up. It should draw 3.5 watts, but it's almost at 7. So there's some overhead, some management that happens. If I remove the RX, it goes down a bit, but it's still consuming. And that leaves me to the impression that not all the features that are on the transceiver are really used by these switches. And that's unfortunate. There's a pin called low power mode, which you can set. You can imagine it like with a television. You put it on standby, so with your remote control, you can turn it on whenever you use it. It consumes very little of power. That is something similar you can do with switches in low power mode. And the big advantage is you don't have to go to the data center and pull them out if you want to save energy. So there are ways where you can do everything with software. So anyway, and the right side was with the Cisco that performed a bit better, but you have licensing with fan types and so on. But in the end, the device we tested here did pretty well with the transceiver. We connected 2 different kinds. They consume the same power as a 2 kilometer one, 0.5 kilometer one. I really wanted to check how they behave, and it's almost the same. And yeah, why not? Now, one last experiment, which I promised, because last year we burnt down transceivers with 250 degrees. Now I'm going to freeze a transceiver this time. So this ice bucket with some ice cubes on top are just for decoration. Actually, what I did was using some tetrafluoro ethanol gas. And this gas is able to pull down the temperature down to minus 40 degrees. And now with a combination of heating up the whole time, you see some condensation effects. Not sure if you can see it. I think it's, watchable. You have some frozen drops there, which warm up when you remove the gas. So there is a thermodynamic exchange, which is quite interesting. But more interesting is how much power it draws if you cool it down, because it makes you believe that having a cool down system, because warm electronics consume even more wattage, how much it helps. And it ends in the end, it really is about 200 megawatts. So it's not that much, but it's interesting to see. You have to imagine we are at minus 10, minus 20 degrees, and inside the laser is still operating at 50 degrees. So you have a delta of 70 Kelvin here. That's a lot, and it's quite interesting how efficient these devices still can operate on such conditions. Anyway, getting to the conclusion, laser and TC are not the main energy draw, so we have to be more efficient at MCU and DSP and see if we can develop a firmware that is more efficient. You can run PRBS to find out how it would perform. If you don't have a switch, you have a coder box, you want to do it on that side. That is a good test where you can do it because it goes almost to the maximum power consumption. Laser temperatures are usually at 50 degrees. That's a different value. Don't get confused with the transceiver temperature, which you can read out of CDM. The laser temperature is harder to get, but here we have it. With VDM, you can do it. If you're able to shut your port to do it, especially with a coherent one, 7 up to 20-fold less energy is consumed. You saw the one with 17 watts. This one consumes around 1 watt if you shut the port. This really helps. It puts the transceiver into low power mode. You still can access it, but it's not really consuming that much power. So better have that if you have ports you're not using, right? Yeah. You can measure power at the switch, and yeah, that is something we also do with the Flexbox. And that's it from my side. Thank you very much. I have to take questions.
Thank you, Gerhard.
Hi.
Go ahead.
Thanks very much, Blake Willis, Optical Geek. I really appreciate the shout out to the new VDM standard. I was not aware of that. I would encourage everyone in this room that writes RFPs to ask your vendors about it and that you ask them to support it, because if you don't poke them, they won't do it. Thanks.
Yeah, let's poke them. Thank you very much for this comment.
Anyone else? Anything online, Jan?
Don't be shy.
No. Okay. Thank you, Gerhard. Okay, just a quick reminder, we have PC elections this week. If you want to nominate anybody or you want to nominate yourself, you have 30 minutes remaining. 3:30 is the deadline for nominations. And up next, we have James, and you're going to have to remind me, Eleanor, from Childlight. It's a Global Child Safety Institute from the University of Edinburgh.
Can we use this? Okay. Good afternoon, everyone. It's a slightly different topic from our previous speakers, where we really put at the center of our work children and young people. I'm Elena Martelozzo. I'm a professor of criminology at Childlight at the University of Edinburgh. And we work with Childlight, which is a global child safety institute, focusing on the online safety of children and young people. This is
data. So just if you want to go next one.
Yeah, sorry.
Oh, is it
green button?
There we go.
Here we are. So as I mentioned, we are based at the University of Edinburgh. We've been funded 4 years ago by the Human Dignity Foundation, and we work with a number of partners around the globe to really identify the risks that children and young people are exposed to online, and we're here to share some of the data that we have just launched today. So we started our global index 2 years ago, focusing on technology-facilitated CSEA, child sexual exploitation and abuse. But what we have done this year, we've added some further studies. In fact, we've had 19 additional studies that we've added to our index between 23 and 2024. And we've included some subtypes of technology, child sexual exploitation and abuse. And this data has been presented really for the first time globally. And as I mentioned, it's been launched today. And what we found largely is that 9.1% of male and females reported facing online exploitation and abuse online during childhood at least once in their lifetime. And I'm accompanied here with my colleague James, who's going to take you through our data.
Hi, everyone. So as Elena said, it's a little bit of a different type of presentation, but we take a public health approach towards tackling technology-facilitated child sexual exploitation and abuse. And as part of that, we think that a surveillance model, which looks at multiple sources of data, so some is based on survey data, which this meta-analysis is based on, and then we also conduct studies into child sexual abuse material that's available online and hosted by a number of different companies, as well as the distribution and sharing of child sexual abuse guidance documents. So first, I'm going to present a little bit on our technology-facilitated findings from the meta-analysis. And you'll see that 1 in 4 children is likely to face online sexual extortion during their childhood. So this is based on a number of studies that were conducted both with children as well as survivors. So those would be adults that dealt with or were perpetrated against. What we see that in Western Europe, this number increases to 37.4. So that's over 1/3 of people are experiencing some form of online solicitation. We also added a new subtype, as Elena referenced, which was exposure to unwanted sexual content, which will be of particular interest as recent legislation within the UK, but also pushed worldwide, is focusing on limiting exposure to children to sexual content. So making sure that there is age verification for entering adult pornography sites or spaces of the internet that should be only accessed by adult users. And as you can see, 7.3% of children have experienced this type of exposure. When we look at some of the regional findings, we see that online solicitation is especially high in Latin America and Caribbean region, Western Europe, and Eastern and Southern Africa. Western Europe also shows up as high in unwanted exposure, same with Eastern Europe and Central Asia. And we did see a sex difference between the reported types of child sexual abuse, with girls experiencing more commonly online solicitation, exploitation, and sextortion, also known as sexual extortion. Boys experience high rates of exposure to CSAM and that exposure to unwanted sexual content. So my question to everyone here is, can this be addressed through tailored safety interventions? How can we use this information about sex and gender breakdowns, as well as regional differences, to create a safer environment for children online? In terms of regional findings based on child sexual abuse material, we use data from 4 of the global actors in this space that measure whether it's reporting of CSAM or the hosting of that content. So we take data from the international hotline network called InHope, the IWF, which is based in the UK, the Internet Watch Foundation, as well as NECMEC in the United States, and Thorn, as well as Child Rescue Coalition. And we've broken this down into regional availability in terms of proportional measures, as well as the tagged content within those different regions. So what does the actual content look like of this illegal material? One thing we've seen within this content is that commercial tags, though limited in proportion, exist across the world. So this is the sale of child sexual abuse material and the marketing of the same. We also saw that a large portion of that commercial content is found on the Onion router. And this is especially important as we look at kind of how to disrupt the availability of this material, as the Onion router or Tor is often used as a facilitator to access on this type of content on the clear web. So one of the areas that I mentioned earlier is new to this data set is data on child sexual abuse guidance documents, or more commonly known as pedophile manuals. These documents are created by perpetrators and offenders and shared both on peer-to-peer network as well as ClearNet and Darknet. And they provide 3 different functions based on data from a roundtable that we hosted. So the first one is instructional intent. So they provide guidance on what to do in order to prepare a child or to harm a child. They also provide a justification for those actions. So they act as kind of like, this is the reason that this is okay, and their sharing in possession symbolizes that especially. And then finally, it creates a culture of normalization within this community that harming children online and in person is okay. And those are the 3 things that we would like to disrupt. So when we look at the distribution of these based on just one data source, we find that they're largely located in high-income countries. And this is especially important as we look for levers and advocacy and support in terms of disrupting the availability of these materials, is because high-income countries largely have the legislative levers as well as the resources to disrupt this type of content being made available. So the fact that 81% in 2023 and 75% in 2024 were located within these regions shows the responsibility of these governments and organizations to address their availability. So if there's one takeaway that you can kind of take from this, is that we are trying to promote 3 different types of responses to this. So the first one is to recognize it, which, as you can see from the data, it's a global phenomenon. It's something that needs to be recognized. The second is prevent it, And for this, we've talked about before, is taking a public health approach. And that's not saying that tech sector is solely responsible for this, but has a duty of care to children and especially child users to protect them online. And they are one of many actors that can help facilitate this. Others are through education sector, through health itself, through criminal justice and legislation. All of these need to work together in order to disrupt the availability of this type of material, as well as the availability of the instruments to groom, harm, and exploit children online. So I don't know if there are any questions. Elena and I will be in the hall after this presentation. Please come up to us. If you'd like to have a further discussion, we are happy to share. As Elena shared, this is available for the first time today, and it's building on the continued work that we do at Childlight around measuring the scale, prevalence, and nature of technology-facilitated child sexual exploitation and abuse. Thank you, everyone.
Thank you. Well, I see there is at least one question, please.
Lutz Donhage speaking for an NGO, not for an ISP now. First, thank you for the presentation. Over the decades, we have seen such reports, nothing has changed. It's always the same numbers, always the same sources. We had a discussion about 30 years ago. And this was the first time I'm involved in this discussion, and we had a problem that there was an understanding that there is something to protect. But the misunderstanding or the misconception here is internet is not a safe place. Internet is the mirror of the real world. You have to deal with this world. You can't make a safe space for the purpose, for a good purpose, by restricting everybody else. That's not possible. So the real problem is how to make an environment within the internet so it can be used safely. It's the same question we have, how to protect children in the real world. There are some areas, there are simply no-go areas for children. And the parents are responsible for this. You can't go out and say, politics has to say something that no area in the world might be a problem. That's not possible. We have the same discussion here in the internet. The internet is content neutral. That means I do not understand your presentation for this audience here, because it's technical people. We are responsible for keep it working, not for stop it. For some reason, the reason might be good, but to some productive on this. For 30 years, we started with an action delete instead of blocking. And it was huge success because the law enforcement agencies have no interest in going out and delete content, harmful content. There are some really bad content there and need to be taken by the law enforcement. The people have to be taken down, of course. But it has to be done by them, not by us. Because they can decide what is useful and what's not. The same is for Tor network. The Tor network is there in order to protect a lot of people. I'm coming from a region where we had, our first project was with new religious organizations, and we seek for how can somebody who want to get out of a sect or something, how to protect them. And we use these networks for this. And
sorry,
somebody
can you compress it a little bit? The comment is longer than the lightning talk. Sorry, please. No, it's you on your side.
Yeah, thank you. It's Lucas from Düsseldorf University. I think we are obviously on a very emotional topic here, and also very at tense between like child protection and also privacy and the internet. And I was just wanting to ask whether you had a look into like technical measures regarding making the compromise between protecting child's online, but also still retaining the ability to stay anonymous in the internet. I think there are some, and I think it's important to provide guidance to governments and also companies how to implement such measures. I was wondering if you had a look into that.
So I'd like to first answer to the first gentleman that spoke. I'm really sorry that you think that this topic is not relevant. I tend to disagree. I think everybody has the necessity, and I think to learn about what the data 20 years later is still saying, to show that, you know, the landscape is still quite fragile for children, young people, and I agree it's a very emotional topic. But as you say, it's important to share these findings, to share these data, which come from organizations that we respect, and they're working day in and day out to ensure that the internet is a safe space. In terms of, what do we do with governments? Absolutely, governments have a huge responsibility in shaping legislations and policies, and we inform governments with our data to show robustness about some of the recommendations that we always put forward to them in particular. And going back to the technical side, I think, we all know that the internet wasn't designed for children and young people. However, they are the largest consumers and users, as we know. So it's important to take them into account when we do design new products. So that safety by design, which you probably heard hundreds of times in your work, it's something that we put at the very core of our recommendations with tech companies and industry. And I'm not sure if James wants to add anything.
No, we are way out of time.
Yes.
I know.
Okay, thank you.
Last, but very quick comments. Okay. Hi, Andrew Campling. My affiliation is relevant for this talk. Amongst other things, I'm a trustee of the Internet Watch Foundation, which is a charity that locates and removes child sex abuse material. I think it's important to raise the topic because it is technology facilitated harm. So we can close our eyes to the problem, but it's a problem that the industry is enabling, whether we like it or not. And I guess thinking about that privacy comment, there's also the privacy of children, which is actively being harmed by these attacks. So do we protect the privacy of largely privileged adults at the expense of the privacy of children and arguably, there are other human rights as well, remembering that privacy is a qualified human right versus things like the right to life, which is an absolute right. So sometimes I think we get distracted by privacy and forget other human rights matter as well. So we need to take a much more balanced approach. Thank you.
Thank you, Andrew.
Thanks, Andrew. Thank you.
Peter Spacek. Brace for upgrades, plural. The stage is yours.
Yes. Thank you very much. This is going to be another little bit emotional topic, at least for me. I'm Petr Spacek. I work with ISC on all things DNS, but this time I'm talking on behalf of many open source projects. I couldn't fit all of them on slide. From the news, you already know that LLMs can find lots of bugs. Some of them actually exist. And subset of these is exploitable. The tool itself is just a tool, but the real problem is, again, in this case as well, of the people. Because there is many people who nowadays use the CVEs as a literally curriculum vitae enhancer, and they have their own key performance indicators based on the number of CVEs they get assigned. So when they submit reports to open source project, it's not to help the project, it is to help themselves to the next bonus. So, case in point, Bind DNS server received this year to date, well, to yesterday, it has changed overnight, over 200 reports. We've managed to triage 130 of them up until yesterday, 84 more to go yesterday again,
And roughly 8% were actually valid security issues of various severity levels. We have 500 more to go found internally using LLMs. Crazy days. Going to the routing length, FRR, similar story. 62 reports to date, only for this year, roughly 4% valid. Number of CVs is kind of messy for FRR because anyone can go and assign CV number for FRR, which is just insane, but that's what happens. Unbound, similar story. Lots of reports, some CVs, definitely more than previous year. BERT in the routing length, again, similar story. 70 reports only to this day for 2026, 7% valid. Power DNS, exactly same story. Lots of reports, 5% valid. DNS mask, I didn't have a chance to meet Simon Kelly in person, the maintainer of DNS mask, so I've just quoted out of his email on the public list. You can see lots of issues, time spent on charging it, finding duplicates, insane. Why is it a problem? Well, we like to receive bug reports, that's all right, send it our way. But this is an example, of course you cannot read it, but that's just to give you a sense how it looks like. This is one report for bind. It goes for pages and pages and pages. It has subtitles like step-by-step proof of concept. Well, the catch is that it goes on for a couple more pages, and then you find out that you cannot reproduce it, and the LLM just wrote something, but there is no way to trigger that. And the motivation for the submitter was to get a CV number and to get a little money for the bug bounty. So if the reports were a drink, it would be about this quality. And the OSS maintainers get that drink every day, at least 2. So yeah, not good for your health. In essence, what is happening is a denial of service attack on the development team. It's a handful of people. They are here in this room. They've spent some time together. You can shake their hands and see that it's real people, not machines. And it's really taxing. For you as the users of the open source projects, that in effect means that the features are not being developed really, or perhaps at very slow pace, because well, all the time is spent on triage, basically. Perhaps you have all your features, you don't care about the features, that would be good. I would like to stop doing new features for a while. But perhaps your deployment is growing and you would like some performance optimizations. These are not happening either. To cut out the, try to optimize the process, at least in the bind DNS, we've decided to stop providing workarounds along with the bug description because it takes even more time for every single bug to find out, how exactly you can configure it so it doesn't trigger, and we have 300 knobs. The same goes for versions affected. Historically, we've provided, okay, the first version affected was this number and the last was this number. We are just not going to do that anymore. With 25 years of history, it really takes time to find out the exact version number, and we don't have the time. So the bottom line is, it's going to be very interesting going forward. I can see some things in the pipeline, and other projects shared their view that this is going to happen. So can you upgrade? How long does it take? Please think about it. Because, if we have a CVE fix release like every short period of time, it will be interesting. I spoke in hallways to root server operators, so one of the most critical parts of the infrastructure. Of course, I'm DNS guy, so I know nothing about BGP. That's also critical, obviously. But in DNS land, root servers are critical, and some root server operators told me, well, okay, so you ship new code, we release it, we have automation, we can deploy it anytime. That's how I like it, because it will get used very often. Perhaps you can say, okay, these small projects, they suck. They cannot keep up. Well, I don't consider a Linux kernel to be a small project. And judging by the last week and a security release like every week, it's not limited to small projects. You can read more on the link. Perhaps, these open source snowflakes, they cannot take it. Well, here's, a statement from Microsoft. Of course, it's a huge corporation, so 5 lawyers was working on that statement, so it's like huge and you have to parse it. But the bottom line is basically, well, be ready to act quickly, and if you can act quickly, you will be better off. That's like the long story short. Going forward, it is entirely possible that the usual luxury of having the embargo when you have 1 week advance notice that there will be something and then you upgrade might not actually hold. Because if someone used the LLM to find exploitable bug, there is no reason why someone else cannot do that. And that is actually happening in practice because we are getting duplicate reports at the same time or in a span of a week. So apparently multiple people are finding the same things at the same time. And while the reports we see are from the good guys, sort of, at least half good, but I don't see any reason why the bad guys who actually want to exploit that instead of getting the number for their CV wouldn't do that. So, well, be ready. If you're a researcher or new researcher, please send a message that unverified reports are actively harmful to the projects. If you find something verified before you send it over, we have enough unverified stuff. Here, there's a link in the slides for a template which is useful definitely for DNS, perhaps for other projects as well. It basically cuts it to, we don't need code flow explanation because we know how our code works. We need actual reproducer and the assumptions you have about the test. So if you are reporting back in DNS, let's say, and your assumption or the assumption your LLM used is that the parent zone is malicious, then well, go home. This is not a security issue because the parent in DNS can do anything. That's how the protocol is designed. Maybe it's a bug, but definitely not a security one. If your LLM can generate pages of text, perhaps it can generate something more useful. If it can generate a test, executable code, which demonstrates the issue instead of vague description, do this and do that, that would be excellent. Send it over, generate the test, not 5 megs of code, but 10 lines or 100 lines if 10 doesn't do it. Please send it over. That will actually help. And with that, I'm at the end of the talk. There is not really much we can do alone, but you can help us. Different projects are in different situations. Some projects would like, having a money so they can hire more people to work on it. That means support contracts. Other projects perhaps have enough money, but they would like to, for people, but perhaps they would like to play with LLMs. Give them access to hardware, give them access to the LLMs, or generally ask them what they need because they need better than I do. And no matter what you do, brace for frequent upgrades. Thank you for your attention. And we have 45 seconds. I apologize. So I'm not sure how we do our handle this.
So we're going to cut the queue immediately. If you could all be as brief as possible, please. Just cut it, Tyler.
Well, my statement was generated by LLM, so 0.1 out of 5 is. I liked your observation that the social contract apparently needs a little bit of restructuring in that, for instance, you no longer do all the legwork to figure out what's affected, what's not affected. It's just like, okay, bug was identified, latest release has the fix, enjoy your life. And I think cutting in old features or removing legacy, headache parts of code bases, a lot of projects benefit from a spring cleaning because it reduces your surface.
Yes,
and there is no negotiation with the machine. You have recommendations include this, include that, but in OpenBSD we now see that the LLMs just fully automated dump reports on GitHub. There is no human on the other side at all. So there's nobody to even negotiate with.
Yeah, that's even worse, yes.
It is what it is. But thank you for your presentation. I found it very insightful and I can corroborate all your observations and I agree with your analysis of the current situation.
Thank you. I can see that we have a bunch of open source maintainers in the room. Perhaps if you stand up and wave, people will know who to ask for, what they need. Yeah.
Daniel? I'm Daniel. I'm an internet citizen
First of all, thank you for the presentation. I think it's eye-opening. I also agree with your conclusion. Be ready for quick updates. Everybody in the room should take note. This just strikes me as a repeat of the whole story of spam. It basically is. It's a DDoS.
Yeah.
And the way to deal with this is probably to, as in the open source community, to make some tools to deal with the avalanche. So open source maintainers should probably get together and make a, rather than paying for having maintenance fees and paying for dozens of people doing stuff, creating some software that helps dealing with the deluge. Maybe that's an idea. Think about it. Thank you.
Okay. Like I say, we are very short of time. We have one more presentation left, so please, even quicker.
Hi, Andrew Campling, 419 Consulting, relevant affiliation this time. I was at the RSA conference, the annual cybersecurity conference a few weeks back. The sort of headline from that is it's going to get far worse than LLMs because agentic AI is currently red teaming your software, your infrastructure, and even very underfunded new agentic AI is placing in the top 1% of hacking capability in capture the flag competitions at the moment. State actor-backed agentic AI hacking will be far better than that. So this is going to be a problem. It will find actually viable issues, not just sort of superficial ones. And probably the whole issue is going to have its technical debt.
Okay.
Yeah, thanks, Lucas from Düsseldorf. I was just thinking about the social side of this issue, because like there maybe someone is spending time with your project, finding bugs. Maybe if it's AI assisted, maybe they didn't put so much work into it, but maybe they did, and maybe they do want to talk about it. So maybe I was wondering if it's a good idea to encourage like communication with open source maintainers beyond publishing a CVE, right? Maybe you don't need to like directly put up a CVE. Maybe it might be better to like have a chat in the first place and maybe see if you can even confirm the issue and only then put up a CVE with like lots of documentation. That was just an idea that came to my head. But thanks for raising the discussion. It's an important topic.
Okay.
I try to be quick during this time of OpenVPN. So yeah, thanks for bringing this up. We have the same issue, like 7 reports in the last 2 weeks, and we haven't yet been able to triage them even.
Yeah.
But they don't look critical. But we have had to do many more updates than in the previous years. On the subject of CVEs, this is actually an interesting point. When do you assign a CVE? Because the rules are somewhat fuzzy. Doing a CVE is more work than not doing a CVE. Do you do a CVE and then an embargo release? Because, oh, it's just a minor bug, but still worth a CVE.
Yeah, let's talk.
It's a nightmare.
Yeah, let's talk. We have the same questions. So let's talk in the hallway, perhaps.
One of the things we need to address is actual distributions. Because like OpenWRT, Debian, whatever, they ship stable versions of the software, which means I have to go back to like 2 releases prior and figure out is the bug still there. And we don't do releases for OpenVPN 2.5 anymore because we are 2.7. So if somebody ships 2.5, the patch might not apply. And then all this update stuff falls apart, which is a problem we need to fix.
Yeah, let's talk.
Dave Knight, Nominet. Thanks, Peter. That's really great. I hate to see you struggle, but I see this as a wake-up call for operators. You know, you mentioned that some of us are sitting with our deployments at the end of a CI/CD pipeline. We've got the test built in. We can rapidly do things. That's not everyone. And I think, you know, operations teams will have to be having conversations with themselves right now because our model for how we do this kind of stuff has to change to adapt to this. You know, previously where we could look at a CVE and think about it in terms of attack surface. Do we need to patch now, or is this a firewall thing? You know, the workarounds you spoke of. We're not going to be able to have those thoughts and keep up with that. We are just going to have to keep rolling out patches. And so now we're in that danger of now we're doing things we understand less. And so it's going to bring operational instability as well as, you know, nightmares to your lives. Sorry.
Yeah, all right. Thank you very much.
Thanks again, Peter. Okay, so our final lightning talk for this session is Stephen Farrell, and he's going to talk about ECH in OpenSSL.
So I guess I have like -1 minute or something. See if it works. So yeah, this is kind of a little bit lighter, I guess. Encrypt Client Hello is an extension to TLS that has been worked on for crap loads of years, and finally it's kind of done. It's an RFC since March. We got code into OpenSSL in April, even though that code had been more or less stable for a couple of years. There's some details there. The work we did on this was kind of funded by a crowd called the Open Tech Fund, who are a really good funder, and kind of gave us money to try and contribute code upstream for OpenSSL and for a bunch of web servers and curl to enable ECH. Why do you want ECH? Because without this, the server name indication, the SNI, in the first TLS exchange exposes the domain that you're talking to, and that can be used for monitoring or has been used for censorship and other things as well. And so we'd like to encrypt some things in the client hello message, including SNI, maybe LPN, maybe other future parameters. And that mostly makes sense when you're not exposing the DNS name through DNS over port 53. This is how it works. I'm not going to explain it. How many people have a rough idea how this thing works? A scattering. If you're interested in how it works, then ask me. The interesting part here is that the client is now looking up A and Quad A and HTTPS resource records in the DNS. The HTTPS OR has the ECH public key that we use to do the encryption, and also has other things like it can have ALPNs, and it can kind of speed up browsers as well by putting out an exchange. There's a bit of key management required because you need a private key to go to the public key. You've got to update the DNS and so on. So that's probably the trickiest part, and updating clients that previously had a very simple model of how they looked at mapping names to DNS content. This HTTPS resource record makes it a bit more complicated. So there we go. That explains the same thing in text. There's a bunch of corner cases that I'll skip over because I've got -1 minute. Code changes. If you're going to deploy this, you need some kind of key management. Typically, it's like a cron-like service where you refresh these keys periodically. Cloudflare in their test sites, for example, do it every hour. We do that in the same in our test sites because it's in the nature of the protocol that it doesn't give you forward secrecy. It's an ephemeral static if you have an exchange. And so you want to replace those keys at some frequency. On the client side, it's relatively straightforward. The mechanics is all inside the TLS library. The hard part for clients, if you wanted to enable some client, is doing the fancy new DNS stuff, which relates to kind of happy eyeballs and all sorts of things. And doing that simply just to get it working is relatively straightforward. Doing it more in a fully featured way is a little bit more complicated. On the server, it's actually much easier. Essentially, patches for things like Apache and Nginx are a couple hundred lines of code only, once the TLS library supports the feature. This is what's supported, so OpenSSL has it, Boring has it, NSS, WolfSSL, RustTLS, Golang. So there's the client libraries support is pretty good. There are, of course, API differences between OpenSSL and Boring SSL. In terms of clients, Firefox, Chrome, and derivatives support ECH. We contributed code to curl, which is there now. On the server side, all those web servers have it in their main branches. And now that OpenSSL has kind of released this, hopefully it'll, in future releases of those web server products, it'll be a feature you can just turn on and configure and relatively straightforwardly have it work. So that's basically it. It's kind of more ready to be widely deployed. If you're deploying web servers in particular, or if you're poking at TLS exchanges to look at the SNI messages, things might, or the SNI in the client hello, things might change. If you're interested in deploying it, we're happy to kind of help you. We still have some funds from our funded project, so we can help people get it deployed if they wanted to play with it. And there's on the project site, there's some various reports, including one of a little trial we did with the Wikimedia Foundation, where they enabled this on a small web property they have last year. And the headline is "Nothing broke," so it kind of works and it doesn't really break things. And with that, I'm done. I expect fewer questions than for the last presentation.
Thank you, Stephen. Brilliant stuff. And I see it's very clear to
Coffee.
everybody.
If you go on coffee, I guess.
Well, yeah, we're standing in between them and coffee.
That's fine. If you're interested, just grab me or Neil O'Reilly, and we can talk to you about it.
All right.
Thanks.
Thank you very much.
Okay, just one announcement. There are no buses to the social tonight. Just be aware, you'll need to make your own way there. You can walk, you can take public transport, you can take a taxi, but there are no buses. There's one exception. If you have mobility issues, there will be a bus outside the Moxie at 8:45, but that's only for people with mobility issues. Thank you very much.
All right, good afternoon. I'm going to give folks a second to grab a seat before we get started. All right, welcome. First of all, welcome to Edinburgh. It's a slight novelty to be able to welcome you to, in a way, my home. I want to start you off with a local anecdote before we get into the session proper. There is a map of Edinburgh from 1862 which solves two problems that we have in networking. One of those is difficult, which is measuring one-way latency. The other of those is how do you beat the speed of light? In 1862, they solved this problem. There's a map which you can go and access. There's a link at the bottom there. Hislop's time gun map of Edinburgh and Leith. Now, a time gun sounds much more sci-fi than it actually is, but at 1 p.m. every day, the time gun is fired. So this map has a series of concentric rings that are centered around Edinburgh Castle. And the map describes to us what the rings mean. Now, you can't read that, and I definitely can't read that, so allow me to expand. So the two lines here solve the two problems that I delineated a second ago. The first one is, for every additional circle of distance at which the observer may be from the castle, he should subtract due to the measured rate at which sound travels from the instant he hears the report, i.e. the firing of the time gun, in order to obtain the exact moment of fire, or 1 o'clock p.m. Greenwich Mean Time. This is, every concentric ring is 2 seconds from the firing of the gun, based on the speed of sound. So we know where we are on the map, although the map doesn't quite include the EICC. So we are here. So if you hear a bang, it's probably 2 seconds past 1, approximately, because no map can take into account wind conditions or any other scenarios. So that's condition one. This map from 1862 satisfies a constraint for measuring one-way latency. The second part, which I particularly like, is we solve the speed of light. In Edinburgh, the internet operates at infinite speed. The flash of the time gun's fire requires, owing to the immense velocity of light, no correction for any distance. It doesn't matter how far away you are from the gun, no time has passed. Faster than light. 1862, they had all of this together. But that's enough for me. On with the session. Who are we? We are your friendly MAT working group co-chairs. My name is Stephen. I am joined today by my co-chairs Massimo and Nina, who can wave from the front. If you would like to contact us, you can do so directly at matworkinggroupchairs@ribe.net for friendly comments or whatever you want to rage at us about. We're happy to take any and all criticisms. A little bit of session admin, queue discipline. There is some. We aren't super religious about using the Meet Echo queue, although some people are. But please do state your name and affiliation when you're at the microphone. We will try and do our best to capture everybody, but we will cut the mic lines if we're running low on time. During the session, please rate the presentations. It's usually best to rate during the session because otherwise you will forget, and I always do. And if there's something interesting that comes up, please discuss the presentations on the working group list if you think that there are shared topics to discuss. Before I continue even further, I have a little bit of paper from the NCC with a bunch of reminders. One is, right, PC election voting is opened as of 4 p.m. and will close on Thursday at 5 p.m. The second reminder is there will be a session on diversity, equity and inclusion in tech today at 6 p.m. here in the main room. And the final reminder is that for tonight's social, there are no buses to the social tonight, so you can walk, use public transport or take a taxi. The directions are on the meeting website. There will be one bus exclusively for guests with mobility issues, which will depart from the entrance of the Moxie Fountain Bridge, Edinburgh at 8:45. Remember to bring your badge to the social. I can say that the social venue is only about a 20 to 25 minute walk from here, so it's not super far if you're concerned about the distance. our agenda today, we have 5 talks on the agenda. We've kind of clustered them into a couple of IPv6 related talks. We've got a couple of BGP adjacent talks, and we're closing out with this talk on the Iranian internet shutdowns in the last few months. So that's all I have. Our first presenter today is Jeff Houston. For many of you, Jeff requires no introduction, but he's going to get one anyway for those of you that it's valuable for. Jeff orchestrated the construction of the first internet network between Australian universities. He is APNIC's chief scientist and an Internet Hall of Fame inductee at APNIC. He undertakes research on internet infrastructure, IP technologies, and address distribution policies. Jeff.
Thanks, Stephen. Good afternoon all. My name is Jeff Houston. You don't need to clap that, or you're clapping Stephen. Well done. I love this story about the speed of sound. In the 18th century, the speed of propagation of electricity through conductors was an equally timely topic. And they were fascinated to figure out how fast electricity moved through a wire. And so a French, whatever, Jean-Antoine Nollet, got 160 monks, 1.6 miles of iron cable, a Leyden jar, got all the monks to hold and keep their feet on the ground, and applied a massive electric shock. By the simultaneous screams and jumps of all the monks at the same time, he concluded that the propagation of electricity through wires was instantaneous. Why don't we do that today? It just sounds like such a great way of measuring stuff. Here's a V6 packet, everyone jump. So this is actually not a talk about V6, and it is not even a talk about DNS, not really. It's actually a talk about measurement, which is why I sort of put it into Matt and nowhere else. It does flow on a little bit from the Tobias's talk earlier this afternoon in the plenary, but it kind of leads in a different place and a different way to try and understand, if you will, the problems and intricacies of measurement. So we start from the same point. There is quite a venerable RFC 22 years ago that, oddly enough, in a document that says IPv6 transport operational guidelines, says you better keep v4 going. It's just an odd title for a conclusion. But, you know, the shoulds in there are kind of, don't forget v4, this is not the time to sort of ditch the lot and move to v6, which at the time was quite timely. Now, there is a change to that. Yeah, there it is. There's this proposed change that recommends at least 2 NSs for a zone and dual stack name servers, right? And every authoritative DNS zone should, not quite must, but should, serve by at least 1 v6 reachable. And it's kind of a different hint now, isn't it? Because the earlier one said, Christ's sake, if you want it to work, keep v4 running. This one says, well, maybe you should keep v4 running, that's up to you, but you know, you really should have at least something in v6. It's not saying you must, but it's kind of going, you really should. And the assumption behind this new BIS, that's a BCP for some reason, is that v6 is now mature, well understood, and using v6 as transport for the DNS is as good as v4. That's what it's really saying. Now, if I actually go and look at the world as a whole and look at the, 5 billion odd users out there who use the internet every day, only half can get anywhere in v6. So for general use out there on the internet, that degree of deployment maturity isn't really there. It's a 50% problem. It'll get better, but today it's not there. But the DNS is special, as everyone who works in the DNS keeps on saying they're special. Yes, they are special, and it's very sad, but you know, you have to tolerate them. But this assumption that v6 is now mature, well understood, and as efficient, is it true? And more to the point, can we measure it? And so let's actually look at what the measurement question is. If I put something up on the DNS in v6, how many users can reach it? I don't care about what resolvers or what resolvers you use. That's kind of irrelevant, because the people who pay for all this show are you and I paying our ISPs or whatever for this. So if I phrase this not in an infrastructure mode, but phrase it as a user problem, people using the internet. If I switch parts of the infrastructure into using V6 in the DNS, do I piss people off or will it just work? That's the question. And that leads you into a measurement question, which is kind of hell on earth, because measuring the DNS is always difficult. It's not straightforward. Why not? Because the DNS is anything but simple. What's a resolver? Something that gets queries and gives you answers, yeah? Is it a single program on a single machine? Is Google's 8.8.8.8 some massive thing somewhere? Of course not. It's a state of mind as far as I can tell. So is Cloudflare's Open Resolver. And what about the resolver running in my ISP? Well, I don't pay for it. My ISP pays for it, and I don't pay any extra for it. So it's some IBM PC that someone last looked at 3 decades ago that they assume is still running badly, and no one looks at. What is a resolver? You know, and there are so many different ways of building it. There's no simple answer. It's not a thing, it's a function. And when you're starting to try and measure the DNS, the things get in the way of the function. So a resolver also might be the one that operates on my Mac. It's a wonderful resolver. I'm its only client. It loves me. On the other hand, Google's resolver has approximately, thinking here, about 1 billion clients. And I might be one of them, but they don't care about me. I'm 1 in a billion. So millions of clients. But when I want to talk about the DNS, what my resolver does is supremely irrelevant. Google's behavior is extremely relevant because it affects so many users. So understanding resolvers is actually really quite a challenging issue. We don't know. But okay, well, at least we understand DNS queries, don't we? No, we don't. Queries are not end-to-end. Queries are kind of these ephemeral things that move from one DNS, intelligence point, if I use that word loosely, to another, and then it goes and solves the problem. So it's a relayed problem. There's no continuity. I ask my recursive, and the recursive says, well, that's a great problem, Jeff. Let me go and ask a few of my mates independently to give you back an answer. So this distributed process of query resolution causes fan-outs. It causes a single query being amplified in their own special way. There's no hop count. There's no path. For all we know, there are queries that were made 10 years ago that are still looping in the DNS. There's no reason to stop them. They just loop around quietly going, hey, and they might be there. We have no idea. There's no snail trail. There's no trace route. There's nothing. Queries really have a life of their own. Now, when you couple that with the next observation, that the DNS is free, there are very few of you in this room, there are a few, and I sympathize with you, that have to pay for a query. But the rest of you don't. No one pays for queries. I could ask Cloudflare, I could ask Google. Oh, let's ask both. Why? It's free. Costs nothing. I'll just take the first answer. And all the way along the line, what you actually find is that the DNS adopts, if you will, the lazy approach and just simply duplicates queries all the time. So here's a little graph. The red is A queries. God, I need glasses even at this distance. The green is V6, quad A's. The blue is the oh-so-fashionable HTTPS query. That's actually all the Apple ecosystems machines out there that are really hip and with it, and HTTPS is the new hip with it kind of query. And you notice almost everyone queries once. Well, that's really good. Not as many V6 as V4, but what's 2, 3, 4, 5, 6? And I went up to 15, but that's because, after that it goes up to a few hundred, but the numbers are really quite small. Query duplication is a thing. Queries just get amplified again and again and again. To be perfectly frank, round about 1/3 of the queries that circulate in the DNS are replicants of a previous query, a precise replicant. Same query name, same everything. They just get repeated. And that's sort of a cumulative histogram of what's going on there. UDP is a brilliant protocol. You don't need to wait for an answer. You just ask some more and some more and some more. You can be as impatient as you want. Just keep on asking because queries are free and no one cares. So when you're kind of looking at the DNS, how do you get rid of the duplicates to the information? What's real? What's just the DNS chattering to itself? That's a really hard question to answer because the DNS loves chattering to itself. So the next thing, how to measure. Tobias worked up a different kind of measurement. I'm Tobias, and there's a bunch of servers out there. I will ask each of them and collect some data. One, too many, and back again. And it kind of summarizes the problem. But to be perfectly frank, the server for jeffsfavouritedomain.com is supremely irrelevant. And asking them about, my V6 properties makes no difference. A lot of people ask google.com, and the properties of that server are actually supremely relevant to each and every one of you. There are names that are incredibly important and servers that are incredibly important. So what I really want to know is not the characteristics of individual servers. I want to know the characteristics of the resolvers that you and I use. How to do that? Make you ask the question for me, all of you. Who hasn't received an ad in the last 24 hours? Nobody. Who hasn't received an ad in the last 2 hours? Well, a couple. Ads are everywhere. And oddly enough, ads are a way of doing measurement. Because in an ad, you can load a script. That script executes as soon as the ad is loaded. No clicks required. Clicks are expensive. So if you see AP Nick, don't click it, I'm paying. But you can get an extraordinary amount of folk enlisted in performing your measurement for you. And that's what we do. We use the ad system to distribute queries into the DNS at the stub resolver level. But we take a lot of attention in making sure the query name is unique. It all comes back to servers we operate. So we sit there on these servers and infer what's going on in the DNS from what we see at the server level. So it's many users and a very small number of servers. So the measurement question, V6 DNS, yep. So here's what we find early in February. The amount of V6 out there in the world from a user perspective, about 50%. But if I put an authoritative name server on V6 only, it's more encouraging. It's around 60% of users can actually get that name resolved. Dancing in the streets, that's wonderful. Let's all go home. This is brilliant. But how good is that measurement? And how did I figure out that the user had got the answer? Because I can't change your browser. I can't. I've got the ad to say, try and resolve this name, and I see the query. I answer the query. I know I did. But how do I know you received the answer? How do I know that you actually successfully received V6? Years ago, when you looked at V6 blockage, it wasn't the outgoing packet filters that got in the way, it was the incoming filters. So even if I deliver a V6 answer, it was highly likely years ago that you would block it because the incoming filters said, nah, no V6 here. So how do I do that? Well, the way I actually do it is that DNS query is associated with a web fetch. And guess who the only web server is? Well, same old server. So this only works if they actually do the web fetch. Sounds reasonable? Well, yes, but the problem is that browsers are incredibly, incredibly loose and noisy. They just get amnesiac, they forget things, they don't even attempt. You go away from the web page. It's not. It's not a very good measurement at all. So the real question is, I'm actually trying to measure the absence of data, and I don't want to do that. Is there a way of doing it inside the DNS, that the DNS can actually tell me if it got the answer? Well, yes, by doing stupid DNS tricks. And one of the stupid DNS tricks is to say, here's the name of the name server, but I'm not going to tell you its IP address. You're going to have to work that out. And the only way you can work that out is if you have V6. So I send you an answer, no glue. You have to work it out. You need to do V6 to work it out. Only if you work it out do you do the next query. So now everyone who does that new query has been able to receive an answer on V6. Brilliant, right? This is a much, much, much better answer. This is fantastic. And when I put the two beside themselves, the red line is the web, 60%. The blue line is the DNS, 70%. Fantastic. I found 10% more users by using a better measurement system. Is the web that crappy? Well, some would say, yes, the web is crappy, live with it. But averages hide anomalies. And some of these anomalies are amazing. North Africa has a particular form of DNS resolution in Algeria, in Libya, and in Egypt, where glueless delegations are evil. Evil. They don't do them. So the web is up around 60%. The DNS measurement is at 0%. In all three countries. Well, not quite zero in Libya and Egypt. They haven't quite got the MIMO. But you get this kind of strange difference at a national level, not per ISP, but for every ISP operating in that country. Riddle me that. Whoever was selling this shit was doing a really, really good job. If you need some crap sold, go and talk to these people. That salesperson is fantastic. But it kind of goes, the DNS is not the same everywhere for reasons that aren't the same everywhere. There are very few resolver implementations, but an awful lot of people who play very silly buggers with the DNS. Bolivia, Ethiopia, and Myanmar do it the other way. The DNS gives you a really good answer, the web gives you crap. It's way lower. And if you look at this distribution, you find that even though it kind of is two things talking about the same behavior, when I try and pin it down, I find these anomalies that swing either way fantastically, where the web signal gives a higher result, the DNS signal gives a higher result, and there's almost no rhyme or reason to this. So I can take the maximum of the two and actually get an even better answer. Oddly enough, if I take the maximum of the two and go, look, I'll take either, I'm desperate, 80% of users sit behind something that, some way or other, it looks like they're able to do V6 resolution over DNS, but either individual technique gives you a lower answer. So what's this telling me? Adding this up, what this is actually telling me? The DNS is shit. The DNS behaves in ways that are entirely non-deterministic and that answers are random, not systematic. Trying to measure it is an exercise in beating your head against the wall and reshaping your forehead. Large-scale monitoring, filtering, you name it, simply add layers and layers and layers of obscure complexity that defeat any mechanism to look from the outside in. And you can't follow DNS packets because, as we said, no trace route, no nothing. So quite frankly, this exercise in trying to measure the DNS is one of those kind of endless employment opportunities. There is so much to try and measure and so many different and wonderful ways that the DNS is going to frustrate the hell out of you. Thank you. The guilty are lining up. Oh, DNS vendors.
I'm gone. In that case, I'm gone. Hi, Benno Overeiner and Nelnet Labs. So I don't think it changes the results. What we found out is that NS queries are not always answered. So in following delegations, most resolvers just used a quad A to the root, a quad A to the TLD, a quad A to the SLD, and a quad A to get the results. With QNAME minimization, our first implementation, NS query to the root, NS query, etc. And at some instance, we don't get an answer because it was an NS. If we ask the same thing with an A, it's an A or quad A, we got an answer. So with your experiment going, well, glueless, we ask for the NS, we don't give the glue, you have to. So it won't change your results dramatically, but we found that some, and I guess there are middle boxes somewhere that just don't accept anything else than A and quad A.
But Benno, when I've got the name but no glue, I'm now trying to find an A and or a quad A for the name.
Right.
I've walked out of the NS world and I'm now back into the mainstream. What's the IP address of this name? So yes, I realize there are issues with NS delegation, but in this technique, I'd convinced myself that glueless was brilliant. Right. But the real answers go, well, that's just a theory. And, let me find some counterexamples to contradict your thinking.
Thanks.
Yeah. the other guilty party.
Yeah, Petr Špaček, ISC. What can I say? I'm DNS engineer for like 15 years, and the longer that I do that, the more I'm amazed that it works at all. I think given the place we are meeting, perhaps we should consider switching to like sheep shearing or something. Better for your mind. Thank you.
Thank you. Thanks a lot.
Thank you. Thanks, Jeff. That was awesome. I'm going to quote you forever on DNS is shit. Now we are ready for the next speaker, which is Meinhard. Meinhard is a PhD student and a research associate in the Distributed and Network Systems team at the TU of Dresden. Before TU, he graduated in computer science in Berlin, and his research focuses on internet measurements to improve network security, and is particularly interested in DNS and scalable IPv6 scanning. Thank you. Take it away.
Right. Thank you very much for the introduction. Hello, everyone. So my name is Meinhard, and we're doing IPv6 scanning at our chair at the university. And we would like, or I would like to present to you an alternative approach to scan the IPv6 internet using subnet router Anycast probing. So a little bit of background here. What do I mean with common approaches? So common approach currently, for example, this is what this talk focuses on, is analyzing network topology. And a common approach here is to send out probes to random targets and then analyze the returning ICMP error messages. Because if I just probe a random IP address out there in IPv6, it's got a high chance that it's just not existent or not associated to any device. So what happens? We get a router that returns an ICMP error message, maybe saying host not reachable, network not reachable, whatever. But we can extract some information of that ICMP error message. In this case, for example, the router IP address that the router used to reply to our scanning infrastructure. However, if we probe more deeply into the network, in IPv6, it's required that routers implement some kind of error message rate limiting. So what happens is if we hit a router that has a bucket and we reach this limit with our random probing request, because it would like to generate an ICMP error message, we run into rate limiting and the router just drops the reply. So we wouldn't observe this router IP address when probing with random targets. So we can continue this and maybe run into another rate limit here. So we do not have a complete picture, definitely. The question was here, can we improve these common probing methods to elicit responses from more router IP addresses? And we found something in the IPv6 addressing architecture, RFC. There is a little subsection about the required Anycast address, and it says the subnet router Anycast address is something like what you can see here on the slides is basically the subnet prefix, the n bits of the subnet prefix, and then all other bits just set to 0. And routers with interfaces to this corresponding subnet should reply when we query the subnet router Anycast address. So they should not reply with an error message, but if we send a request to this subnet router Anycast address, we should see an ICMP echo reply. So the idea here is that we do not trigger error messages because an echo reply is an informational message, basically. So the assumption is that we are more or less unaffected, or at least less affected by rate limiting. So we could observe more of these router addresses when we use subnet router Anycast probing. So of course, we hit a subnet, we probe the subnet router Anycast address for which the first router has a subnet to, it replies with an echo reply. We continue using that knowledge, going further into the network, and again hitting a subnet for which the next router has an interface to, so it replies again, instead of, as you have seen before, just dropping the response because of ICMP error message rate limiting. And we can continue this and hopefully we find all these router addresses because they just reply with an echo reply and we don't hit any rate limiting. But there are two challenges. So the first one is, how do we know this subnet router anycast address, right? So we cannot just randomly generate a subnet router anycast address because it must match to an interface of that router. So how did we do that? We just partitioned the routable address space into more specific subnets and then iterate through all of these possible subnets and probe the subnet router anycast address of each of them. So for example, if we use a /32, we then partition the address space and probe all, for example, all /48 subnets for this input prefix. For the first one, okay, the router might not have any interface, but and we run into rate limit, but at some point we will reach an interface or the subnet router anycast address for which the router has an interface to. So it will just reply with an echo reply. Nice. So we can then probe that network because we now know that the this router has an interface to the subnet. So there might be something more behind it. So what we now do is we take this subnet and probe each /64 and generate the subnet router anycast address for this. And then we continue. Of course, maybe we reach another ICMP error message, hit some rate limiting. But if we're lucky, we find that the next router also has a subnet to a more specific network. And then we receive a reply from that router showing us his IP address, at least the IP address that the router used to reply to this subnet. So how well does this actually work on large scale in practice? We did a couple of measurements. We used subnet router anycast probing and compared it to random probing. So we run our measurements every 12 hours over 3 days. And what you see here on the y-axis is the number of unique router IP addresses, IPv6 addresses, we find using subnet router anycast probing and random probing. So main finding here is that SRA probing reveals about 10% more on average of router IP addresses compared to random probing. And the number of echo replies also remains stable over time, which might be an indicator that the SRR scans are far less affected by ICMP error message rate limiting. We also find about 9 million router IP addresses exclusively with SRA probing with this approach. Due to time constraints, I just would like to refer to our paper. There are more results. If you're interested, please feel free. There's one more thing I would like to talk about. Be cautious when you perform active measurements, because in IPv6 there are quite a lot of routing loops. Just very briefly, what are the routing loops? For example, if a router has assigned, or a provider has assigned /32 to its customer, and the customer only uses a fraction of this address space, then yeah, of course, if the customer router has no route to it, but it has configured a default route, what happens is when we try or when we query this SRA address, the router would just forward it because it knows it has some kind of path to this subnet. But R2 would just use the default route because the address space is not used, and it would just send it back to R1. That's where the routing loop emerged. And yeah, we receive at some point when the hop limit reaches 0, an ICMP time exceeded message. In our case, this was not only a single ICMP message, but more than 200,000. This was due to a router bug that may trigger amplification of ICMP messages. But there are more details in the IPv6 working group on Thursday. So feel free to come to that talk as well. 2 implications for active scanning. First of all, please exclude networks that lead to routing loops. So as soon as you find out that there are routing loops, if you actively probe this network, just exclude it and do not use unnecessarily high IP hop limit values here. So, conclusion, exploring the active IPv6 address space is challenging, but SR8 probing is actually a valid approach to complement existing hit lists and also replace random probing, but be aware of routing loops. You can find more details in our paper, which is linked here. And we also continue scanning once a week. So we scan a couple of subnets and publish a report under ipv6-sra.realmv6.org. And yeah, with that, I would like to conclude my talk. Happy to answer any question. Thank you very much.
Thank you very much for your presentation. Here we go. We have the first question.
Hey, Warren Kamari, Google. Could you go back to slides 16, 17, and 18? And while you're doing that, you seem to be making the assumption that things are often or almost always hierarchical. That like the first router has a supernet and then there are more specifics further down. And clearly that's true in some cases, right? You're getting more results. But I think it's definitely not always true. Like often a prefix is used for backbone or large connectivity, and then sites are not actually hierarchical. So
sure.
Okay.
Yeah, thanks.
Jan Linkova. Small comment. If you look in the address architecture, I suggest you look at RFC of 4291, which is much more up to date than one you quote. But what I'm a bit confused about, that address is supposed to be assigned on link. So there is no point of looking at that address in /32 because the router would only respond if you have an interface like assigned /64 or /127, and then it would respond. If it's just /32 on the like configured as a null route or something on that router, it wouldn't respond. It must be a link on that device. So I'm not sure how you can find more devices, like why you start scanning behind that router. If the router already responded, there is no subnetting behind it anymore.
Sure. I mean, if what we try to do is, if you mean the /32 example, this would of course be more in the core, internet core, right? But we still find these addresses replying, of course. But the main idea here is to just improve this random approach to just maybe get more stable results here, if I get you right.
Yeah, Eric Gang, Cisco. First, thank you for the speech. Excellent, good ideas. Like Jen, it's 4291 and not 1884, right? For your paper. The other point, like her, I don't understand why you get a reply on the /32, because actually what you are sending it into a /64 with a lot of zero in the prefix.
Yeah.
And now on the way you are enumerating, you go from a /32, then you go to a /48, right? You enumerate.
I mean, yeah, that's the idea. So we iterate through all of them.
But why don't you try from /32, you try 0 and 1 or /33, then a /34 to go binary search will be faster.
Again,
so go next slide or whatever when you say next.
Yeah.
Next.
This
one?
one?
So you know where you are doing, you went to A, 1, then B, and so on.
Yeah.
You are basically jumping by adding, enumerating 16 bits in one shot. So you are adding the prefix length by 16. So you should do it by one.
I mean, that's what we're doing. This is just for simplicity. So sorry if
No,
that
okay,
confused
that's
you.
You are as smart as we.
Yeah, okay.
Thanks.
Okay, thank you very much. Thank you very much for your presentation. And now we have the next presenter, Job Snyder. So Job is a consultant engineer who analyzes and architects global networks and PKI systems for future growth. He specializes in internet routing security and protocol design and runs RPKI views as a community project, and today he will present lots of free data, the RPKI spool format data materialization as used in RPKI views. Job, the stage is yours.
Thank you so much. Well, surprise, surprise, we're going to talk about RPKI. Let's start with what RPKI views is. All of you know route views. And when you see a good idea, you better steal it. So I made RPKI views in the image of route views, but not for BGP data, for RPKI data. Because about 5 years ago, I realized like, oh, we're using this RPKI stuff in the production environment. We're going around conferences, encouraging everybody to use RPKI data, and nobody is storing all the RPKI data. So this makes debugging events and retrospective analysis very hard. We need to start storing the data. Now, a fun thing about RPKI data is that there is a finite amount of it. With BGP, depending on your placement in the topology, depending on your relationships, and because of best path algorithm, there's basically an infinite amount of BGP. So the more collection sessions you set up, the more BGP messages you will see. In contrast, RPKI is sort of a single writer per CA data structure, and in theory, you can capture all of it, and yeah, then it's a finite amount of data. Now, not many others are collecting the data. RIPE-NCC for a number of years has been taking 1 snapshot per day, but the granularity of that is not fantastic in the sense that if a ROA is added and removed in the course of the day, it will not show up in that archive. So RPKI views tries to capture all the data. And when I started in 2020, a snapshot was about 120 megabytes. I was like, okay, that's not too bad. But as the years went by, the snapshot became larger and larger because more of you were creating more and more ROAS. So now we are at like 500 megabytes per snapshot, and this is a bit of a challenge. In fact, if we look at just one collector this year, I'm slurping in about 1.6 terabytes per month, and it's not great. But I have multiple collectors, so really I am so far in this year already at 20 terabytes, and the year is not even over. So the generation 1 approach of RPKI views was very cool in its simplicity. Like every tarball is 1 snapshot of the entire RPKI as it was for that node at that time, but it also is an entirely unsustainable way of collecting data. And well, it's not weird, but the flip side of it being so much data is that it also becomes less accessible for researchers. And when I say, oh, you can download all the RPKI data, and the researcher is like, I cannot fit 20 terabytes on my laptop. Sorry, Job, I'm going to research DNS. Yeah, I'm like, that makes me sad. Yeah. So something had to change, and if not just to save my own wallet, but also to, for the health of the ecosystem. We had a problem. So enter RPKI spool. And with RPKI spool, I try to make a standardized mechanism how the data capture is done, how to access it, what to expect from these archive files, what the naming conventions is, and document that as if you want to research the RPKI, use RPKI views, and RPKI views has documented that this is the approach, how the data is stored. The RPKI spool, you can sort of conceptually think of it as a tape recorder that throughout the day, as RPKI events happen, just stores all the events, and that the tapes are what you can later replay, and then you can replay the RPKI events throughout the day. So how this works exactly. A RPKI spool uses industry standard formats. So one of them is the tar or PAX, but we'll get to that later. It uses C standard for compression, and I am achieving insane compression rates. And it uses CCR, which is essentially a binary format containing a Merkle tree that is a snapshot of the RPKI state at a particular point in time. All of these are either POSIX standards or IETF RC standards. So this makes it accessible. There's no proprietary binary formats involved. Every day starts with a checkpoint, the initial state. Throughout the day, multiple collectors collect all the data and apply a change data capture process. So there's a second file, the RPKI spool. So every day gives you two files, the start of the day and the changes throughout the day. Now, in theory, if you are analyzing a series of days, you can skip the initial day states of every day if you just string together the spools. But this is to make life easy for researchers that you can latch on to any day in the year that you want and very cheaply start analyzing RPKI data. Here's a bit of a complicated graph of what's happening, but the purple line is the number of snapshots per day. So you can see that it's hovering around 2,000 snapshots per day, and that sort of means that like every few tenths of seconds a snapshot is taken. So that's really, really good resolution if you compare that to a snapshot once a day. The crossbarred green effect is the new objects that appeared in that day. So that's new CRLs, new manifests, new ROAs, new ASPA objects. And the solid portion, oh, sorry, I'm flipping it around. The cross green bar is the total number. Solid bar is the churn, like the number of objects that were replaced by a new version. And then in the bottom, you see in yellow the compression efficiency. Every day, the total capture in compressed form is around 1 gigabyte. But the gotcha is that the compression ratio is around 99%. So these are tiny GSOP bombs when you put them on your laptop and expand them, because then they become quite large. But it means that for durable storage and for long-term archiving, a gigabyte a day to capture the entire RPKI from multiple vantage points all over the world is a really, really sustainable model for the long term. So this is good. There are currently 14 collectors distributed throughout the world, like Amsterdam and Singapore and Zurich and Sydney and Bangalore. I don't really have great access in Africa or South America, so if you have some virtual machine resources you want to contribute to the cause, talk to me. I will happily take your memory and CPU resources. These collectors represent a diverse set of ingestion strategies. So some of them are rsync only, some of them first use RRDP and then rsync. Some of them have only V4, some of them have V4 and V6. Some of them only use RRDP snapshots and not the deltas. So there's like a wide variety of trying to access the RPKI data through various means, so that if there are discrepancies between, say, rsync and RRDP publications, I capture that there are differences between the different access methods. And as I mentioned, that's, it's costing roughly a gig a day, so that's good. Now, as I mentioned, 2 files a day. Initial state is the start of the day, and then the changes throughout the day. So you have the init state and the RPKI spool. And you can look at these files yourself if you copy off the European mirror on josephine.sobernos.net/RPKI/RPKI spools. In the checkpoint, that initial state, you'll see millions of tiny files, and they're sorted in a way that is optimal for compression. So everything that's similar or even duplicate is put close to each other, and then Z standard can do its magic. The first column in purple is the identifier of the collector, and then the second segment of the file name is the logical path to that particular signed object. So this is a really easy way to construct this was the initial state of that cache of that day. Then the RPKI spool, the one that captures the change throughout the day, is a little bit more involved. So we'll go through that one by one. The timestamps in these tar files are derived from timestamps inside the signed objects. And this makes, for instance, backdating detection super easy, because if in today's change capture, the today's RPKI spool, you see objects that have like a timestamp that was a few days ago or a few months ago, that means backdating or recirculation of old objects is happening. Then in the static directory, you see addressed by content. So the hash of the contents of that object are the file name, the signed objects, that is the CRLs, the ROAS, the manifests, and etc. And by naming everything according to the SHA-256 of the content, I get free deduplication, and it is one of the efficiency gains of this new system. Then we have a CCR, a canonical cache representation. CCR is a very modern standard. You can think of this as what MRT was for BGP is what CCR is for RPKI. And MRT is this binary format to record BGP information throughout the day. CCR is an entirely different format, but like conceptually, if you place the tools in the ecosystem, then they are sort of in the same bucket of utilities. And a CCR is essentially a binary encoding of many hashes, and that allows you to reconstruct particular points in time, but also to accurately capture a point in time in a very cheap way. Every CCR is like 20 megabytes, compressed 10 megabytes. If you put a bunch of them together in a tar file and do G-standard compression, it's even smaller. So it's a really efficient method of capturing what the validator was thinking at a particular point in time. Then other files in the RPKI spool are the standard error and standard out of the validation process, and a file that contains open metrics formatted information about that particular run. So retroactively sort of figure out like how long did particular aspects of the validation process take. You can interact with the data in these RPKI spools with RPKI clients. RPKI client has a thing called -f, or file mode, as you could call it. And if you combine that with, for instance, -j for JSON output, you get a JSON formatted decoding of the binary information, and that means you can pipe it into your Python or R or whatnot analyzing pipelines you do, and lift it out of the, say, harder to access binary format into something that is more accessible to researchers. So RPKI client is the go-to Swiss Army knife to interact with the files in these archives. The analogy to MRT in this regard is like RPKI client is your Mabo or BGP dump or BGP dump 2 decoder. In summary, I produce the RPKI spools with a 12-hour delay. So that means that today I publish yesterday's data. The reason is that if there are network partitions or synchronization issues to get the data from the collectors to the centralized compacting location, I have some time to allow that process to happen. So multiple retries are tried throughout the day to get the data into a central location, and that is why there is a delay. Also, the delay allows insane compression ratios, so it's very cheap to delay the data publication compared to real-time delivery. I'm almost out of time, but cool things you can do with RPKI spools. You can discover backdating in the RPKI. I think this is important to be able to detect, because if there are incidents, we must be able to understand them, and backdating is something that gets in the way of that. Misissuances happen. So for instance, under APNIC, sometimes when you delete a ROA in the web UI, it lets old ROAs reappear for maybe just a few seconds, and then those disappear, and then the system stabilizes. So it's really weird behavior to explain, but like a ROA you created a few months ago and deleted a few months ago can briefly reappear. That's not great. What it also allows you to do is search for, like, is the RPKI consistent across the globe, or are we in Europe seeing a slightly different version than in North America or in Asia? These are important questions to answer, because we expect that the RPKI has some global consistency, like some eventual consistency, but is that actually happening, or are there weirder things happening? And if there are like lawsuits or fact-finding missions where it's of critical importance to really understand what happened when with absolute causal certainty, RPKI views is useful for those purposes as well. Then my penultimate final slide. Earlier this week, somebody produced a ROA that was more than 100 characters file name. Apparently that doesn't fit in the US tar format. I was using the PAX utility standardized by POSIX to interact with US tar formatted archives. I now use the tar utility to work with PAX formatted archives because tar supports the PAX interchange format, but on many systems like FreeBSD and Mac OS X, PAX does not support PAX. So I hope I cleared this up for you, but you use the tar utility to interact with the RPKI spools which follow the PAX format. Great. Okay, if you have questions, reach out to me. I am doing this work because I think it helps the community, and I think data collection at scale is fascinating in and of itself. Like, I've learned a lot trying to store all the data in a cheap way. And if it's cheap for me, it means it's cheap for you to analyze it. But what you do with it, that is up to you. And I will answer questions about how the archives are structured, but like, your research is your research, and I am just here to make that possible. So this is an open invitation to the community. Please use the data that is there for free. Yeah, that's it.
All right, thank you. Do we have any questions for you? All right, we have 1 and 2. We're running dangerously close to being over time, so I'm going to take them quickly if we can. But
Hello, Paweł Foremski, the BG Pipeline project. Have you considered any off-the-shelf databases for storing RPKI data, and are you considering indexing the data?
This is a really good question. Thank you for that. And yes, I have considered this at length. But if I were to store the data in, say, Postgres, then what happens 20 years from now when everybody moved on to something else? So I was really looking for what is like the intersection between efficient, but also standardized multiple vendor accessibility. So then you really arrive at IETF standards or POSIX, neither of which have defined a online database engine, so to speak. So I consciously steer away from things like SQLite or Parquet or Postgres or MariaDB or like whatnot, because I anticipate that the researchers will take the RPKI spool and then convert it into an intermediate state that is useful for their project at hand. So you take my spool in tar format, you convert it to the database you like today, and you do whatever you want in that database, but I want to have it accessible in an open standards way.
Thank you.
Or can we aim for 30 seconds or less? Oh.
Hi, Sylvan from OpenFactory. The question is pretty quick. If I understood it correctly, the daily snapshot is not necessary to run your data. So in case of that, does it make sense to, for older data, sacrifice it for CPU and just recreate it?
So the daily snapshot is 500 megabytes, and the daily change data is also about 500 megabytes. So it, like giving researchers a step up to like very quickly investigate a particular day by having the checkpoint start of the day and then the changes since that moment, I felt was worth the 500 megabytes per day. But in theory, you know, if you apply a series of diffs consistently, you don't need the intermediate checkpoints. So I'm just trying to accommodate more use cases or make it easier, lower the barrier, so to speak. Anyway, email me at jope@bsd.nl if you need help with the archive or are willing to support in some way.
Nice, awesome. Thank you. Our next speaker today is Sam, who's going to be talking about detecting and characterizing DDoS scrubbing from global BGP routing, insights from 5 leading scrubbers. Sam is a final year PhD student at the University of Twente with research interests in BGP security and DDoS mitigation. He has 13 years of combined professional experience, having worked at Nepal Telecom and Cloud Factory in multiple areas, including network technologies and software development. Sam.
All right, thank you very much for my introduction. Good afternoon, everyone. I'm Sam. Today I'm going to talk about our work on detection and characterization of DDoS scrubbing from BGP data. This work was published recently as a paper in Passive and Active Measurement Conference. All right, first let me start with an overview of DDoS scrubbing. As you see here, an AS, I say it a customer AS, basically originates its prefix P and it forwards its announcements to an ISP, then the ISP forwards it to the rest of the internet. So that is a normal conditions, means no DDoS attack or no scrubbing is involved. Now consider a situation when a scrubber such as Cloudflare, Magic Transit or Akamai Prolexic comes into play for mitigation purpose. In this scenario, the customer AS starts announcing its prefix to the scrubber, and the scrubber forwards the announcement to the rest of the internet. In this way, the inbound traffic to the customer goes through the scrubber, and the scrubber filters the malicious traffic, forwarding only the legitimate traffic to the customer, which is represented by green arrow, and the outbound traffic from the customer exits through the normal ISP. So with this figure, we see that the scrubbing involves changes in routing behavior, and this is an example of attack-driven scrubbing. So the question we asked in this paper is, how can we infer scrubbing using BGP data? To answer that question, the first step was to select the scrubbers. In this case, in this study, we selected Cloudflare, Akamai Prolexic, Forsara, which is formerly Newstar, Imperva, and Radware. So the reason of selecting those 5 are because they were top 5 in terms of their bandwidth capabilities to mitigate DDoS attack at the time of our study. And the second reason is that they were identified as the leading DDoS mitigation solution provider by Forrester Wave Market Report. And the third reason is that there doesn't exist a comprehensive and authoritative list of DDoS scrubber in the internet. Then the next step is to identify the AS numbers they use for scrubbing. For that, we inspected the documentation of those scrubbers. We had conversations with the scrubbers, and we also analyzed past scrubbing events that were mentioned as blog posts by companies such as Kentic, Cisco Thousand Eyes. Next, we analyzed the public VCP data collected by RIS root collectors. We basically analyzed RIPs and updates. VCP RIPs is a snapshot of data that is collected every 8 hours by the collectors, while updates are collected every 5 minutes. And in our study, we analyzed 30 days of data in May 2025. Our inference approach basically looks into the AS path changes that are associated with mitigation. And we require at least 2 collector peers see the changes. This is basically to improve the accuracy of our inference. Using that methodology, we basically found 2 types of scrubbing, or we defined 2 types of scrubbing. One is always on scrubbing. In this case, the traffic towards the customer always goes through the scrubber, which means a prefix will have a scrubber as an upstream in its AS path. And we observe that thing in BGP RIPs, and we see those prefixes have one of those scrubbers for 30 consecutive days. So basically we see a customer AS and scrubber as an immediate upstream AS. The second type of scrubbing is on-demand scrubbing, which is basically attack-driven activation, and when the attack is over, it gets deactivated. To find this scrubbing, we analyzed BGP updates data, and we observed 2 types of on-demand scrubbing. The first one is upstream change. In this case, the customer AS originates its prefix itself, and they simply switches their upstream provider to the scrubber. And the second case is origin change, where the scrubber originates the attacked prefix on behalf of the customer. In this way, we see the scrubber AS as an origin in BGP AS paths. So we detected those 2 types of on-demand scrubbing using same-day and cross-day approach. So same-day means the scrubbing is activated and deactivated on the same day, while the cross-day means scrubbing is activated on one day while it was deactivated on the next day. And we considered 48 hours as our study period. Here I present our findings of always on prefix for the 5 scrubbers of our study. We observe the dominance of Akamai in our data set, while we found a very low number of prefixes that Vorkara has its customers. Next, I present our findings on upstream change scrubbing for 5 scrubbers. Here you can see in the y-axis there is scrubbing activations, which means the number of prefixes that were scrubbed by those scrubbers, and the x-axis represent the number of days. For now, I want to draw your attention into Cloudflare and Akamai. As you can see, Cloudflare was engaged every day, all the days throughout the 30 days of our study period. And it also gives us hints that DDoS attack is still common, and there is at least 1 prefix that is under attack. And the Akamai comes second to the Cloudflare. Next, we present our findings in origin change scrubbing. Here you see only 4 scrubbers. It is because we didn't observe any such cases for Imperva. And we found a very low number of cases for Cloudflare and Akamai. For example, you see only one origin change cases with Cloudflare. So it means most of the customers of Cloudflare and Akamai go for upstream change of on-demand scrubbing. And for Versara and Radware, we found a high number of such origin change scrubbing. For those prefixes, we analyzed their RPKI practices, because this is directly related to route origin validation things. For example, we observed 52% of those scrub prefixes were RPKI valid, while 12.5% are invalid. Invalid means those prefixes originated by scrubber didn't have ROAS with those scrubbers as origin ASNs. And this indicates that the scrubbing approach might be undermined because the ROA validating ASS might drop such invalid announcement. After analyzing the number of prefixes that went scrubbing, we also analyzed the duration, scrubbing session duration. So in our case, we define scrubbing session as the timing between the first time a root collector peer saw scrubbing activation and the last time a root collector peer saw the scrubbing changes. As you can see in the figure, 25% of scrubbing sessions lasted less than 1 hour and 45 minutes, while the median duration was about 10 hours and 45 minutes. We found some prefixes which lasted longer than 15 hours. And upon our conversation with the scrubber, he mentioned that it might not necessarily be a true DDoS attack. There might be cases where customers continue to announce their prefix towards the scrubber as a precautions. And this also gives us a hint about the durations of DDoS attacks that's happening. Then to summarize our work, we inferred scrubbing events using public BGP data. We observed the dominance of always-on prefix over on-demand prefix in our study period. So the reason could be the number of attacks in that time period might be low, or in general, always-on prefix, always-on protected prefix might be higher because of operational simplicity of such protection. And we observed the dominance of upstream chains over origin change scrubbing. And we suspect, or we guess that the reason could be that the upstream change model of scrubbing gives the customer edge the flexibility to originate their prefixes themselves rather than delegating the prefix origination tasks to the scrubber. And we found some RPKI invalid prefixes that were originated by scrubbing, which might undermine the mitigation approach. And we hope that this type of insights or work could be useful for BGP monitoring systems to interpret routing changes that are consistent with scrubbing. As a future work, we plan to measure the effectiveness of scrubbing by measuring the coverage of routes during scrubbing. The reason is because there might be some cases where scrubber is taking long time to take control of all the internet routes towards the customer, and some malicious traffic may still be reaching to the customer. So with that, I conclude my presentation. Thank you very much for your attention, and I would be happy to take your questions.
Thank you very much. Thank you for your presentation. So any question? Okay, so I have, go ahead, please.
Hello, my name's Ivan Beveridge, no affiliation. I can talk to you separately about some of this, but potentially a reason for always on is certainly with companies that don't want to get hit and then have to take a while to actually go under mitigation. And typically those companies are sort of have high value traffic.
Mm-hmm.
And so they'll pay the higher upfront costs for that. also potentially for those who are, you found some long-running going under mitigation and then taking a while to come out. Some companies also kind of want to come out either when they're fairly sure that all the DDoS traffic is gone, or during a maintenance slot to some extent. So you may find that if they've got a maintenance slot at 10 p.m., something like that, even though they went under at 1 a.m., they may leave it till 10 a.m. that day to actually come out, even though traffic, DDoS traffic might have stopped within half an hour. I'm happy to talk to you after separately. Thank you very much.
Okay, thank you very much for sharing your insights.
Thank you very much.
All right, thanks.
Now we go to the last presenter of this session. We have David Belson. Where is David? Oh, right. It's remote. I should have read that. David is the former head of data insight at Cloudflare, where he was responsible for Cloudflare Radar. With over 30 years in the internet infrastructure space, he has worked with content delivery network, cloud platforms, and web hosting providers. For the past 18 years, David has used internet measurement and monitoring data to produce expert analysis and generate media coverage, with a particular focus on internet disruptions. So David will present about Iran internet shutdown. And David, the stage is yours.
Great, thank you, Massimo. Yeah, and I am unfortunately the former head of data insight at Cloudflare. I was hitting the layoffs that happened last week. So the content I'm presenting today is all based on public graphs. So there's nothing proprietary in there, but I'm not officially representing Radar or Cloudflare, excuse me, in this context. But what I will talk about today is a high-level overview of using Cloudflare Radar to help us understand more about what happened in Iran and with Iran's internet during these shutdowns. So I'm sure that many of you are familiar with Cloudflare Radar, but for the few of you that may not be, it's a platform for global internet traffic, security and routing and technology trends and insights that are built on top of data from Cloudflare's network. For the most part, we do get some other data from other organizations within the industry. It's at radar.cloudflare.com, and I definitely encourage you to check it out and explore it when you have a moment. So we'll talk about a little bit of background. Talk about a little bit of background, some things that we saw ahead of the January 8th shutdown, what happened on January 8th, what happened then on the second shutdown, February 28th, some artifacts or potential artifacts of circumvention tools that may have been or that may be used in Iran, and then just a quick wrap up. So in the past, Iran is no stranger to internet shutdowns. Back in September 2022, there were a number of shutdowns and curfews that were implemented during the protests that were related to the killing of Mahsa Amini. You can see traffic bottoming out over several days in late September and early October there in the graph. That shows RightTel in particular, but similar patterns were observed across multiple networks within the country. And then almost a year ago, when Israel launched a campaign of attacks against nuclear and military infrastructure in Iran, you can see some impact to internet connectivity there as well. That attack happened on June 13th, and some initial restrictions were put into place that day. You can see traffic dropping. And then there's a very clear shutdown that took place between the 18th and the 21st. You can see the traffic line there going to zero effectively. And then traffic began to return after the ceasefire was announced on June 23rd. So you can see it starting to climb after that and then returning to more near normal levels in the following days. So if we look at the initial January 8th shutdown, what happened before it that might have given us a sense that something was happening? So on New Year's Day, one of the things that we observed was that the share of DOH traffic, DNS over HTTPS traffic, from key Iranian networks to the Cloud One resolver operated by Cloudflare, that share more than doubled across both of these network providers. And while it's not a smoking gun that anything was going to be happening, it may have been indicative of additional filtering or increased filtering of DNS traffic over port 53, so standard unencrypted DNS traffic. And then similarly, we saw shifts across the same networks in terms of traffic share for HTTP3 and QUIC starting on January 3rd, where these networks generally saw H3 and QUIC traffic account for about 40%, and that dropped to generally below 5%. There were a couple of spikes there you could see across TCI. But again, this may suggest that there was some increased filtering put into place. And perhaps the most interesting observation here is what happened just before the internet shutdown was implemented on January 8th. So about 4 hours ahead of that, just before noon UTC, we observed an almost 99% drop in announced IPv6 space from Iran. So it went down from about 48.4 million /48s down to 737,000 /48s. And Asia Tech and Rasana just together accounted for about 17 or 18% of the lost IP space. They both saw significant drops. The flip side here, though, is that the radar data showed that less than 0.1% of HTTP requests from Iran took place over IPv6. So ultimately, the withdrawal of the space really had no impact on the overall traffic levels from the country. So it wasn't really necessarily a, hey, we're withdrawing IPv6 space, and we're going to see traffic drop significantly. But what we did see happen was that after the 2 weeks of protests that were going on since around Christmas time, they finally implemented or imposed a complete shutdown. So traffic fell really rapidly. You can see that obviously in the graphs around 16:30 UTC. You can see it plateaus for about an hour, so it doesn't quite reach zero. So the graph on the right there by region is zoomed into just 24-hour view. So you can see it plateau there a bit, and then another hour later, basically drops off completely and goes to zero. So it's not clear why the hour-long plateau that I just mentioned happened only across 4 of the 5 providers, or 4 of the 5 top providers. RightTel, again, was the only one that fell to 0 basically immediately. So not clear why they were sort of singled out there. The graph on the left shows HTTP request traffic. The graph on the right shows DNS request traffic to the Quad 1 resolver. And what you can see there is that it drops off again at that same time around 16:30 UTC on the 8th. But then the next day, we see some traffic return a bit. So traffic, DNS request traffic from both TCI and MCCI spiked around 10 o'clock UTC. And then DNS traffic from AS 49666, the orange line there, returned around the same time, but stayed more consistent, albeit at a lower level. And then we saw traffic recovery in fits and starts throughout January. I've listed there a few days where we saw traffic, blips. You can sort of see them on the graph there. The really, really small ones on the 17th and 18th, a little more sustained, a little bit higher on the 21st, 22nd, same thing on the 25th and 26th, and then a more aggressive recovery starting on the 27th. And most of that traffic that we observed coming back generally was from MCCI and Iran Cell, so 2 major mobile providers within the country. And then after the end of January, we basically saw traffic more consistent throughout February. And that is, of course, until the events of February 28th. So on February 28th, the US launched attacks in Iran around 6:15 UTC, or around 9:45 local time. And about 7 o'clock UTC, so about 45 minutes later, we saw internet traffic from the country drop precipitously, and really hit about, at that point, hit about 98% lower than the same time the previous week. So it's a really clear loss of traffic. Clearly things were shut down. And what you can see if we look at it from the top providers is again, the HTTP request traffic dropped to zero basically almost immediately. You can see also the traffic, the DNS traffic drop is visible within the chart on the right. So if you look at February 28th, you can see a little bit of a drop there. But what you can see is it doesn't really totally go away across most of those major providers. You'll see it start to grow again over the next several days. And then it drops off sharply around March 6th, and we'll talk about that in a minute. So if we look at the traffic distribution across the ASNs within Iran, you can see the few days leading up to February 28th is fairly consistent. But after February 28th, about 99% of the traffic from Iran was lost, at least from a Cloudflare perspective. And you can see that the distribution of the remaining traffic was really very different. Iran Cell, the light blue, was dominant for the first week and then dropped. And then you can see that MCCI had a smaller share in that first week, but then grew and was responsible for almost half of the traffic times throughout March and April. And the shutdown, is still going on. We've seen a little bit of growth. You can see it there in the chart. Some minor movement starting in mid-April. That's due to allow listing of additional websites and web applications. It's due to the so-called white SIMs and the Internet Pro service, where there's tiered access available for different folks within the country. But by and large, the restrictions and the filtering remain in place. It would have uploaded this graph to basically through this weekend, but unfortunately lost access to the internal system that this graph comes from when I was let go last week. So we see that the traffic going away, but we also know that there's been attempts at circumvention. So the DNS traffic, an analysis of the DNS traffic, I think gives a good perspective on that. So DNSTT is a tunneling tool that can use DOH, DOT, or UDP53, and attempts to encode data in resource records like text records. So that previous spike I mentioned after the following the February 20th shutdown, we can see on the traffic on the right that there was a big growth in DNS requests over UDP53 because it was so, majority, I basically removed it from the graph. And then what we can see also on starting February 28th is that the share of text record requests coming from Iran also grew significantly. So it reached, basically, it was the majority of the requests over that first week. But we can also see, so this shows it a little more clearly, and this text record requests were coming from a mix of the major providers. Nearly all those requests are coming from RightTel, MCCI, AroundCell, and TCI. But something shifted on March 6th, and we saw that the text record traffic from RightTel, MCCI, and AroundCell dropped significantly. And over time, it basically disappeared. You can see the dark blue, light blue, and orange shares just really peter off over the coming weeks. So another indicator here, another potential artifact of circumvention is this burst in traffic that we saw on April 14th. And this coincides with the release on GitHub of a tool called SNI Spoof RS. It's intended to work through Cloudflare, but we believe that the short duration of the spike suggests that the authorities in Iran probably detected it and blocked it fairly quickly. And unfortunately, this is something that I was asked about a lot, as the media was covering the shutdowns, is, what about Starlink? Do you have any visibility into, Starlink usage in Iran? Unfortunately, because there are no Iranian entries in the Starlink geofeed, we don't have visibility into the traffic coming from Starlink in Iran. So just wrapping up, the Iranian citizens unfortunately have spent most of 2026 to date offline. The little traffic is left from Iran. The distribution across network providers is very different and more volatile than what was before February 28th. And just be careful out there if you're using circumvention tools because they can leave fingerprints. And finally, contact information for both me and where to find Radar, the Radar-related resources. And if I know there's a few seconds left, if there are any questions. Thank you.
Thank you, David. We have people lining up, so take it away.
So, hi, Warren Kumari, Google. Would you mind going back to slide 4? And while you're doing that, Cloudflare Radar is a really wonderful service, and I'm sincerely sorry that you're no longer involved with it.
Thank you.
I hope it continues to exist and thrive.
As do I.
So, looking on the right graph, before the shutdown, there was a noticeable difference between total bytes and HTTP bytes. And then after the shutdown, when it came back, is the delta mainly sort of the loss of 1.1.1 DNS traffic, or do we know what the delta is, like why the lines now match?
I don't know. So if I had, I can try to dig in. Well, I can try to contact folks to try to dig into it. But what the delta may be would be potentially DNS-related traffic, potentially warp traffic. We had graphs internally that would break out the traffic by service.
Okay.
So yeah, sometimes when we see these gaps, we'll see warp or DNS often accounting for the difference.
Thank you.
Shane Kerr, IBM. I'm also very grateful that you were able to make this presentation. So do you think it's possible that increase in TXT record traffic was some IP over DNS or something equally terrible?
I don't know. So we didn't dig into, obviously what was in the requests. We could just, we were just doing the analysis by breaking it out by the different protocols or different request types, things like that. So,
okay.
But it aligned with what DNSTT can do.
Yeah. Okay.
Blake Willis, speaking as someone with a lot of Persian American, Persian Canadian friends, one of whom just got back from Iran yesterday on a sightseeing trip, and the airport got bombed, so she had to change her flight. Thank you very much for this, and sorry to hear about the layoffs. Obviously, it's pretty hard to see because people are changing their location and so forth, but my friend who was there was able to chat with me just fine while she was there over a VPN, and I have no idea how that was actually working, but she gave me the IPs of her servers, and they were all in Iran. Do you have any, I know the data is probably not concrete enough to share here, but do you have any visibility into VPN use and like the success of that during this time?
Not offhand. The only thing I can think of would be if you have the IPs and you know that if they are like third-party VPN providers, yeah, and you know the ASNs, you could use the Radar Data Explorer to look for traffic from Iran and AS whatever. To see if that's coming through. But if it's a VPN server that's on one of the regular Iranian networks, then you sort of it looks like the rest of the traffic.
Yeah, thanks.
Thank you so much, and thank you, David.
Thank you.
It's great you could join us.
Thank you.
All right, and this brings us to the end of this working group. Yeah, I'm going to do a clicker. We're going to do all the remarks. Please rate the presentations, discuss them on our mailing list, and you can send us direct feedback. Before I let you go, there is one announcement that we haven't done yet. It's going to be very brief. It is that this is my last RIPE meeting as a working group chair for MAT working group. I've been around forever. I do not want to count. So it is time for new blood. So the process is going to be handled by my remaining co-chairs on the mailing list. But I just want to say thank you to all of you for all the years. It's been great. Love you all. And see you all in Sofia.
Session, the Diversity, Equity and Inclusion session here at RIPE 92. So welcome everyone. Before we start, a couple of announcements and some housekeeping. So the first one is tonight's party, and I know you will all be raring to go there. So there are no buses to the venue. You can take a cab, you can walk there, you can take a local bus or something. The directions are on the website, on the RIPE 92 website for tonight's party anyway. There will be one bus, but exclusively for those with mobility issues, and that will be leaving the Moxie Fountain Bridge at 8:45 sharp. So, okay, a bit of housekeeping. There will be time for Q&A with it after each talk or discussion. And we have, if you have any questions, there's a microphone down this aisle over here and a microphone down the other aisle. However, if you are not feeling brave enough, because this is a safe space, and you'd rather ask a question on MeetEcho, then we have Olka from RIPE NCC, who is not only doing the scribing, but she's also the MeetEcho chair for this session. And I think that's it. Anything else? No, that's it. So the theme I chose for this session is I want to break free. And I'll take a small moment to explain why, because it connects everything you are about to hear in a way that I think matters. At RIPE 91, that session focused on the D in DEI, diversity. This time we move on to E, equity. And we are continuing with the human stories, because that is where the real conversation lives. Breaking free does not always look dramatic. Sometimes it's quieter than that. It is the work of saying, this environment is not working for me and I deserve better. It's landing a job on your own terms when the system was not built with you in mind. And it's finally having a name for something you have been carrying for years without knowing what it is. So, 3 talks, 1 thread. I will open up with You Are Not Alone as the first talk. It's about toxic workplaces, the patterns, what any of us can do. Henrik Howell Pedersen and Peter Madsen will follow with a different way to success. It's a story about employment, inclusion, and what it actually looks like when an employer gets it right. And Rob Lister and Paul Ginsberg will close with a talk on rejection sensitivity dysphoria, something that affects more people in this room than you probably realize, and it likely affects me as well. So, let us start. So this is quite a difficult conversation or a difficult talk. It took me a long time to write this, even though It's something that we all feel familiar with. A lot of people in this room will feel familiar with this. So maybe not something that you have talked about openly, maybe not even something you have even admitted to yourself. And it's based on a short essay written by a very, very close friend of mine, actually from this industry, who gave me permission to share it via this talk. They wrote it because they had been through something that took a long time to name, and they wanted other people to recognize it faster than they did. When I read it, I recognized things I had heard from other people across this industry. And when I shared it more widely, the response was immediate. People saw themselves in it straight away. That told me everything I needed to know about how common it is and how little we talk about it. The subject is toxic workplaces. And it's not the dramatic kind. It's not the shouting. It's not the obvious villain. It's the quiet kind. The kind that creeps up on you, where meetings get cancelled and feedback disappears, where your role shifts without explanation, where your ideas get ignored and then celebrated when someone else repeats them, where blame always finds the person doing the actual work, and where slowly you begin to doubt yourself. Maybe I am the difficult one. But no, you are not. So toxicity does not announce itself. It seeps in quietly. And the self-doubt it creates is not a weakness. It's part of how the environment works. It makes you internalize what was never yours to carry. The emotional cost is real, and it's cumulative. People who've been through this describe a loss of confidence that goes beyond work. It gets into how they see themselves. They even feel isolated, even when surrounded by colleagues and friends. There's a constant low-level exhaustion that never fully lifts, and there is a fear of speaking up because people causing the harm are often respected figures in the community. And speaking out feels like career suicide. Don't burn your bridges is what you get told all the time. And so people stay silent, not because they do not know that something is wrong, but because the cost of saying so feels too high. In an industry like ours, built on long-standing relationships, closed networks, and reputations that carry enormous weight, that silence becomes a thing that protects the problem. It's not neutral. Silence is active. It gives permission. And one thing that does not get talked about enough is what happens after. When someone leaves or speaks out, or when something uncomfortable becomes public, the ghosting starts. People who were considered friends go quiet. Messages go unanswered. Misinformation spreads quietly through old alliances. Powerful people close ranks and others follow without ever questioning the narrative. And this is one of the harder things to sit with. But here's a reframe. The people who disappear without asking, without any curiosity or care, they were not really there to begin with. Real friends, they come to you. They ask. They listen. Their loyalty is to the truth, not to reputation or to power. Legacy loyalty protects the powerful. It does not protect the people being harmed. And if you're watching this happen to someone around you right now, please do not stay silent. You do not have to blow the whistle. Just check in with them. Back up their ideas when they get ignored in a meeting. Challenge the gossip when you hear it. Be the ally you wish someone had been. Silence signals that it is acceptable. Even a quiet show of support makes a real difference. So what do you actually do if you are in it? Document everything. Dates, names, decisions, your responses, not just as evidence, though it may become that. Writing it down is also a way to validate your own experience when everything around you is telling you to doubt it. Talk to someone outside the organization and outside the situation, a friend, a mentor, anyone not embedded in the same dynamics. Silence, again, is what toxicity feeds on. Build connections beyond the job and this corner of the industry. Those relationships will remind you of your worth when your workplace is trying to convince you otherwise. Set boundaries. Protect your time and your energy. And know when to leave. Because leaving is not a failure. It's actually an act of self-respect. No job is worth your peace, your mental health, or your dignity. If you are further along, if you have already left, if you are in recovery, healing is possible. It is not immediate, but it does happen. Reconnect with genuinely what excites you about your work. Reflect on what happened without turning the blame inward. Redefine success on your own terms, not the terms of the environment that harmed you. We need to build an industry where integrity matters more than influence. Where the most valuable asset, and I genuinely believe this, it's been on my LinkedIn profile for donkey's years, is its people. If you are in it right now, you can get out. If you're watching it happen, you can stand up. And if you have survived it, healing is not only possible, it is your right. You are not alone. Thank you. So, seeing as I'm chairing the session anyway, any questions, any comments?
Neil O'Reilly. Sorry, I guess I'm at the front. One of the things, I'm not sure that affiliation matters here, and what I'm going to say has nothing to do with Tolerant Networks Limited. But one of the problems that I've encountered is that by the time you've admitted to yourself what the problem is, you're way behind in documenting what's happening, and the burden of keeping the notes is unbearable.
Thank you. I'd just like to say that one of the things for this talk is that actually making people aware of how it manifests, how the toxicity manifests, and just to be aware of it. So hopefully people will be aware when it's starting to happen to them, or if they're going through it right now. So at that point, they can start documenting.
Yeah, Mireille, I once worked in a toxic work environment, and an interesting revelation to me is that in diversity, equality, inclusion, uplifting is an important aspect, but I also witnessed that from the other side. It was kind of centered around a quite powerful and high-placed person, and those who went along with him, they felt also uplifted by him, but they also started to copy some of his toxic traits. And that was a very interesting revelation. So if you are in a toxic work environment and you see your colleagues, maybe even your friends, start to copying these toxic traits from the powerful person, that is your cue signal.
Thank you.
Tobias Siewich. What I would like to emphasize, because this was pretty much about uplifting those suffering, but also one of my biggest fear is to, at some point, be a person people do not tell anymore when they are wrong. And that is something we have to be all way more aware of. telling a good friend who's being an ass to fuck off and get their shit together is an act of love. And we all need to do that more, regardless of the esteem of our friend. And we also have to do that when we feel ourselves in a safe position to people in positions of power. If we can afford it, we should do it. And if it's friends of ours, we have a duty to do it out of love for them.
Thank you. Right. Anyone else? Any comments? Oh, okay. Janos.
Yes, Janos Rocco. Actually, listening to your talk, I just realized how lucky I am because I actually never was in such a place, in such a toxic environment, but I fully understand how bad it could be and how important it is to help your friends. Thank you.
Thank you. Okay. Mark.
Yes, Mark van der Wal. I have been in the position of knowing someone who was in a toxic work situation and recognizing it myself, telling them that this is not acceptable, what they are what they're going through. And it was really hard to convince them that that was not okay what they were going through. They had to leave. Because sometimes, and even sometimes the hardest part is not deciding to leave. It's, okay, I should leave, but where to?
Yeah.
Thank you.
Okay, thank you. Okay, Rob.
That's a brilliant talk. Thank you for that. And I have two comments, questions. One of which is, I've worked in a place where the following happens. We all talk around the water cooler or in the pub or after work. We all agree, we know what's wrong and what we need to do to fix it. And then you go into the next meeting in the office and I get up and I go, this is wrong, we should be doing this. And then all of the others, my colleagues, are now, they don't want to get up and say the thing, but I'm not the sort of person to just let that go. I'm like, I'm going to say there's something wrong, and whether management want to hear it or not has got me into trouble in the past. But okay, I'm going to say it, and it pains them sometimes to listen to me poking holes in their plan. What would you suggest for that sort of situation where you just, everybody knows and they'll all talk privately, but then you don't feel able to get the support on the record?
That is quite a difficult one because it's always power politics at play. And I think people are scared of losing their jobs, so they won't say anything. And I think, a lot of it just perpetuates the toxicity within the workplace because people are just too scared to say anything. They know things are wrong, but they won't say it, and it just goes on and on and on. And I think basically some HR departments aren't very good at this. Either you may go to them and mention to them that this is what's going on, but they don't take it any further forward. They will address your issue, but nobody else's, or a wider issue. And it's a difficult one. I don't have an answer to that. I think society needs to change. I think people need to change and be a bit braver. But it's difficult. It's very, very difficult.
Speaking of HR departments, that was the next thing I was going to say was I've discovered over the years that HR departments are not my friends. They are there to support the company, not necessarily me.
Yes.
And they will say all lots of lovely, nice things, and they will try to say, yes, so we'll get back to you, we'll let you know. You have to sort of be a bit pushy at them and say, okay, when are you going to come back? What, this time next week? Because they will basically want this problem to go away. They want to bury it. So you have to get specific and get dates. So this is where you're documenting things, writing things down, or just send an email after every interaction that somebody says. Just follow up with an email. But, just following up from our conversation, this is what we agreed with. All of that counts.
Yeah.
And that's what you need to go to HR with. And someone gave the best tip ever. But if you end up in that situation, you ask one question to HR they really don't want you to ask, what is the legal basis for any of this? Because then they will be forced to go back and actually look and say, okay, what actually is the legal basis for all of this?
Thank you. Thank you.
Hello, I'm
Hi.
Caroline Vos, the CHRO of the YPCC. I was already planning to stand up, but then I thought, okay, now I'm really doing it. First of all, how you create culture is something that you really do together as a whole organization. And of course, leadership needs to lead by example. But when we talk about culture in the YPCC as well, I always say we can have all these nice processes and procedures. But if we stop talking to each other and talk about each other and not with each other, then we know it will go downhill very, very quickly. But that's not easy because giving feedback is difficult, but receiving it in a constructive way is also not easy. And you see a lot of discomfort happening when people stop talking. And also if that happens from a leadership perspective, the leadership gives the wrong example. So I really believe that culture you build together and a safe work environment is also something that you need to create together. And that's not easy when you have so many different personalities, cultures, backgrounds, experiences. I have my experiences, Hisham has his experience, and then together we communicate and maybe see something from a different perspective. But continuously talking and try to find a common ground, that is what works. And just to respond a bit to the HR part, what I always find difficult is I'm the CHRO for the whole organization. So if there are two colleagues having a fight, I need to listen to both sides. And that makes it sometimes difficult because I need to be neutral while both parties want me to take sides. And that's not my role. However, I do also have heard the stories about HR departments really only supporting the organization. I hope to really set an example to support everyone within the organization. But I think it's a good topic to bring forward here. And that we support each other, that we look out for each other and care for each other is the way to have a healthy work environment.
Thank you. We have actually run over time, so I'll have to stop. Okay, just go a bit over time then. I'm the chair, right? So before you, Matt, Ulka, is there anyone online? No. Okay. Matt.
Matt Poundset, DNS.org. I will be fast. I was going to expand on the comment about HR departments. HR departments, I think, more precisely, are there to keep the company from getting sued. Sometimes that puts them in alignment with you. Sometimes it doesn't. But that's why it's important to show up with documentation and also document interactions with HR as much as you do with whoever the toxic issue is with.
Sure. Thank you.
So Tobias Siebich again, I would like to follow up on the comment from the chief HR person from our NCC. I think one part of being good in that role, also in the sense of diversity, is acknowledging that one is protecting the company. It of course feels nicer to say, like, I'm here to support everyone, but I think everyone is supported better by being honest and upfront of the role of HR and making sure that the organization itself has support channels that help people being supported independent of an entity that necessarily, due to their role description, has a conflict of interest.
Thank you. Just one thing, I think it's anyone who's going through this, the documentation side of things, this is where you need a friend. This is where you need someone to keep you grounded rather than go emotional, because the other side of that toxic environment will just switch off. And so you need to be grounded, and a good friend is definitely needed in this. But okay, well, Kathy, I'll have to close.
It's a really quick question, Kathy Hammond, ISC. Nothing to do with ISC. Should organisations, corporate organisations, have, in addition to their HR, a welfare officer?
I think that would help. Yeah, thank you. Okay, well, thank you for giving me the opportunity to talk about such a... Thank you. Yeah, it's a difficult topic, I know, but it needed to be said and brought forward again, because this topic did come up a few years ago. Now, so as my talk was about what happens when environments fail people, the next talk is about what happens when they do not, when someone actually gets it right. So we've got a bit of positivity here. So Henrik Haug Pedersen is a network engineer at Norlys in Denmark. He's also a disabled person who works flexible hours, and the path to where he is today was not straightforward. The industry we work in is not always built with people like Henrik in mind, and he's going to tell you honestly what that has felt like. But he's not here alone. His manager, Peter Madsen, is with him, and that is what makes this talk something quite different, actually. So you're not going to hear the same story. You are actually going to hear the same story from both sides of the desk. What it took for Henrik to get there and what it took for Peter to make it work. What you have to think about as a manager and what you have to be willing to do differently. There is also a quiet truth in this talk that I do not want to give away, and how many people in this industry are quietly navigating something similar, what that means for all of us. So please welcome Henrik and Peter.
Yeah, so this talk is about me and how I finally managed to land my dream job at Norlys and some of the challenges that has been on the way. So first I'm going to talk about my previous work experience and some of the assistance that should be for the workplace and for disabled person, and then I will go through some of the challenges of finding a job, and then Peter will take over.
Yeah, I'm going to talk a little bit about the management perspective of actually hiring a disabled person into your team, what it actually takes from your work environment. I'm talking a little bit about building a safe work environment. I'm also going to share some of the improvements that we still can make at Norlys in order to facilitate the disabled people. And then I'm going to show you some of the hidden benefits from actually hiring people with a disability in your company.
Yeah, so you heard a little bit about me, but 29 years old and a network engineer, but the more interesting things is the actual package I come with. So I previously had the epilepsy, which means I needed to take some medicine to avoid my body from locking up in all different type of ways, but I still have cerebral palsy, which means that my right side of my body is not as steady as normal people, and I've dyslexic, which means it's hard for me to write and read stuff, but understanding stuff is not an issue. And then I've ADHD, which can mean that focus can vary depending on the actual interest in the task, and it's also can be hard for me to attend large gatherings where there's a lot of noise. So here's the journey to Norlys. So first back in 2017, I worked at Lund & Benz for a development company, but that was an okay in the beginning, but my department was very small and got sized down, so for a half year, I basically was the only one with nobody to spare with. So yeah, after that, I went to Triple IT in 2018, where it worked really well because I had the actual work body, and I was seen as the extra hands to get stuff done. But then Corona hit and messed that up. So in 2020, I took a CCNA to try to get to the actual networking part, but still Corona. So in 2021, I went to Intendbus, which was a bad experience both for me and for the company because it was very busy. I felt that all the way, so the learning experience was not very good, and I felt I was sitting alone with getting too many tasks and nobody to spare with and help me with the actual getting things done. And then I managed to get to Nordic last year in June. So some of the challenges, difficulty with disabilities is that the workplace should not put too much pressure on the disabled person because it's easier for them to get overwhelmed, and it's also a requirement to actually be present and understandable for the workplace, and assigning a work body which is not necessarily the boss is also a great help to have a dedicated person to contact. And for the person itself, it requires you to share your needs and tell when the limit is reached, and do not hesitate to ask for help. But it's also a requirement for the company to encourage that, because if it's too busy, disabled person will probably just stay silent. And so finding a job, it's also a very difficult task because I'm not fitting into the 37-hour job position. So, and those positions are not being advertised that much when trying to find a job. And there's also some additional challenges of finding. People are afraid to employ people with disabilities because there's extra things that need to be done. Also, when there is disabilities involved, I feel I'm being put last in the queue because he can't do the same thing as a normal candidate. So finding a job often requires of knowing somebody in the company to easier get employed. And it's also required for the company to it's more work for the company to include a flex time work or part-time, because it's not the same as hiring a normal person. And it's very good to work at Nordic because I have the freedom to look into what I actually want to look into, and there's not too much pressure on me, and there's the support I need, and I have good colleagues, and as part of my work, I can follow interesting networking conferences instead of having to take time off or use extra time to follow interesting things that are happening. And then I will hand it over to Peter.
Yeah. Good job. So a little bit from the management perspective. So what you have to think about when you're looking at these applicants that come in and that might not fit that 37-hour position that you have applied for, that you have put up on the workspaces, be open-minded, right? People come in all different shapes and sizes, and often less than 37 hours also makes a difference at your workplace if you think a little bit about it. You have to find these tasks that are nice to have and not need to have. And I know that every company have those. You just have to point them out, because this is where this workforce is actually quite amazing. They're there for less time at your workplace often when you look at part-time workers, but they actually have an amazing payout because they're eager to contribute to society and to your workplace and show that they're actually also human beings that matters. You have to look out for some of the local rules. In Denmark, we have some salary models that make it a little bit more attractive to have what we call flex workers into the workspaces, where some of the state or the municipality actually pays some of the salary, and the work then pays the rest of the salary. So there is some good salary models in Denmark, and we had a talk, me and Shannon, or Linda Shannon, that maybe some of the rest of the world needs to copy what we're doing in Denmark, because it actually works. Then you also, as a manager, have to watch out, because some of the HR systems do not align with part-time workers, and sometimes it looks very strange when you look into scales and vacation times and all these kind of things. Then I want to talk a little bit about building a safe work environment, because this is something that has definitely helped us getting Henrik in place into our job and into our work. So first off, what we did, we built sort of a safety net where we had a agreement with a good friend of Henrik that if he saw a mood swing or heard something from Henrik about work that was not working, he would be able to reach out to me and tell me that this is not okay for Henrik. We told Henrik about this because, of course, it shouldn't be a secret that somebody takes care of him, both inside work and outside of work. But this is really something that makes it safe. Then also, as a manager, find out where you can reach out for health insurance, or if there is a counselor involved, make sure you have those details at hand. So if there is anything, you can reach out to help. Then you have some basic work needs, and this is where stuff actually gets a little bit interesting, because when we look at Henrik, we can often see that he has a disability with walking, but that is actually not his main problem. He needs help carrying a glass of water. He needs some extra help in the cantina, get some lunch. This is small tasks for everybody to help with in the office, and it's not been an issue to actually help with that. So the big issue that you actually see on paper is not the big issue that you face in everyday life, and it's not actually a big issue, it's very small. So those ordinary tasks that he needs help with, or that anybody might need help with, is something that you need to think about. Then assigning a work buddy, this is also something that we would very much love to do for Henrik. We will come back to this, but it's a good idea to sign a work buddy, and I think it's a good idea to assign a work buddy for anybody new in the company. Then you have to think about your office facilities. You have to think about if there is an elevator, if you hire somebody in a wheelchair. You have to think about how many stairs do you have if you have a disabled person. And you have to be sort of open-minded about this when you sit at the job interview, because otherwise it's not going to work. Maybe you can move your department down to the ground floor if you want to help out with getting somebody with a disability into your team. And then special equipment, what we did was actually just ask Henrik to go pick up whatever he needed. So noise canceling headphones, special keyboard, a mouse that works for both hands. Well, he got it if he wanted it, right? So this should definitely not be an issue to find the right office equipment. And often offices also
provide special chairs if needed. It is possible to find that. Work-life balance. You should also include some room for health treatments and rest when you hire somebody in with a disability or a flex jobber or a part-time worker. For Henrik, he is off every Wednesday and he only works until 2 o'clock every day. So he has the time for rest and he has the time to go to physiotherapy to keep up with his paralysis. Then you also need to be ready as a manager when you're working with somebody that have a disability. It might be something like ADHD or something like that. But when ideas hit, they need to come out. Otherwise, you're not actually gathering on those golden sprouts that you put out, Henrik, sometimes. So we have the agreement that you can always write. I will always read, but I will not always answer. And this actually works very well. So if Henrik in the middle of the night gets an idea, he can always write it down to me in text. Then he knows that I've seen it, I'm there, and then we can talk about it at a later point. Sometimes you have to also remind me that, hey, you wrote something because it's hidden in some more messages, but it works. Then align with teams and departments because you need some clear instructions and expectations towards your new team member that comes in that is not like everybody else. And you have to limit those assignments from outside as well because it can be overwhelming, especially when you get such a talent as Henrik and people might fight over him, getting him to do stuff that he is an expert on, just simply because he has the knowledge and the interest in stuff like, for instance, RIPE. I'm not sure we have anybody else who follow RIPE to the same level that you do. So yeah, it's quite amazing to have you in here, but it's also, we need to shield you a little bit from some of our other departments. So where there are some room for improvements, limiting assignments. We have maybe sometimes limit the amount of assignment to where it actually becomes a boring workday and some people feel less important. For our job, for our company, we have done a restructure, which means that there is a lot of task that has become very crucial task that needs to be done right now, right here. And that means we cannot assign it to somebody that is not going to be a full-time worker. So it's basically moved from a nice to have to a need to have task. That's very unfortunate. At the same time, we also have a lot of politics in a lot of our daily tasks right now because we need to see where does this fit into our reorganization. Then assigning a work office body, I also mentioned this a little bit. Our team right now in Norlys is separated over multiple physical location, which means that even though Henrik is a part of a team of 11 people, most of them are actually not sitting in the same office as Henrik, meaning that it is a challenge to find a work buddy that is there all the time to help out. So yeah, but we make it work sometimes. You use somebody from another team, you use me. We make it work, but it could be better. And then, of course, the physical separation of our offices makes it hard to actually get a full overview of all the stakeholders that want to interact with our department, which might make some things very confusing and hard to get when you cannot go directly down to your stakeholders and say, hey, this is Henrik, this is your stakeholder, this is what we need to work with. You have to do it over a Teams meeting or emails and stuff like that, and it becomes a challenge. Quickly running out of time here. Okay, so there are some hidden benefits here because when you actually are implementing a safe work environment, you quickly find out that some of these needs are something that everybody needs, especially in our line of work because we are, to some degree, very special people, engineers. We are a special type of breed, and we all have something, strengths and weaknesses. And I, as a manager, definitely benefit from my team a lot more if they tell me what their strengths and weaknesses are, and if they dare to speak up about what is actually going on, so it does not become a toxic work environment. So I can actually help them perform instead of limiting them and say, hey, this is what the company wants. And if you don't agree, you can go hide in a shoebox because that doesn't work for anybody, right? And yeah, very valuable people that we work with here. Engineers are not something that is just
born every day, especially not with knowledge within the company. So then building this safe and work environment actually hasn't costed that much extra time once we start thinking about it. It's just collaborating with other teams. For you, yes, we needed to establish maybe one contact person, but of course it's not everybody that needs a safety net like that, but it doesn't really take that much extra effort once you have done it once. You can easily do it twice or 3 times in a row because you have those contacts to the health benefits and stuff like that. So I think this is something that should be done for every employee because it matters. That was it.
Any questions? Anybody? Anything on Miteko, Olka? No. Okay. Any questions? We have Rahul coming.
I just wanted to say, Henrik, that you're an absolute inspiration. It was a great presentation, and well done to your manager as well for keeping an eye out for you.
Thanks. Okay. Good. Anybody else? No? Okay, thank you.
Yeah,
thanks. Thank you both. So yes, that is quite inspirational and it's good to see. So anybody who's here in a high position in their own companies, if you are able to instigate change, please take that as a decent example, a very, very good example. Our final talk today takes us somewhere that I suspect is going to be one of those where a lot of people in this room are going to say, huh, is that me too? It sounds like me. That's what I've been experiencing. Actually, I have as well. Or is that what I've been watching someone I love is going through? You know. So Rob Lister, as many of you already know him here, has talked about ADHD before. He's built up quite a following post his last Right talk about being honest, his own experience, in a way that doesn't really necessarily happen at our technical conferences. And this time he's back with Paul Ginsberg. He's an ADHD coach, and together they're going to talk about rejection sensitivity dysphoria. And you may not have heard this term before, but I think you will understand what it describes. The intense, somewhat overwhelming emotional response to the perception of rejection or criticism. That way, that's how it shapes us, how you communicate, how you show up, and how invisible it can be to people around you. So this talk is about naming it, understanding it, knowing how to support your colleagues in your life who live with it. So Rob Lister, Paul Ginsberg, please.
Yeah. I don't know what I do. Press this button. I've got survey to go back. Yeah. It works. Oh shit, I haven't got my clock. I can use that one. That clock's
yeah, it's fine. Yeah. Okay. So thanks for that, Dinesh. You've said pretty much a great introduction. Some of you might remember I did a talk at RIPE 88 in Krakow. It was kind of me, talking about me and my experience with ADHD and going on that journey. And I had an amazing response to that talk. People still contact me about it and we still talk about it. So, oh yeah, this is something we definitely need to be talking about. The sort of follow-up to that, Paul here he's a friend of mine, is also now an ADHD coach, helping me work through some of these issues that I was sort of having with part of the ADHD. It comes as a package. So I'll let Paul introduce himself.
Hi, so I'm Paul. I'm an ADHD coach. I've got ADHD, I've got autism, I've got giftedness, I've got dyspraxia. It's a bit of a buy one, get a few free situation with these things. That's typically what happens. You don't just get one, but you get a few extra in the thing. I am a trustee for the Scottish ADHD Coalition, so we do some work here in Scotland, helping promote and helping support those with ADHD and do some campaigning work on that. But also I have a tech background. I spent 15 years doing IT, in particular Salesforce. I think that's enough for that one. Credentials have been explained, if not proven.
Okay, a little bit about my story, and maybe this might be familiar to some of you. I've worked for sort of many places over the years, and going back to toxic workplaces, some of them I might have thought are toxic. Others, when I think about it and when I delve deeper, you kind of think, is it really a toxic workplace, or is this all going on in my head? Am I making it toxic and it's not actually a toxic workplace? Or are my suspicions correct? Or am I being too defensive? Am I being too paranoid? Is my brain actually working against me here? And some of it's quite hard to recognize when it's happening. That journey that I've been on with Paul about, recognizing what's going on here and going, is this actually what's going on, or are you just being paranoid, or you're making reading more to this than there actually is? So maybe you've had this situation, the appraisal, annual review, the big meeting every year, and I dread this probably more than I should every year, of like, oh no, now someone's going to go through everything over the past year and tell me all of my failings and what I've done wrong, and this is an anxious time. Maybe you find it also an anxious time. Appraisals aren't always done well, and it doesn't seem to matter what they say. I always get worried about it. What is the point of an appraisal anyway? Is it to performance manage me out? Is it to gather evidence so they can fire me next year if I still haven't done it? Or is it just like a review, am I doing a good job? Is it a box-ticking admin exercise? Maybe, all of those things. But it's very difficult for me to work out what's going on. I get a huge overreaction sometimes to these appraisals. So the name for this, rejection sensitivity dysphoria, which Paul's going to talk about.
Cool. Okay. So we're going to do an interactive experiment in a moment. So you might want to get your phones handy, but we'll come to it. But let's try this. A message comes from your boss, someone you get along with, Paul, or whoever you are. Can I have a word with you for a moment? So what does your gut tell you at this point? We've given you three options. That there is an update about a project you are working on. That your boss wants to have a small talk with you about a minor matter. That something has gone terribly wrong and you are involved in some way. So there's a poll, we've got 30 seconds, so I'm going to time it. I've looked at the clock counting down. There's a poll with one question. It takes to a Google form. We promise to delete all the answers afterwards. You don't have to sign in if you're not in incognito mode, then you're not signed in. But anyway, you've got 30 seconds or 20 now, and probably slightly less than that. We'll see what the audience here and online, if you can type in the URL quickly enough, would say. If someone says, can I have a word with you, please? So the question is that there is an update about a project, that your boss wants to have a small talk with you, or that something has gone terribly wrong. Right, that's probably 30 seconds. Let's see what the results say.
The results in?
The results are in from the ripe jury, and they're not showing on screen, which is unhelpful.
Oh.
And I'm going to read out the results. Okay, so 14.6% say there is an update about a project you're working on. That your boss wants to have a small talk with you about a minor matter is 29.2%. But over half the audience here say that, over half the audience say that something has gone terribly wrong. Okay, like swapping between PowerPoint presentations. The world will just eat me up. None of you will look at me in the face because, so embarrassing. So anyway, for me, it's always number 3, that I'm about to be fired. Pure certainty with a dose of existential dread. Not that I've just let myself down, but the team down and the company as well. Possibly inconveniencing many people who were relying on whatever system I was working on. And that I'll never be able to work in the industry again. Particular examples of triggering phrases include anything that is nebulous, in that it could be understood in multiple ways, such as, I've arranged a meeting on Monday. Is everything okay? Colleagues' tone and simply not even being acknowledged can also have an impact. Some of you may think I'm kidding about presuming the worst possible outcome, but I've got a secret that I will share with you in a moment. First, to explain, I do love to talk about the positives of ADHD. I absolutely rave about them. And neurodivergence. I mean, Henrik's presentation just before us was incredibly inspiring and shows many of the benefits. But there does appear to be a yin and yang side to it for ADHD. Apparently, you don't get the positive aspects without some of the darker aspects too. They are all part of the same whole complete package. You don't get to choose. And this topic, rejection sensitivity dysphoria, or RSD, falls firmly into the darker side. So RSD, as Dinesh mentioned, is a strong emotional reaction to negative judgments, exclusion, or criticism from others, feeling like a failure, disproportionate to what actually occurred. And it is really common. And that's the topic we're introducing today. One particular respected professional puts it as high as occurring in 99% of those who have ADHD. So not everyone, so you can't make assumptions, but a hell of a lot of people. And it has an impact on those around us too. RSD can strike anyone though, even those without even those without ADHD. So no one should feel singled out. Okay, what's the reason for this? I can hear you cry. A common claim states that children with ADHD receives 20,000 more negative messages by the age of 10 than the neurotypical population. It's not true. And it was based on a non-scientific guess which went viral a long time before TikTok. The number is dubious, but the underlying concept isn't. There is robust clinical evidence which shows that children with ADHD receive significantly more criticism, correction, and punitive responses than neurotypical children. Too much, too loud, too messy, too forgetful, too distracted, too slow, too fast, etc. If you're unable to sit still or concentrate, then you're not fitting into the behavior that 80 or 90% of your peers manage. There tends to be consequences. And then because the corrections don't work, you either end up missing out or developing that hypersensitivity or both. Let's give an example from the tech world of the drip, drip, drip effect. For me, it was when I was doing IT support. It was passwords. Someone would phone up at least once a week to reset their login password. Once every few months is tolerable, but the same person, they couldn't organize themselves or thought it quicker to call me than press the reset button was rather frustrating. Small things that mount up. It gets annoying and it gets sensitive. What you can cope with once is fine, but regularly, without any reasonable justification, it gets to get really irritating. So imagine being told off for losing track of time, a relatively common ADHD trait. Once is okay, but to be told off regularly, and despite your best efforts, it then becomes a source of misery. We learn coping strategies, given the appropriate supportive environment, but the sensitivity, the damage will remain. And then, just for the joy, be extended. So you've got one area that's sensitive, but then anything around that also causes that sensitivity and pain. We become adults. Great. We learn our workarounds. But again, that vulnerability has become an encoded part of ourselves. How that vulnerability expresses itself is a whole different story. It can be shame. It can be anger. It can be panic attacks. It can be people pleasing. Or it can be avoiding situations where rejection might occur. Pretty bad unless, here's the silver lining, we are aware of this and develop coping strategies for dealing with RSD. We'll get to those in a moment. But first, there's a second ingredient to be aware of. If there's one thing that COVID taught us, is that we don't exist in isolation. that we should all be self-sufficient is a received piece of wisdom. Except this doesn't make any sense whatsoever. And here at RIPE, you absolutely know that. Everything from the moment you wake up relies on others. Turn the light on, well, there's a factory in China that manufactured that. And there's probably some wind turbines fairly nearby off the coast of Aberdeen for providing the power. Had breakfast? Well, thanks some friendly farmers for your cereal. We don't exist as a solo venture, never have done, never will do. So, with that in mind, what can we do about RSD as a team? Because we are not alone. The first ideal step is to recognize that this is happening. There is the quick emotional gut side to the brain, which is producing messages for your consideration. But the logical side is there too, to do error checking and filter out some of the fluff. So basically, pause and do a reality check when you're getting internal alerts. Speak the result out loud or write it down, and you will find your brain calming down. And also, if you spot, this wasn't in my notes, but I'm adding it, if you spot some of your friends who appear to be going down this path, help them pause and slow down and check what is happening. We need to train the body and mind to navigate towards healthy brain signals and learn how to dismiss some of the noise in the brain. Breathing out or box breathing calms down the nervous system. Shifting the narrative and helping others shift the narrative, going from I've failed to I've learned, is also very helpful. It can even be I've learned that I'm not currently good at doing this. So the next question is, what can I do differently to improve if I think it's worth the effort? But one of the biggest one of the biggest things for me is, oh, actually, no, I'm going to pass on to Rob. I knew that. So what's helped you, Rob?
It's helped me
with
definitely
RSD.
some of these things, learning to recognize what's going on, learning to recognize what's happening. It's taken me a long time to sort of finally realize and sort of take a step back. Don't click send on that email. You know, give yourself 20 minutes or sleep on it and go, okay, if I still feel the same way about this, I'll send it. But actually, a lot of the time, I'm like, oh, actually, no, I've totally read too much into this. Yeah, time to think about it. That's definitely the thing that's helped me the most.
Thank you. Lots of things, but we're running out of time, which is part of the issue. And I am sitting with the kind of perfectionism and just holding and saying, is this good enough? And that is a conversation I have with my RSD quite often. There are other ways, however, such as communicating your needs clearly. So here we get into some more practical steps. When I go into meetings, I train others to let me know what the meeting is about in advance, so I don't overthink it. And that training can be subtle. For instance, can I have an agenda the day or two beforehand? Which is actually an example of reasonable accommodations. You asking for something, and then your employer learning how to meet you midway. And you know what? Those agendas give me time to prep and work out my thoughts. So actually, the meeting probably goes better than it would have done otherwise. With my autism hat on, I ask people to be clear and direct. Then I know where I stand and I don't second guess. This removes a lot of assumptions and the risk of misinterpretation and misunderstanding. It's a question of practice and learning how to trust others, as well as yourself. And objectively, we do improve just about every single day. It doesn't do any harm to take a moment to stop and appreciate it either. But the effort required is not just from you. I want to be clear. There's also an onus on the workplace to create conditions for psychological safety too. Rob's going to touch on those in a moment, but just to say that we've included a few extra slides on this topic, should you want to download the deck and learn more. There might have been a little ADHD urge to include all the details, but I understand the conference is only 5 days long.
Okay, reasonable accommodations in the workplace. I won't go through all of these, but it is a question of discussing it with your workplace. It looks like different things for different people. It's very individual, situation specific. What works for me might not work for you. A good tip I heard is to present this as an experiment. Just say, let's try doing this and see what works and what doesn't. If it works, great. If it doesn't work, well, we've learned something. It's all individual. And also required often under law. If you tell your employer, I need a reasonable accommodation, they kind of do have to consider it. And yeah, it's all about that. And there's some other extra slides at the end here, which will go into a bit more detail on accommodations. But it is definitely worth having that conversation. And a little bit of now sort of coming back to toxic workplaces, how do we tell if we are in a supportive environment or not? And some of the signs that I've sort of noticed are, if there is a pattern of repeated situations, gaslighting, a blame culture, if there is, your employer seems less willing to make the reasonable adjustments, or they sort of dismiss it as it's all your problem. This is all your problem. This is nothing we can do here. It makes a problem about you, nothing to do with the workplace. That is borderline toxic. And also the RSD itself amplifies these problems. It makes the whole experience worse. So if that's happening, maybe toxic workplace. Maybe a not toxic workplace is actually, there is some acknowledgement of the issue. You have the conversation, but want to be non-judgmental about it. And they want to put in things for you to make reasonable adjustments that work for you. That is not a toxic work environment. Hard to differentiate sometimes when a lot of this is going in your head, but finding out what is working, what's not working. If it's a team issue, it's kind of something that everybody sort of needs to be aware of, needs to work on. Okay, so stuff that's helped me, practical help. I do like sort of doing a bit of reading and getting tips and things from other people. So got some links here about what's helped me. The Neurodivergent Office Survival Playbook. I love this because it's really short, very succinct, just gives you brilliant ideas like this is what this looks like, this is what to do, or this is what you could try. And I thought it's sort of my ADHD self. I would highlight the bits that I thought important to me. So I got my highlighter pen and started highlighting everything. And I thought, I am not to be trusted with highlighter pens because ADHD people, cannot do this. So yeah, I'll end up highlighting the whole book in the end. But yeah, a really good guide, very short, very easy to follow. It's £7, but you can have a little flip through this one if you want to buy it. And also, if you want the proper manual, the ADHD field guide for adults, really nice read. It's a bit of a book, but there's nothing left out, and you can just dip into any page you want and read. It's really actually quite comprehensive. Why does everybody hate me? I was reading that on the train on the way up here. So why does everybody hate me? People sort of give me. But yeah, all good books. Paul, recommend this.
Yeah, so I can talk to the video. There's an hour's deep dive by the father, like the person that came up with the term RSD. This is still a new topic. The person that came up with the term rejection sensitivity dysphoria is still alive. So we are learning so much, and the awareness is growing. It's actually, in terms of ADHD and neurodivergency awareness, it is a good time to be alive. The 2020s aren't that bad. So this gives you an hour's link to a really deep dive podcast on it. What else is there? So we've now come to the summary. 10 seconds. Yeah. RSD is really common. Take a pause. Your instincts, so some takeaways. Take a pause. Your instincts are just one data point. It takes practice to recognize RSD. And it goes back to like workplace accommodations. It's an experiment. Don't be afraid to try. Some things won't work, some things will. And asking for support actually benefits everyone. As we've already heard a couple of times today, everyone benefits. So don't be afraid to give it a try. And I think that probably ends us with the clock now going up in a rather confusing fashion. Thank you very much for your time, everyone. Thanks to welcome to Ganesh too.
We've actually gone over time, so apologies to the AV team, the fantastic AV team who are going way into their dinner time for this. Won't keep you much longer.
We'll say if people have questions, Bob and I are I'm certainly quite happy to hang around. And
I'm happy to take questions or comments for 1 or 2 minutes or something. Anything?
I've got the manual ready.
Okay, here we go. We got 2. We'll just keep it to 2 at the moment. Nothing on Meet Echo or Olga? No, okay.
Thank you, Janusz again. Thank you very much for this very interesting presentation. I think I learned a lot about this problem from you, and actually it just reminded me of one thing which probably relates to RSD as well. It's Hanlon's razor. I tried to quote it exactly. Never attribute to malice that which is adequately explained by stupidity. So we have to keep in mind that things may not be that bad just because we feel they are so bad. I may be wrong, but
my career, this is where it gets tricky because the world is not a simple place. 19 times out of 20, that's correct. It's the 1 in 20 and trying to navigate between the difference is really hard work. And actually, I'll say that ADHD people and neurodivergent people tend to be more vulnerable because when someone shows an interest in us, that's an interest, and that's actually a relatively positive thing. So navigating that and understanding when that borders into toxicity or just things that people are doing with good intention that are good for neurotypical people, but actually not helpful for neurodivergent people is very, very hard. So again, the malice versus accident versus other things, it's complicated, but yeah, in principle, I 100% agree.
Thank you.
Yeah, it kind of goes back to thinking about what is the simplest explanation here. Have they just sort of forgotten to copy me the email? It's usually that, in my case anyway. What's the simplest explanation? Are they really, is it really this worst case scenario I've made up in my head? Or most of the time it is kind of not that? Yeah.
So Tobias Fiebig, TU Wien, and I know I don't look like it, but I'm a manager, like a people manager. And there's also this other side of the coin, especially if you yourself might not be as normal as might be expected of a manager. Teams tend to accumulate a bit close to how their managers are, or in other terms, if all your friends are neurodivergent, you're the only normal one. I do have some news for you, which is something to be aware of as a manager. So once it's about team composition, and maybe then having people who do have skills that can help one as a manager or the rest of the team to deal with these issues, if you as a manager might not be able to do it. And the other thing is, if you do happen to build a group team of people which are all a bit neurodivergent, it might actually become difficult for non-neurodivergent people in the environment.
Yeah.
But surprisingly, the same procedures seem to help them as well.
Okay.
Yeah. Nothing to add to that. Absolutely. Okay. Diversity is amazing and it works in all forms.
Right. Rob, very quickly, please. Yeah.
I can catch up with Rob afterwards.
No, go ask a question.
Thank you for that. Is there one thing that employers can measure against to determine whether this is somebody being overtly sensitive versus somebody who needs help?
I don't. Well, if someone's being overtly sensitive versus do they need help, the answer is yes. I would say it's the trickiest thing, and this comes back to HR, is navigating and having authentic conversations. If people, and I think this is a problem in British culture, certainly versus like the Netherlands, where I spent 7 years, is that when we see problems, we don't have conversations and it escalates and spirals. Soft skills is not my strongest point, but having those conversations where you touch base with one another and say, what can help you here? Or, it's like, open the lines of communications, the alternatives are worse. That's what I would say.
Okay. Thank you.
Thank you.
Thank you. So 3 talks, 3 very different stories. It's all about what happens when systems and cultures around us make it harder than it should be. So just 2 more minutes, really. I'd like to say something before we close, and it's if you've heard anything here today that resonated, if you recognize yourself in any of it, do not sit with that alone. Talk to someone, reach out. The people in this room are actually more open to that conversation than you might think. And we've just spent the last, an hour and a quarter proving it. Keep the conversations going in the hallways, over coffee, online, and that's how things actually get done. Not in sessions like this, as valuable as it is, but in the smaller moments afterwards when you continue those conversations where someone feels safe enough to say, me too. So thank you to Henrik, to Peter, to Rob, to Paul for their honesty and their generosity in sharing what they shared today. And thank you to all of you for being here and making this possible. So you are not alone. None of us are. Thank you.